Mhm. Hello, good morning, ladies and gentlemen. I would request everybody to please be seated and people outside, please come. We are ready to start the session. Good morning again, everyone. It's my absolute pleasure to welcome you all to India Heat Summit 2025, hosted by Climate Trends. We are hugely grateful to the National Human Rights Commission and National Disaster Management Authority for associating with us on the event. While the weather systems have brought much attention to the early arrival of monsoon in the country, but we know that an anomaly of 1 year and lower temperatures today doesn't mean that heat isn't a threat to us. Keeping that in mind, over the next 2 days, we will bring together leading scientists, policymakers, development experts, and civil society voices to explore solutions for growing challenges of heat stress in India. It has been absolute pleasure to have so many eminent speakers agreeing to join us here today. Without further delay, I would like to kickstart this morning. Some ground rules before we begin. We would encourage you to engage with the ongoing conversation using our official hashtag India Heat Summit. We will try and keep few minutes after every discussion to allow some questions from the audience. And those joining us online can post their comments in Q&A section on the Zoom chat. Please join me in welcoming Ms. Aarti Khosla, Founder and Director of Climate Trends, to deliver the welcome address and set the context for this important gathering.
Morning, everyone. Distinguished speakers, guests, participants, friends from media, students who've taken the right effort to be here this morning. A very warm welcome to everyone from my side as well. As Kartiki said, it's complex times. When we started planning for this workshop, heat was so in our faces and so prominent across the country that it felt like it is the single largest threat that the country is facing at that moment. But here we are, not only do we have complex threats, trade, escalations, climate, but we are also at a time that in the last 72 hours, we've seen the kind of mayhem and early onset of the southwestern monsoon has caused in the western parts of the country. I think the short point is all of us who are sitting here are quite aware that we cannot wait for certainty on climate impacts to happen. It will be uncertain. That's how the science is going to be and will be. But we've come at a point where climate impacts, especially heat, are no longer climate issues alone. And that's really the reason why we have hosted this workshop. And we have brought together people not just from climate think tanks, academic institutes, researchers who are top scholars in the country, but we've made an effort to socialize this topic far and wide so that we are able to reach out to those who we haven't been able to reach out to before, and we are able to draw some interconnections, because pretty much it is quite clear that not just it's not an environmental threat alone, it's also a threat which is quite closely intertwined with how our economy and our social fabric, our public health parameters are looking or will look in future. So that's really the purpose of this meeting. Climate Trends is also an organization which believes in interacting with a diverse set of stakeholders to make sure that people understand the climate connections. Our work over the last 10 years of our existence has largely been to bring together public understanding as well as policy making in the areas of climate more and more together, so that there is coordination across key departments on matters of air quality. There is linking on how heat and power demand is being understood in the country. There is greater understanding of how energy transition can be just and equitable, and there is a way of understanding climate action at an international level and the rhetoric around it with what is happening in country at a national, local, and regional level. I think in the interdisciplinary approach that we have of not just looking at climate as verticals of mobility, energy, agriculture, forestry, and so forth, but just as a way to mesh across each other, we've also taken a lot of effort to make sure that the narrative on climate remains front and center of public mind, and that's important in terms of what Climate Trends brings to the table. I think that's our contribution. I know that there are experts over here, and we've partnered both with the National Human Rights Commission and the National Disaster Management Agency, and the sole purpose of having made that attempt to bring those two partnerships has been to create that impression that this is not a subject which has to be discussed in silos, and therefore needs to be widespread and discussed more widely. Can I get the In the interest of time, I will not talk a lot about how the climate changes are happening in the world. All I will say is we are only looking at first order impacts at the moment, where we are probably talking about the rate of change. We haven't even come in the world where we are talking about second order derivatives, where you're talking about the rate of change of the rate of change. That will also happen. This slide merely shows that India is on the global hotspot when it comes to wet bulb temperature, which is a combination of land temperature, relative humidity, as well as the temperature of the air, which is essentially what IMD started to put in their weather updates and forecasts as feels like temperature. It's 35 degree, but feels like 42 degrees. And it's important to understand that distinction. India, also several studies like CW and others have shown how 7 out of 10 districts in the country are under heat stress and will continue to be so. The point that I want to make over here is that globally, as you are seeing the climate conversation developing, it's becoming more and more clear that the targets that the world set of keeping well below 2 degrees or maintaining global temperatures to 1.5 degrees are nearly at an offshoot. We can wait for another 10 years for data to come to show that the offshoot is permanent or not. But whether or not 1.5 degrees are attainable, I think it's quite clear that climate goals are crucial, because climate impacts will be local and even hyperlocal. This is because we are talking about heat specifically, this is just a visual representation to show how it's a vicious circle, but it literally starts at the point of extreme heat, which can then lead to a cascade of effects in terms of how people will get impacted, how monsoons will be erratic, how public health systems will be under pressure. And as such, we have a very narrow way of tracking public health parameters when it comes to heat stress. Uh, just some numbers to put things into perspective. You all can read this, I don't have to for you, but just in terms of the importance of the subject of heat, I think it was last year or before that, when the Reserve Bank also put out its own analysis, which said just as early as 2030, there will be about 4.5% loss of GDP when it comes to just the impacts of heat stress and erratic monsoons in the country. That's quite significant, and I think becomes even more important and a socio-economic problem when we have over 80% of Indians that are employed in the informal sector. We live in cities where gig workers are seen more and more. There are no rules for street vendors, gig workers, construction workers, and the impact that it's going to have on labor and economy is just going to increase. Again, not much to labor on, but to just convey my point that the connections are really multidimensional and all pervasive. We are talking about an increased heat demand. Just in single year, Indians are buying 15 million air conditioners. Over the next 10 years, there is going to be 150 million ACs sold in the country. India's cooling action plan is both ambitious as well as necessary, whilst at the same time, the power peaks are shifting. We are changing from a country with an afternoon peak to an evening peak where people want to come back home, and in the hours after work, the air conditioner use is rising. But similarly, none of the impacts should not be addressed or are not important. And I think you see them all here in terms of just the health risk extreme heat is posing: infant mortality, GDP loss, not to miss sea level rise, which is the basis of all of this problem. And we are seeing how the 10 degrees drop of temperatures in may look very present in Delhi, but is indeed a result of an odd interaction between several weather systems, including the western disturbances, and the impacts of loss to life and property have not been minimal just over the weekend. I will keep going in the interest of time, so sorry if you feel that I'm rushing through some of the slides, but just the fact that when heat becomes a silent killer, we will also have to find silent opportunities. I think in this world where we will find more wrenches than opportunities, it's important for us to understand, just to make sure that we are able to look at the solution side and bring to the table as well answers and not just problems. There is just some numbers from a World Bank report which shows how much is the opportunity just if we use innovative methods of cooling, alternative and energy efficient technologies on cooling, and we will discuss more of this in our panel. I put this up here because there is going to be friends from media and some journalists who are covering the topic, who are in the room now, and who we have invited specifically for them to understand that this is not just narrative and it's not just opinion. This is pretty much evidence now, and it's important to look at this topic not just as an environment beat, but as something which interlinks as well to other important areas, and therefore important that in editorial discussions, that's how it features, that it's not just an environmental report. It's something that's far more interlinked to industry preparedness, to how our companies are reacting, how water scarcity is being managed, how heat response is being dealt with in our public health systems, so on and so forth. We did some numbers in terms of how social media is picking up the story of heat in the country, and this is just to give you an idea that in the 1 year that we tracked between last year April, May, and I think this year May, the numbers that are showing here show that people online in India are not talking about heat as just a climate event alone. People are talking about it in terms of cooling demand, in terms of rising costs of power bills, and in terms of the associated impacts. I mean, I think that comes with a caveat that people who go on Twitter and Instagram and post about these things, you may well expect them to be graduate level or higher. I think I'm making a very wide assumption here, but you know the connection that people who understand these things in a certain way also understand them not just as climate impacts, they understand them as impacts on their share of wallet, on how people are leading on their daily lives about. Uh, I wanted to put this up because we are also part of an international global network, which is unique in its abilities to understand climate and public narrative. And we undertook a study which essentially talks to people to check how concerned they are about climate change or how worried they are on climate change. For the moment, this doesn't cover India. That is why we don't have it, but you see it covers some of the countries still, like Brazil and South Korea, and some obvious ones like UK, Canada, etc. And the numbers are quite high overall, which basically shows that when you ask people, do they care about climate change? Are they concerned? Do they think their jobs will be impacted, their health will be impacted? The answer is an overwhelming yes. People do think that the impacts are there. I think what's missing is the issue salience. Do you think that climate is a top priority among the top three in your country? No, very low numbers, because some other issues take precedence. And I think for us, the learning over here at least was that it's not important whether climate is the top three issues or not, but it is very important that climate is impacting the top three issues, whether it's about jobs, whether it's about public health, whether it's about economy. Climate is impacting each one of those things. And therefore, whether or not it is salient, I think it's quite salient because it sits as a threat multiplier and across all of the issues in any of the markets, including in India as well. Uh, well, this is a diagram that we like, but perhaps I will skip this for the moment. We have a session on finance. Basically, this is our interpretation of what climate finance is. What is coming in terms of international climate finance is drops. Where it's falling is a half-filled bucket, and the bucket is, of course, leaky. And this is the nature of what climate finance is. There is zero finance that's available in the world today on climate. You may try and look at how to call it innovative, look at putting stuff together, maybe talk about, special drawing rights from the World Bank need to happen and reforms of the multilateral banks need to happen. Again, I'm not a finance expert. We are having sessions where we will talk about what's the resource mobilization going to look like. But I think in the tripod of various kinds of disasters that the world is looking at, it's going to be very hard to rely just on international finance to meet our needs. But India is nearly the fourth largest economy after nearly overtaking Japan. We are at a moment where we can set the terms of where finance is going to come from. Part of it will be domestic mobilization. A lot of it will have to be Indian corporates, companies, business sector. But there is hope, there is opportunity, there is also the ability. It is just that we have to carry those conversations in that context. Uh, I will pause in 30 seconds and just to say that thanks very much for everybody who has taken time to be here this morning. Our purpose for this meeting is not to show what is not happening. Too much is not happening. Our purpose is to just show how is it that solutions can come together. What you see here is literally just a laundry list of the kind of issues that we need to think of. We need to think of urban governance issues. We need to think of labor and regulation issues. We really need to think of resource management issues. And we need to think as well of making sure that whatever we have so far, I think experts will come through the day where we will talk about heat action plans. Many heat action plans have been made. NDMA is going to be in the room and we will talk about what's the level of disaster preparedness. We have all those things. I don't think that those things are connecting to each other. Our cities learning from each other when it comes to heat action plans? Can we facilitate some of that? Our industry prepared for water management? Can we bring industry together and insurance sector together and try to look at those things? I think that's the mental application we have done. I hope that our ability to bring parts of our ecosystem together in a very discreet way to discuss these things is going to be successful. And really just look forward to both listening as well as learning from what happens over here. In the end, we are living in weird times and it's not going to stabilize by the looks of it. All it feels is that whether any kind of disaster it is, whether it's trade or it's terrorism or it's climate, we are not in a moment where we cannot address and we cannot act. We have to address it. We have to act. When it comes to climate, I think it's quite clear. Every degree matters, every fraction of a degree matters, and every life matters. That's the small contribution that we will make by talking about heat in the next 2 days, and perhaps go and submit it to relevant ministries like Ministry of Power, Ministry of Environment, and and Ministry of Renewable Energy, to just bring together everybody's mind on this important topic. I will pause and will hand it back to Kartiki to take us through the proceedings of the day. Thanks very much.
Thank you, Aarti. It is now our privilege to welcome Sri Bharat Lal, Secretary General and Chief Executive Officer of the National Human Rights Commission of India, to deliver the keynote address. A seasoned civil servant with more than 35 years of experience, Sri Bharat Lal has served in several pivotal roles across government. He has worked closely with Honorable Prime Minister of India, Shri Narendra Modi, since his tenure as Chief Minister of Gujarat, contributing to the governance reforms and development strategy. Notably, as the architect of the Jal Jeevan Mission, he played a key role in shaping one of India's most ambitious and transformative programs aimed at ensuring safe and adequate drinking water through individual household tap connections across the rural world. We are honored to have him here today to share his insights.
Good morning, everyone. Aarti ji, Soumya ji, and my colleague, friends, delegates, ladies and gentlemen. First and foremost, let me apologize for one thing, that I have to leave this place around 10:45 because I have got over 11 o'clock meeting actually, and I have to reach there. They have to be remain present physically. But at the outset, let me congratulate all of you, and especially Aarti ji and their colleagues, for organizing this meet, this dialogue, this discussion, very, very important. To the extent that only last month, National Human Rights Commission issued a letter to 11 states, basically, to take proactive steps to protect people who are vulnerable, and especially people who are, whether it's a homeless or elderly persons or people who are going on work. So as we all understand that human right over the years the domain has expanded actually. And whether it's a climate issues or it's a heat or it's a during winter, basically cold waves, they are part of right to life, Article 21 basically, and National Human Rights Commission takes up this issue in this spirit. Let's see India. I think here most knowledgeable people are here, but just imagine in 30 years, 24,000 people died. If just see one figure here in India. And if you see that 30 days roughly in this country, in fact, we keep on, I have long experience or less opportunity to work in water sector. So always we see in India, basically, that paucity of water is the limiting factor in our socio-economic development and economic growth. As a country having 15 to 20 days, rainy days, and 365 days, you have to manage from that, whatever precipitation you get. And if you leave glaciers, the whole central India, southern India, western, it is based on those rainfall, and whatever you collect, use it judiciously. So allow me to give just a little bit personal background that I spent my childhood in Allahabad, Prayagraj, and we knew only two issues that time. Floods during monsoon because of Ganga and Yamuna. And second was heat waves. During summer, yes, there would be there. In my working life, I went to Gujarat. And it was in I joined civil service 88 and 1990. Imagine 85 to 87 were basically drought years, 3 years, consecutive drought years in Western India. And Rajasthan, Gujarat, and part of Maharashtra was badly, badly impacted, actually. And you can think about that economy, health, cattle, livestock. So we have seen that the worst part of, worst stage of basically kind of climate impact in a state like Gujarat. In fact, from 71 to 2001, 3 consecutive census operation. In many blocks of Gujarat, population went down instead of increasing. And one of the major reasons for migration was basically, you can say, paucity of water and of course heat waves, actually, Now, if you see last year, imagine last year 100 people died as per report available with us, because data is also a problem, as you all know that, at the moment there is whatever we get data is a huge challenge. So last year 100 people died as per report available with us. But as we all know that wet bulb temperature 35 degrees centigrade, I think in many, many areas we are crossing that limit, or we are in that stage of, where basically this is a one challenge which has come up, actually. And without artificial cooling, I think, especially one segment of society, productivity is almost zero, Well, if you see the frequency of heat waves from 4 to 5 or 6, basically it has come to 10 to 12, So it means frequency is also rising. And if you have seen the map, I was looking at the map, basically, see, Western India, the whole Rajasthan, Gujarat, Maharashtra, part of Karnataka, then Andhra Pradesh, Odisha. I mean, these are the states which are affected. Now, today, this discussion basically focus on basically challenges and opportunities. And in this context, let me just give you some very specific point, actually. So what we have identified at the commission, basically, that there are 7 very specific challenges. We worked, actually, we started working since last 2-3 months. We are working on this thing, basically. One is absence of occupational heat exposure data. This is one issue, basically. If you don't have that data, how you are going to have a very concrete policy, very actionable point, And this is one issue we are highlighting and we are working on in this thing. Second issue we identified is poor socioeconomic vulnerability mapping. There are certain segment of society, their exposure is basically their whole livelihood. Everything is dependent on, this thing. And because these are the marginalized groups and most vulnerable groups. And that's why for National Human Rights Commission and for all of us, basically, it's very, very, very important, Then basically unstandardized heat risk indicators. If you see the indicators which have been identified, actually, I mean, well, I think there is need for further working. And certain reports, basically, we have seen that, whether it's coming from IPC, AR6 or WHO, I think there are challenges. The fourth issue is inadequate urban heat island mapping. In urban areas, basically, this mapping is not taking place, except there are some noble exceptions. I was in Gujarat and in Ahmedabad, I have seen the kind of things they have done, or some parts of Hyderabad or Nagpur, But I think there is a fourth issue about urban heat mapping, The other sixth issue is non-integration of real-time meteorological and health data. See, most of the data are basically not talking to each other. In fact, when I was working in water sector and Jal Jeevan Mission, we realized that clean water, sanitation, and health surveillance, these 3 data are not talking to each other, basically. And that was one of the most challenging waterborne diseases. If data is not basically, not interacting with each other, and you are unable to extract it data, and take dashboard or whatever information we make available to researcher and advocacy groups like you, if data is not in that format, the data should be in that format so people can make some sense out of this data, actually. So this one aspect, that public health data, basically health data and meteorological data, it must be interacting with each other, and people should be, researchers should be able to extract this data and work on it. Well, similarly, Aarti ji gave some number. Actually, I was looking about air conditioning and cooling and all those kind of things. But look at the big picture actually when we are going for policy making. So scarcity of cooling, demand and access data. Again, when you are working in basically climate field and you are talking about adaptation and so I think this one data, that cooling demand and access, this data, if it is available publicly, I think is going to be very helpful, basically in setting the agenda and for advocacy. And lastly, the seventh issue which we have identified is limited use of remote sensing and satellite data in local governance. See, when many of us have spent some time in Western world, and of course they have their own challenges. But just think about it: the people get up in the morning and they look at the data actually, weather forecast, and they plan their day. But just go think about it at national data. 3 days back, I was looking at the data actually that when this storm took place here in Delhi, and next day morning, because I got up at 2 o'clock and I was looking, and I just went back actually, that what kind of forecasting is done, and local self-government, are they sensitized and they are issuing that kind of advisories or alert or this thing? No, we are unable to do that. So this limited use of remote sensing data, interpretation, and basically using this data by local self-governments in governance, I think this is the seventh issue so far as we are concerned. Talking about opportunities in mitigating heat risk, we identified 10. There could be a number of activities, and I think you can, when you discuss, you'll be able to firm up, basically. And I look forward, actually, Commission looks forward, basically, to having this kind of information. But we identified that something very doable, very, very preliminary things, So 10 activities or 10 opportunities we identified. And first is that was expanding and scaling up this heat action plan. I think this need to be expanded. This need to be, if we have to work with it, basically, it cannot be limited to few cities, few states at few level. If you take Ahmedabad or Odisha or other places, I think. But I think there are opportunity. There is an opportunity. In fact, Ahmedabad, I have noticed myself that mortality went down after this. This thing, mortality went down by 30 to 40%. I don't have exact figure, but I think mortality in that district, that metropolitan area, it went down actually. So it means heat action plan, it should be further expanded. It should be taken, at different level of governance unit. And I think we all have to work on that. The second, basically, again, from challenges originate, that digital heat and health early warning system. Again, if these two data are interconnected, people start analyzing, and local self-government start basically issuing advisories and this thing. So basically digitizing the whole heat or weather, this data as well as the early warning system is going to be very, very helpful. Well, again, data-driven vulnerability mapping for integrated interventions. So vulnerability mapping, whether it's a state level, then district level, and the localized area, if time zone, we can do this mapping, and then intervention are planned in advance. I think we can develop some kind of infrastructure, some kind of advisories, basically, especially high-risk zones, and targeted support activities, whether it's a cooling centers or hydration points, those kind of activities we are looking at. The fourth point which we are trying to work out is investment in passive cooling infrastructure. Let's understand that if 90% your workforce is basically informal sector and people are going out, just imagine. In fact, one issue we identified, that gigs workers, we take pride and pleasure basically that food is delivered in 10 minutes. Think about it, our roads, our kind of civic sense, and these young boys, they are just simply on one motorcycle running from one place to another place, that within 10 minutes, 15 minutes, we have to deliver. Whether it's a high temperature or traffic congestion and severe penalty, I would say, severe penalty, gigs worker. So I think this part from human right angle, I think this is one part basically where investment in passive cooling infrastructure is going to help, whether at individual house level or public places. I think this is one, and I was told, I have seen that in Hyderabad, I think some good work has been done, and those kind of, activities we are promoting, and we are encouraging that this opportunity should be used. Well, then harnessing the India Cooling Action Plan, which basically offers expand affordable. We expect that it will be expanded, and energy efficient cooling access in climate responsible manner. I think this activity will be further taken up, and it will be expanded. And if the presentation I was looking at it, that more than 16 crore vulnerable people are there actually. So I think this is one area where we can enhance productivity, we can improve quality of life, we can save mortality, we can save lives. I think those kind of things, And one of the MOEFCC report basically indicating 2019 that this reduced cooling energy demand by 25 to 40% by 2038. So I think we have to work on, Well, public awareness, as we all know, that any issue, whether it's for policy making or for implementation, public awareness and behavioral change campaign, I think it holds the key. In any democracy, I think awareness and people's demand, it makes a hell of a difference, basically. And I think our kind of society, where with thriving democracy at different level, I think this is one area where I would urge civil society, NGOs, and other group that kindly basically contribute your mind in basically raising public awareness through different means, and especially in vernacular language at local level actually, because democracy has its own way of working, and if at ground level, if there is a recognition of certain challenge and certain problem, I think the government or political class immediately act on, And of course, I think people need to be educated about their own personal level behavioral change, about whether it's a hydration or work rest cycle or use of shaded spaces, those kind of things we can work. In fact, in Ahmedabad, it was used basically this mosques and temples. In fact, they were used for behavioral change actually, because they have some kind of impact when they talk about this kind of thing. So such innovative methods have to be found out, and we have to work on it. The seventh opportunity which we are talking about is integration of occupational heat safety and labor laws. I think Aarti ji has pointed out, and again I would say yes, our labor laws, our labor code, whether it's a timing or it's a protective gear or outdoor workers, their facilities and protection, we have to. But most important is informal sector. See, formal sector is still, much better, but informal sector actually it creates a lot of, challenges. And as I know that ILO, but of course Niti Aayog have also done some exercise. Basically, they have developed some kind of framework. And I think we need to work on this framework for basically improving climate safety standard as well as productivity. The eighth point is leveraging remote sensing and AI for urban heat mapping. Because as we all know, and China is a classic case basically where urbanization has started posing different kind of challenges in heat wave. So remote sensing, using remote sensing and AI, basically urban heat mapping is a very, very important opportunity, and I think India should avail this opportunity and should work on, And in fact, a lot of that different imageries are available basically, and different models are coming. In fact, yesterday only I was looking for different kind of models, and I can see that those kind of models are basically coming in the market. So I think there is a scope for this kind of mapping, followed by some micro level at local level, localized intervention. Whether it's a zoning investment adjustment or reflective roofing or tree planting or different kind of activities can be planned by local self-government. The ninth point is mainstreaming heat risk into urban planning and building codes. I think some work has been done. Basically, our energy conservation building code and smart cities mission offer some kind of policy framework, but I think it needs to further work on on this thing, and basically integrating these thermal comfort requirement and municipal bylaws. I think it's going to help basically in concrete action and concrete outcome, basically. And lastly, the opportunity which we see that international collaboration and climate finance. This is one area basically where I think, see, as it has been said, that we all work in silos. Individually, we are brilliant. In our field, we are working very well. But I think this time has come actually that we should be able to integrate, and we should be able to work closely with one another. So when it comes to multilateral banks or funding agencies and create climate finance fund, I think there is a need for this kind of adaptation projects and activities. And I think time has come that there's a technical assistance are unlocking climate financing, but climate, this heat waves and heat, this thing which has to be given importance to, this thing. Well, while closing, I think so far as the National Human Rights Commission is concerned, for us, basically, we consider that this is one of the very core function of the various level of governance, whether at the municipal level or our panchayat level or at the state government level. It's no more a luxury, actually. It's a very, very, very important, activity for government. And it's our obligation, constitutional obligation. I really appreciate that right to life, which is like clean water or improved sanitation or public health. So similarly, saving people from heat waves, I think it's a constitutional obligation, and whether it's a human right or equity or inclusiveness, it must be kept in mind that government and institutions are basically working and for climate adaptation. Well, as we all know that this one issue basically, and especially in our kind of country, where basically more than 46% of our population our workforce is basically in agriculture and supports 70% activity. Kindly see that how it is interlinked with livelihood. It has a very, very huge linkage with livelihood of people basically, but simultaneously their dignity need to be preserved, protected to build a very resilient economy. Yes, we have become fourth largest economy in the world, but while we're moving upward, I think dignity of people, this labor force, these workers basically, especially unorganized sector, even agriculture, farm labor, I think we have to keep in mind. Friends, while closing, I'll just appeal to you that let's work on aligning policy and science, because most of the time, at times we miss basically science and part, when we are working on policy. So let's align on policy and science, investment with impact, not merely investment that, okay, number, but I think we must go for just monitoring and looking at the impact. And third part is that technology, but traditional knowledge. Yes, we adopt modern technology, but our traditional knowledge, traditional practices, it must be dovetailed, And well, we have to create a kind of environment where union government, state government, local self-government, NGOs, academic institutions, and citizens basically go on and own the challenge and work for the solution. So wishing you all very best, and I look forward to the outcome of this conference. And certainly from National Human Rights Commission, I think we'll be looking at the recommendations and outcomes of this conference, and we'll be certainly working with you in basically contributing our might in solving this challenge. So have a wonderful day. Thank you very much. And thanks, Artish, for having me here. And friends, please pardon me because I have to leave. I have no choice actually, because there is going to be one in the commission. There is some what you call cases basically come where everybody has to remain present. So I'll push off. Thank you. Have a wonderful day. Thank you so much. Thanks.
I'll quickly request Aarti to present a small memento to Bharat Lal sir. Thank you, sir. Thank you so much for those insightful words and setting the right mindset for us to take forward during this conference. We are very delighted to have you here. We now begin with our special panel discussion moderated by Ms. Aarti Khosla. Joining her on this is high impact panel with eminent speakers. I'll start with Dr. Krishna Vatsa, member NDMA. Dr. Vatsa is a globally recognized expert in disaster risk reduction. He has worked with UNDP, World Bank, and national institutions on urban resilience, early warning systems, and capacity building for climate-induced disasters. Dr. Mrityunjay Mahapatra, Director General, IMD, popular known as Cyclone Man of India for his accurate cyclone forecasting. Dr. Mahapatra leads national weather forecasting services and contributes significantly to climate services, resilience strategies, and disaster preparedness in India. He also serves as third Vice President of World Meteorological Organization. Mr. Ashish Khanna, Director General, International Solar Alliance. Mr. Khanna has over 26 years of experience leading energy sector development in private and public sectors in more than 15 developing countries in South Asia, the Middle East, and North Africa and Sub-Saharan Africa. Dr. Soumya Swaminathan, Chairperson, MS Swaminathan Research Foundation, and former Chief Scientist of World Health Organization, a globally respected public health expert and clinical researcher. She has worked extensively on infectious diseases, health equity, and climate health interlinkages. Over to you, Aarti, now.
Thanks very much. Morning again, our esteemed panel. It's my honor and a privilege to moderate this session, which is made up of not just the top scholars in India on the topic, but also each one of you bring the depth and knowledge that we will be happy to collate and pass on, especially when it comes to talking about heat. Uh, we had tried to set the context, but in the next 1 hour, I would really look forward to having as much as a deep dive in your brains on what is really going on with this very complex topic, how it links to disaster, how it links to preparedness and opportunity, and where is it that our fulcrum should lie when it comes to the kind of efforts that we should be making. May I come to you first, Dr. Krishna Vatsa, as the member of the National Disaster Management Authority. You're also one of the disaster risk reduction experts, well-known experts in the world. We are at a juncture where, while we are talking about heat, monsoon is coming and creating mayhem. While we are talking about how to deal with heat, we really have to figure out how to integrate heat stress management with public health indicators. I want to pose a very open question to you on what do you think are the challenges when it comes to managing heat? How is NDMA looking at the integration?
It's indeed a very complex issue. Thank you very much for inviting me, allowing me to share my thoughts with a very informed, very well-steeped cohort of participants and experts. It's indeed a very, very complex issue. And yesterday we were reviewing the heat wave preparedness and mitigation at the state level. All the states participated in the meeting. As usual, it's a mixed bag. Some states are doing better, some states are lagging behind, and our job is to encourage all the states to improve their heat wave preparedness and mitigation. One thing that we realize, and we are working towards it, that it is not a seasonal issue anymore. No, we would start our preparations for heat wave management in January or so, but we realized that, and in January also we would think that in the midst of the winter, we are talking about heat wave preparedness, but actually it should now be year-round effort. We should start somewhere around August, September for the next year. So, and that's the kind of magnitude and the proportion and the kind of seriousness and the scale that the heat wave management requires. Considerable amount of effort goes into heat wave preparedness across the country. And NDMA works very closely with IMD on this issue, and I would say that it's a really good partnership going at the national level, and we are also trying to involve more and more agencies. A large group of knowledge management partners are actually working closely with us to disseminate this preparedness and mitigation. So let's, one thing is that the heat wave, heat action plans, that's how we approach the whole issue. We are preparing heat action plans at the state level. All the states have prepared their heat action plans, good, bad, but they are there. We have impressed upon all the states to prepare heat action plans at the level of cities and districts. And a large number of districts have prepared their heat action plans, and cities also are now picking up. Yesterday, I saw UP has made excellent progress in preparing heat action plan at the district level and at the city level. Rajasthan, it is it's spreading fast. We are getting more and more cities to prepare the heat action plans. So right now we have more than 250 heat action plans across the country. It's a large number, but we need to expand the heat action plans to more and more districts and cities. So this is one thing. But preparing heat action plan is one thing, and actually addressing some of the key issues, critical issues, central issues related to heat wave management is different. Heat action plan could very well be a cut and paste plan, and how do we improve the quality of the plan? That's also a very, very important challenge. Look at some of the technical dimensions of the heat action plans. What are the issues that we need to look at? We need to look at the deviation from the temperature. Dr. Mahapatra is here. He knows, he's far more knowledgeable on these issues than I am, but I'm also raising some of these issues. So deviation from the average temperature, the absolute temperature that is, that exceeds 45 degrees in certain parts, and it is exceeding right now 45 degrees in many parts of the country. Then we also have the issue of the difference between the daytime temperature and the nighttime temperature. When the temperature narrows, things become much more difficult. We have the issue of heat and humidity coming together, and this is posing a serious challenge. Sometimes we are underestimating the impact of heat just because the temperature is less, but we have a much higher humidity, and generally due to the climate change, we are seeing more and more humidity, and that's actually posing the challenge. So heat and humidity need to be combined, and that's always a technical challenge for us. Urban heat island impact, of course, we recognize it. The cities are much hotter. How do we integrate urban heat island impact in our heat action plan? We do not have a very easy tool for doing that. We do not have the kind of data also, and we do not have the kind of skills for bringing these at the city level. So these are some of the important critical technical issues that we need to address. Then we start looking at the impacts, how the heat impacts the people. And we are talking about the differential impact impact on different population groups, different working groups, elderly, women, children, all of them are differently affected. The people who are in informal sector, people who are in construction sector, they are very differently affected. And I think a heat action plan needs to reflect these differential impacts. And again, this is something that requires a lot of understanding, thinking, data management, and proper reflection of all these socioeconomic realities in the writing of the plan. And then we also have the health impacts. How are our health authorities preparing for heat wave management? What is the kind of reporting? How should reporting be organized? How our primary health centers and hospitals are prepared? Have they set up the cooling centers? Are the doctors familiar with the symptoms of heat wave, and how are they administering first aid and the related kind of diagnosis and the protocol. So the impacts again need to be reflected. The health aspects need to be reflected properly. Then we come to the core aspects of the heat action plan, which are the preparedness and mitigation. What are the preparedness measures? And preparedness measures again would different from one district to another, one city to another. Of course, the important parts, some of the common sensical parts are very, very clear. We need to provide for more water, more cooling centers, more health centers. Those things are very, very important. We need to reschedule the working hours, reschedule the school hours. We need to provide more facilities at the bus station, railway station, all those things. We need to improve or reduce the overcrowding in our public buses, trains, and all those things. So these are some of the important preparedness measures. Again, all the agencies are involved, but again, at the local level, all the agencies need to get involved, and there the leadership of the district at the district level makes a huge difference, how the agencies come together and work together. And finally, we are moving to the mitigation aspect, how we need to take long-term measures, which is, of course, passive cooling, cool roof technologies, and those things. So a heat action plan is a complex endeavor. And when we are expanding the coverage of heat action plans, there are challenges. The challenge is who writes the heat action plan. Do we have the kind of expertise to write so many heat action plans? So that's one thing. We do not have a very well-established, I would say, academic or technical center through which we can develop a kind of I would say that a group of people who can help the districts. And this is this is what I keep appealing to all the knowledge partners. Let's try to reach out to the districts. Let's try to reach out to the cities. They need our help. And if we just leave it to the officers to write the heat action plans, it would not be a great success. We need more hand-holding, and we need more technical assistance. We need more technical training, actually, at the national level. We don't have one designated proper center of excellence today for disseminating all the knowledge, all the expertise, and some anchor for deepening the practice of heat wave management. That is the central challenge today. We are expanding it. All our efforts. One major problem that has always been flagged is how do we implement the heat action plan on the ground? Our heat action plans don't have a financial mechanism to back them, but that too we have kind of address that. We have been working hard to get the mitigation fund to support the heat action plan. And that has been allowed. That has been a big win for us at the policy level. We are issuing the guidelines soon. Hopefully, we have been working on those guidelines. So now at the state level, there would be some resources available. But again, the government resources would not suffice. We need more complementary sources from the private sector, from the NGOs, from the local governments, and from citizens themselves. It is a problem that affects the entire community. And so there has to be a wider mobilization of resources. The government would provide the catalytic funding, but there has to be more funding from outside. So hopefully within a year or two, we will see many more innovative experiments, interventions happening at the grassroots level, which would reduce the impact of heat wave. We would also see I think many more innovations at the state and district level. People are coming together, setting up cooling centers. All those things will happen. But what we really need is to improve our technical backstopping for the heat wave preparedness and mitigation in the country. So that's how I look at the entire problem. Thank you.
Thanks very much, sir. If I may, I think the problems of lack of academic coordination and rigor also speaks to how, like back in the days, the state action plans for climate change were written. Maybe it was around the Copenhagen COP in 2009. And after that, a lot of institutions, including Terry, others at that time, I remember Terry, sorry, I don't mean to pick on one, but a lot of organizations helped states write the state action plans. And 2016 onwards, when air quality became quite poor, and the whole national clean air program was created. I mean, there are always like lessons to learn. The whole national knowledge network was also established as a way to have that tripod, where in each state you will have a premier institution like an IIT, you will have one PCB or designated municipal body or an urban local body, and you will have like the nodes of the national knowledge network. So at least the intention is that you bring the academic rigor, you also bring participation from the private sector, you get more ideas into the mix and try and make a comprehensive plan at the state level, however that may be. I think your point is quite well taken, that it's not just the onus of one agency of the government to make a plan for something that's very complex and intertwined. And therefore, the more it's integrated, the better. Maybe when we come back, it'll be helpful to hear anything more on the aspect of financing heat action plans. That was a place where at least the air quality plans got into doldrums on not having enough money and the allocations going into solutions which are false solutions, so on and so forth. So how do we make sure that whatever we are doing is in just the money is available and the money is at the right place? We'll come back on the second round. Can I come to you, Dr. Mahapatra? You are not just known as the cyclone man of India, but when climate becomes prime time, you're always in the news. And very recently, you also launched your special 6x6 kilometers resolution weather system, which will include forecasting. As such, weather is becoming more and more extreme. So while on the one hand, we don't have enough to be able to quickly act on what weather impacts are bringing to us, we also must accurately measure and monitor what is out there, and therefore the need for better data, better forecasting, and making sure that the two speak to each other. How are you feeling at this moment? Are we sitting at a heat wave? Are we sitting at a monsoon mayhem? Where should we look? How is it that we should divide our energies? Should we look at developing heat action plans and integrating them? Should we look at figuring out what a truly integrated data system looks like. Could you shed some light? It's just, I think it's a lot of confusion in the mix and would be helpful to hear your prioritization.
Thank you, Madam Aarti. Good morning, namaskar to all of you. My dear panelists, distinguished friends, ladies and gentlemen. At the outset, I congratulate Climate Trends for organizing this meeting and conference on the issue of heat wave. As Aarti told correctly, that we are conducting this meeting when there is no heat wave in the country in the month of May. So that speaks of the variability of the weather. Weather varies largely in a tropical country like India. So this year has been very unique in that sense that you have got monsoon now reaching up to Mumbai. There has been continuous heavy to extreme heavy rainfall, flooding various parts of the country in South India. And there is an absence of heat wave, except a few places in Rajasthan. Of course, yesterday it stopped in Rajasthan also. So while doing so, I'll concentrate on the heat wave. So, and while listening to various speakers, I just want to go back to a history. Let us remember 1998, when 2,000 people died in the country because of the heat wave. And thereafter in 2015, again 2,000 people died. But now, if you just look at, it is not happening so. It is limited to a single digit or a double digit. So that we should acknowledge that the country has come up with these various solutions in the recent time to combat with the adverse impact of the heat waves, or rising temperatures, or the impact of the climate change. If I compare 2015 or 1998 to 2025, certainly the climate change has aggravated. There has been years in the recent period when we have seen the record-breaking temperatures, but still we have been able to minimize the loss of lives and properties. So it has been possible because of many measures, be it the planning or institutional mechanism, or be it the early warning, or the preparedness, prevention, or mitigation measures, and overall the response of the people and the community towards this heat wave. If I just look at when it was 2015, the people died, especially in Odisha, Andhra Pradesh, and Telangana and region mainly. The immediate step was taken in various angles. And in terms of early warning, we decided that we should go for a seamless weather forecasting and early warning system. So from 2016 onwards, we started a seasonal forecast of temperature. Prior to that, there was no seasonal forecast of mix of temperature. It was followed by the monthly forecast. That was the beginning. Yes, of course, the accuracy was not so good, but gradually the accuracy increased. And now we have come up to a stage where we have got a multi-model based ensemble forecast to provide the probability of occurrence of the heat waves, its severity, and also temperature every month, every season. There was no extended range forecast at that time. That means forecast for weeks to come, say 1 week, 2 weeks, 3 weeks, 4 weeks. From 2018 onwards, IMD started the extended range forecast of temperature, indicating the possible hot spells or cold spells, heavy rain, or wet spells or dry spells. Following that, the impact-based forecast commenced in 2019 for district-wise and station-wise on the term of the heat wave conditions. So by that way, the information extension occurred to link with seasonal to monthly to weekly, then to the daily forecast up to 5 days warning. And then we came up in 2022 that there should be a very short range forecast on day of occurrence. So in the morning at 8 o'clock, we issue a special bulletin indicating what is going to happen today in terms of the temperature and other parameters. Simultaneously, at the same time, NDMA came up with the heat wave action plans Yeah, immediately because the triggering was from Gujarat, Ahmedabad city, and gradually it extended. And as Bassab told that it is now 23 states and union territories which have. Yes, it will vary from state to state within terms of the quality, but at least it has been in place. And there has been measurements, there has been initiation by the NDMA, supported by many organizations, to take off starting from month of February. So while talking of the partnership, yes, it has always been a success story of partnership. Without partnership, one individual or one organization cannot succeed. And whatever you see today, the products, the services being provided by IMD, it is based on the inputs suggested by the public, NGOs, government agencies, various stakeholders, especially press and electronic media also. For example, I will tell you, we started with only the average temperature, departure from that's normal, then the absolute value of temperature, as Bassab told. That was the criteria to declare the heat wave. But gradually, we came to know that yes, humidity is a major factor. So we provided for, at present, we are providing forecast of humidity up to 7 days, along with the temperatures. Not only that, for last 3 years, we are providing the index, that is temperature humidity index, or you can say the feel like temperature, that are available not only in a graphics image, but also it is in GIS platform. You can zoom in, you can find out your area, you can find out what is the temperature and humidity and what is the index for that. Then also Lu in Northwest India was taken care of, and sea breeze and land breeze also plays dominant role in occurrence of the heat wave. So we decided that we should go for the forecast of winds along with all these parameters. So we started providing wind forecast up to 5 to 7 days surface wind. And that gives a measure whether today the sea breeze will be stronger. If sea breeze is stronger, there will be no heat wave condition over Andhra Pradesh or Odisha or West Bengal or anywhere. But sea breeze is weaker and land breeze is stronger, then there will. Similarly, if there is strong, dry northwesterly winds of Northwest India, it will lead to very severe heat wave conditions. So therefore, the winds were taken into consideration. The next come the how extreme it is. We say it is departure. Departure does not say about extreme. So therefore, the question was put up to IMD that how extreme it will be. To address that extreme value of the temperature, we introduce the percentile. Now you can find out the information about whether temperature expected will exceed 98th percentile or 95th percentile or 90th percentile. And accordingly also, you can assess what could be the impact. The next point, what you found that it is not only 1 day temperature, it is the persistence. How many days continuously the maximum temperature has been higher, or how many days continuously the heat wave condition is continuing. That persistence information is also provided with the data available in the website for the last 7 days, along with the forecast data for next 7 days. Then we found out from the study, actually public health and others from Gujarat and some other areas also it was suggested that it is not the only day temperature, it is the night temperature which kills. So we introduced the warm night temperature. We defined the criteria to find out the warm night conditions. And now you can find out the warm night conditions. So then similarly, we found out the percentile of the warm nights, whether it is exceeding the extreme conditions. Because if you have got warmer night, people cannot sleep well. Just think of the people, not like us who are sitting in the AC rooms here. People working under the sun, people do not have the roofs. The people do not have the affordability to have put off a fan even. So those people, if they cannot sleep and also on the daytime they have to go for work for their livelihood, so it becomes really difficult, and it is found that health-wise it is also analyzed that warm night along with the heat wave conditions is very dangerous. So therefore it is also taken into consideration. Now, so you may say that yes, you are producing all the information, but where is the synthesis? Yes, we have come up with a decision support system. There is a synthesis of all these parameters, and we develop a composite index. But that composite index is not shared to public at present. It is experimental within house itself. But based on that, the color coding, which was earlier introduced as green, yellow, orange, red, only based on the maximum temperature criteria, is not so at present. The impact information which is being generated in terms of color coding, green, yellow, orange, red, it takes care of all these parameters which I discussed here. And accordingly, we prepare a color-coded district level and station-specific warning map for the heat wave. After doing that, you have to inform, so what is the damage expected and what is the action suggested? Though it is not the work of IMD, but IMD has ventured towards this area with collaboration from various agencies and especially with support of NDMA. That health action plan, NDMA guidelines helps us, and we go by what is standardized, what is prepared, we put up that, what will the impact in terms of health, impact in terms of agriculture, impact on livestock, impact on water bodies, and many more. So all these are taken into consideration. And what we do actually at present, an impact matrix we prepared, which is static in nature, not dynamic in nature. It is static in nature. It takes into consideration historically whether the particular district people have died because of heat wave. So that information we have done by preparing a climate hazard vulnerability analysis of the heat wave based on data of 1961 onwards. Actually, data are very difficult to get, the mortality data, morbidity data. What we have done actually, we prepared a document that is called as disastrous weather events. Every year we publish it from our Pune office. There, we analyze all this data and data are digitized. Anyone can utilize that. From that data, we composited and found out what is the vulnerability of a particular district due to the heat wave. And according to that, information is also utilized while writing the impact and the risk. Then we collaborated with various knowledge partners, with various agencies in the state, and information is being provided to all concerned government agencies, non-government agencies, even the associations like say medical association. And you will be very happy to know that it is not limited only to the higher echelons. The information also goes to the ground root actually. And I'll just give one example. In Delhi, the Rickshawala Association, Vendors Association in particular, market complex are getting the information about the temperature and heat wave. Of course, it is not our responsibility. People came to me and met this year itself and said, we need this information. And they told that we'll do it experimentally in Delhi. Then we'll spread to all the cities in the state. Therefore, people are willing. So we have to work together and we have to find out the people-centric approaches. We told that we cannot write in your words. They are converting in their own language. They're just putting up a placard in the street market and they're writing this is the temperature and this action should be taken according to their own requirements. So we have to prepare. Though we have done technically so much things, now the time has come that we have to think about very targeted, vulnerable populations. Like, for example, who dies if we just look at of the heat wave? The people who are pulling rickshaws, the people who are working on the street, the people who are driving vehicle like trucks, not like AC cars, in the road. Those are the people that are working in the paddy field or any field, crop field, etc. So these are target groups. Other things are also expected, just like, for example, the students, the old and weaker sections, and the people with the morbidity, etc. So these are the targeted groups. I think all of us know that qualitatively, but the time has come to tap each and everyone so that the success story which has been wrought so far, that will further extended to minimize the morbidity. Morbidity is still there. Mortality is reduced, but still we have to reduce further, because if you compare, for example, usually when you go for the death analysis, you'll find that in Rajasthan, people do not die because they are accustomed to that climate. But what we found last year, the people died in Rajasthan. So it becomes unnatural. So there could be some reasons that needs analysis. Why people die in Rajasthan? There was heat wave conditions. We found out that it is a persistent heat wave condition of Rajasthan. People are walking on the road and they fell down and they become all right. So there are some evolving issues There are certain areas where earlier there was no heat wave, but now you are getting the heat wave conditions. For example, Tamil Nadu, for example, Kerala, for example, Karnataka, where you do not get usually the heat wave conditions. But now the spread, which was limited to North India and Central India and plains, now it is expanding towards that. So that we have to take care of that, and accordingly, the population has to be sensitized and action plan has to be prepared. We are ready to share all the data, and I am happy to inform you that whatever data we have, that is available in the website. If someone wants to access the data, we have developed the APIs. Please write to us. We'll provide the APIs and the observed data and the forecast data. Similarly, we have got the geospatial informations that can be shared with WMS layer, can be shared to you if you have got this support system. We encourage the individuals, states, the organizations to have their own decision support system. Otherwise, early warning cannot guarantee the early actions. We have the early warning now. Our forecast accuracy, we just look at for the day one, it is about 90% in case of heat wave, because heat wave is easier to predict compared to, say, heavy rainfall or compared to lightning or thunderstorms, because it is a continuous process. Now, similarly, for day one, if we go up to day 5, it is 60% accurate on day 5, which was not the case earlier when it was in, say, 2015, or even before 5 years. If you just look at our 24-hour forecast accuracy was 60%. Now 24-hour forecast accuracy is 90%. So there has been about 40 to 50% improvement in forecast accuracy, and because of many reasons, because of the investment, because of the improvement in observational systems, then modeling systems, and of course there has been improvement with respect to dissemination. Of course, the Common Alert Protocol has come up. I think Bassa forgot to inform that this is a success story of the Common Alert Protocol, by which all the mobile service holders, be it smartphone or not smartphone, they can get the information about the special warning being generated, and they can take care of that. Only thing is that what I feel now with all these developments, and as you mentioned that yesterday we have gone for a 6-kilometer resolution global model, and also we've got other models. With all these models, we do not go by any one model, we go by the multi-model ensemble, because just like doctors differ, models differ from each other, and that we take care of. And also new technology we adopt. Just for example, AML is coming up. We are also adopting that. Some products are being generated on the temperature utilizing AML. But there is a need for synthesizing both AML approach and the physical model approach. That also we are working towards that. We also coordinate and collaborate with various agencies working the field, not only within the Ministry of Earth Sciences, but also various academic R&D working within the country and outside also. So it is a joint effort, and this joint effort is going on. It will further go on in the future. Only our target should be now that, as all speakers have told, the public-private partnership. Everyone should work towards one objective, by which all the data, all the information being generated can be utilized to reach out each and every person with the solutions, irrespective of this changing climate or irrespective of this rising trend in temperatures and heat wave conditions. Yeah. If you go long term, yes, temperature is rising, heat wave frequency is increasing, duration is increasing, intensity is increasing. Still, it is a success, but it can be further successful. For example, now we have gone up for livestock. We have gone for memorandum of understanding with the Ministry of Fisheries. Now the ponds, inland fisheries. So the livelihood can be assured irrespective of the increasing heat wave conditions. So those livelihood aspects also have to take into consideration apart from the lives. So I'll stop here. Thank you very much.
Thanks very much, sir. I think a lot of things are coming out. 250 heat action plans exist, as Dr. Vatsa pointed out. What you're saying is heat stress is out there. The heat waves are becoming expanded. They're becoming more frequent. They are becoming longer. But at the same time, we have long-range data. We have several models. We have a heat index, which is experimental and not shared, pretty much like the early days of air quality index. You're not looking at PM 2.5, PM 10, you're looking at 7 parameters, and you're looking at a composite, and that's what conveys what the impact is, and that's really what you said. We have heat quality index as well, which is experimental and not shared. I'm myself on some groups of IMD, and I know how much data and information you share and how much up to date you keep the journalists and the media community, and that's really important. One thing that you said about partnerships, and I will come to you, Dr. Swaminathan, and you have been a leading scientist. You have looked at various kinds of health / epidemic situations. Heat is a little bit different. It needs coordination, it also needs planning, and it needs very fast, robust action at the moment when it happens. So, my question to you is hearing the weather scientists and hearing disaster experts, what is your view in terms of how prepared are we to look at heat as a public health concern in India? Where are the actions and coordination mechanisms?
Yes, thank you very much. And I think the previous speakers have already touched on a lot of issues and points. So maybe I try to focus on some of the health impacts. See, I think one of the things that's becoming obvious is that heat is no longer something which, or a heat wave is not something which happens once in a while in a few places in India, and you have to deal with it for those few weeks and then you're done. Last year in Chennai, in the month of October, there was a big event where a lot of people collected on the beach. Lakhs of people collected on the beach to watch an air show, and 6 people died before they could be, taken to the hospital and saved. They died of acute heat stroke. This was in the month of October. So obviously, if you look at Chennai heat, it's going to be very different from what we face in Rajasthan or Delhi, though the humidity levels are increasing here also. But in the south, the coastal areas, you have very, very high humidity levels. So even if the temperature is reading at 35 degrees, your body is experiencing 45 degrees. So I think and like you said, the unseasonal monsoon. So the message here is that with climate change, things are more unpredictable. They do not respect the rules of the past, and they are going into different areas at different times of the year, and therefore you have to be prepared all the time. The second is, I think, what has also been mentioned by others, that is, it's not just the peak temperatures that are the risk, it's really the elevation of not only the day, but even more importantly, the nighttime temperatures, which do not allow your body to basically cool down. And what has been observed is the rise in nighttime temperatures has been quite dramatic. I think, Dr. Mrityunjay, you would agree, over the last decade or two. So the persistently high nighttime temperatures, the duration of time for which that happens, that is having an impact on our biological systems, which is not fully understood. So we are seeing an increase in cardiovascular events and deaths, in high blood pressure, and particularly when you combine heat and air pollution, there's evidence that has a deadly impact. And that is, across large parts of North India, you have high heat with air pollution. And so that's causing a lot of damage to the different organ systems. There's also a lot of data that's emerged in the last few years on the impact of heat on pregnancy. So, loss of the pregnancy, so leading to stillbirth, leading to premature delivery, leading to high blood pressure during pregnancy, high maternal and newborn death. And in fact, during that famous Ahmedabad heat wave, a lot of newborns had died also because the newborn ward was on the top floor of the hospital. So we undertook a series of studies in the last 2 years really to look at the impact of climate change, but more recently we're focusing on heat on women and children in particular. So there's a survey that's going on currently across 7 states of India. So we've also done a lot of consultations with NGOs and civil society organizations. So one thing that's very clear is that the heat action plans, Dr. Vats, you were talking about, the numbers are multiplying, So state, district, cities are developing them, but these are largely top-down, developed by a group of experts sitting together, and there's very little community consultation that has gone into it, and there's very little ground truthing of the recommendations and very little feedback. So I think one of the immediate things we need to do is, it's fine, we need the heat action plans, but I think they need to be revisited on a yearly basis, and there needs to be a lot of community consultation and inputs into these. I saw a film that's been produced by the CSE recently. It's on YouTube, on the heat impacts on fisher women and auto drivers and so on in Chennai. And the fisher women and the fishing community traditionally have adapted to heat, again, like you said, because they've been exposed. They're outdoors, they're either out in the boats or they're selling fish. But they were sitting under maybe thatched roof. They had a different kind of shade under which they would sit and sell. Today, they've been told to sit under, something that's been made by government, which is generally not a very climate-friendly roofing. It could be a tin roof or something like that. And so they're baking in underneath that. Similarly, if you walk into any slum, you'll find that many of them are using metal sheets for roofs. There's no ventilation as well in those houses. And therefore, the night temperatures inside those tenements are 4 to 5 degrees higher than the outside temperatures. So while we may think the outside temperatures come down to 29 or 30 degrees, what they're experiencing inside their homes is 35 or 40. In Thane, there was a study done by CEW where the indoor temperatures went way above 50 when the outside temperatures were in the mid 40s. So what are they? So obviously you can't sleep in your home then. And then you have to leave your house and look for a place outside to sleep. So you'll find a lot of people sleeping outside on the beach, etc. Now, for women, that also poses safety issues. So one of the things that our studies have found is that women are disproportionately impacted by heat and by other climate hazards. And these issues have not been considered fully when we are discussing about the adaptation plans. The other thing is the lack of the data, or rather the data sitting in silos. So that was also mentioned by, I think, Dr. Bharatlal in the morning, that all our departments collect a lot of data. But if you really want to look at the IMD data and overlay, let's say, health data or biodiversity data, one would find it quite difficult to do. So I think that to me is a low-hanging fruit. And if a few departments would come together and agree to create, and I have been pushing for this idea of an environmental health regulatory agency, or at least start, if not with the regulatory agency, with the environment health hub, where the Ministry of Health and the Environment and possibly Earth Sciences would come together, because the technology now that D and NDMA and others is extremely cutting edge. It can have a huge impact on our health outcomes if only we were able to integrate. For example, the early warning that the IMD puts out, how is it being understood by the health workers? How is it being translated into action? Where are the protocols for that? And similarly, at the community level, you gave a very good example, Dr. Mohapatra, of the vendors in Delhi, being very proactive. So we have a similar example of the fishermen in Tamil Nadu. After the tsunami, they were completely terrified of going out to the sea. And so we worked in partnership with them and with Qualcomm and with INCOIS, actually, because INCOIS has all the data on the marine parameters and the weather data related to the oceans. Earlier, we would use NASA data, but now INCOIS data and ISRO, they have all the data that we need. But it's taking that data and making it useful for somebody who's going out to fish in his boat that day. So these theoretical alerts and things like that, which are very generic, they don't translate into somebody who's a fisherman or somebody who's a rickshaw puller or a woman who's rolling BDs, in a factory or in her house. So that individual needs a data which is very useful for them. And therefore, this fisher-friendly mobile application that was created, and that partnership with INCOIS now continues, because we are updating that. It's gone through 54 iterations based on feedback from the fishermen. So it started with weather parameters and whether it was safe for them to go out to sea. It evolved into many more things, like where the fish are most likely to be on a particular day. They also get alerts if they approach turtle nesting zones, if they approach maritime borders, so that they don't cross unknowingly into a neighboring country's sea and get arrested and so on. So they actually are the ones who gave the feedback that this is what we want, this is what we want. And so the app has grown and developed over a period of time based on the community's needs. I think for heat, we need something similar. We have the IMDs. So this is what we're planning to work on with the Indian Institute of Science and Art Park. We have a program that will start very soon in 4 different districts of South India, where we will monitor communities. We need long-term data as well, right? So we don't really have very few places in India where we have long-term monitoring of both climatic and health data so that we can get a good idea. We may think that that 1 week in May, which is very hot, is what is having heat impact, and the rest of the year there's nothing. But when you actually go into communities and monitor, it's not the case. And then we are also finding out the impacts on things like domestic violence, on nutrition, on antenatal care, on immunization services. And we have to remember the health workers are also part of community. They also get impacted. And these Ashas, Anganwadi workers, ANMs, they're all out in the field, going work, walking to the villages, meeting people. So we have to also think about protection for them. So we, I think, need a lot of new we need the data to be in one place to make sense of. We need collaboration between the, I think, different departments, particularly when it comes to operationalizing a heat action plan. We need the community voice, and then we need technology. I think solar energy provides now today a lot of opportunities for perhaps cooling solutions as well, not just for people, but also, animals, their livelihoods get impacted. So we have to also think more holistically of people and their livelihoods, and how do we protect those. And death, by the way, is the tip of the iceberg. And even that, we don't, fully count all the deaths that are attributable to climate hazards or to heat, because our death reporting systems are still not uniformly strong across the country, especially on the cause of death. So we need to strengthen that, because that is the best source actually for the government, for policymakers to really know, because what people die of is what should inform your policies, and that keeps changing from time to time. So I think that's another area for strengthening of our data systems, needs some capacity building. But I think eventually it's morbidity, as Dr. Mahapatra was saying also. It's not just the mortality we need to be fixated on, that, okay, this year only 3 people died and last year 50 people died, but what is the impact on health, productivity, and as you were saying, Aarti, on ultimately health determines your productivity and economic impact, and it will impact our GDP, as you already showed some projections. So it all makes sense for us to be a Viksit Bharat and a high income country, or going towards that we have to protect people's health and productivity. And I think climatic stressors are going to be like the biggest. And final word, nature-based solutions is something that we must keep in mind as a adaptation measure and a solution. We don't always need high-tech fixes. We sometimes just need to go back to the basics, because we've lost so much of our biodiversity, especially urban biodiversity, that we need to think about nature-based solutions for each of our geographic areas, which could make sense.
Thanks a lot, ma'am, for bringing out all the relevant points. Can't say more on nature-based solutions. I mean, like you said, this is not technological fixes, or this is not jargons. This is just bringing the tree cover back. This is making sure that the concretization is contained at some level, but also take your point completely on having that environment health hub / regulation, because clearly that's what everybody has been saying since the beginning, that you need systems to speak to each other. You need data to speak to each other. We don't need to be in silos. I know we are running late. If I may request our panelists to stay back a few more minutes, and I would invite Mr. Ashish Khanna, who has been at several important postings, including the World Bank and a few others across the world, and now is as the Director General of the International Solar Alliance. Sir, you are sitting at a place where you're watching India's progress on solar and our commitments to our nationally determined contributions. We claim India has the most ambitious climate targets in the world. That's one side of the story. The other side is that our peak is shifting. We are now consuming a lot more energy. When power demand peaks up in the next 10 years or so, there is going to be even further demand that is going to come on either coal or gas, or possibly into solar as well. How do you think increased power demand is interacting with how heat stress is becoming a very prominent aspect of how power demand will go up in the next 5 to 10 years?
Thank you.
And I know in the interest of time, can I combine another question? Would you also be able to talk about the role that new systems like solar can play in making sure that while we are managing heat stress, we are not creating more emissions?
Sure. Thank you, Aarti, for inviting me, and it's an honor to be next to three doctors and experts. I'm not an expert on heat stress, I must confess. So let me share that first of all, it requires cross-sectoral solution. Dr. Bharatlal mentioned everybody went. I'll probably answer both your questions across four heads. The first is, how are we going to manage more? Because India needs to double its electricity demand over next 10, 15 years, just because of the nature we are growing, we are urbanizing. And that's not only true here. I'm coming from Africa, where 70% of buildings that need to be constructed by 2035 are yet to be constructed. Just imagine how much stress the world needs in terms of electricity production. And we are less than 5% of US per capita energy consumption right now. First is we'll have to innovate. What do we mean by innovate? We have now done 100 gigawatts of solar generation in India, but we are going to face the problem of evening peak, as Aarti mentioned. Now we are coming to a solution where a combination of battery storage, but also hydro's pump storage can come together as some form of a combined hybrid projects, which increase the efficiency of even solar projects. And the bidding for those projects is now coming at a lower than the new coal projects. If that happens, then the future of India's growth and jobs need not be compromised with more heat and more stress. It is very vital that we capitalize on that. Second, look at sectors. Look at agriculture. There's a technology called agrivoltaics, in which you have rooftop and you grow crops under it. It prevents 30% of water loss on crops. It gives a huge cover for the solar panels as well. It is very vital that we absorb and look at business models for doing a lot more on agrivoltaics. Then there is something called building integrated PV. The material that's going to be used in construction of buildings, like the glass, can actually completely absorb solar PV panel, because you need not have solar rooftops only. Imagine if majority of buildings and urbanization in India are going to happen over the next 30, 40 years. If we can make sure that technology of BIPV, building integrated PV, in terms of what kind of materials we use for cement, building, glass, all of that can increase the heat absorption and probably provide energy needs rather than any more of coal and gas in a much more economical way. The second part of it is there are a lot of technologies that exist but need to be scaled up. And I think we all need to figure out what will be the way for doing those scalable business models. Let's talk about agriculture, where solar pumps are a very important way of making sure our overall demand for fossil fuel-based generation can come down. India has one of the world's leaders. More than 1 million solar pumps are there. But it is possible to actually do far more, especially the case of Maharashtra, which is a great case, where rather than taking very expensive electricity to the farmer at the cost of 7.5 rupees, if you take some fallow land next to the substation and put solar there, that can be at 3.5 rupees. You have empowered the livelihood of farmers. You have reduced the fiscal savings by half to the government of providing those. I think those models will need to be scaled up. That doesn't compromise, I repeat again, our economic growth while compromising heat stress. The third segment is on digitization and AI. We, sitting in India, probably have to be role models for the world in looking at using digital planning for planning our systems and distribution and transmission and power flows. Today, especially in distribution segment, we haven't done a lot of digitization where AI can tell what is the most optimal utilization, both for generation, but even for storage. Imagine 10 years from now, if half of your homes have some battery storage and you're on vacation, there are going to be apps that will allow you to trade your battery storage with your neighbor rather than having a coal or gas-based generation somewhere else. That is all again vital for not compromising on economic growth and not compromising on heat stress. The final issue, Dr. Bharatlal mentioned, Aarti mentioned, is on financing. I feel I'm coming from a lot of international work where too much of talk is happening on innovative finance. But I think time has come for actually real instruments. We in International Solar Alliance are working on risk mitigation financing tools because most of this solution will have to be done by private sector. Government anywhere in the world does not have enough money to meet these. But why is private sector not investing in developing countries? Africa, for example, has less than 1% of solar renewable energy. India is the only country that is doing very well. But they need some risk mitigation and some blended finance to attract a lot of private sector. So that I think is the fourth set. All these, if done well, are essential that we do not aggravate the heat stress because we are still early on in the development stage and we need a lot more energy for economic growth. Thank you.
Thanks very much, Mr. Khanna, for keeping it very clear and just the 4 points that you laid out. I know that we have run late by a few minutes, so I will ask Kartiki to come up and bring this panel to a close. But I think I will just say that a lot came in here. Expand the heat action plans, expand public-private partnership, expand the view on community, stop taking a narrow view on health, make sure that data and systems speak to each other, and just, I think, expand also technologies like solar PV and agri, etc. There is no one solution. This is not a single unidimensional problem. And I think what everybody said really speaks to some kind of a combination of forces that must be put in place to tackle heat stress, but also tackle heat weather, freak weather. We are not living in a world where crises will come one after the other. We are living in a world where crisis will be compound, and I think our actions will also have to be compounded. Thanks very much to all the panelists, and back to you.
Thank you all to our esteemed panelists for sharing the valuable perspective. We now request all our speakers and dignitaries to kindly gather for a group photo. And I would also request Aarti to present small mementos to our guests. Yeah, I mean, group photo. We now break for tea and networking, and we will reconvene quickly in 10 minutes by 12.
Yeah, I know you had to leave. I'm sorry. I'll come and see you one day. But Dr. Mathu was there. I knew him from my past life. So in my days of Terry. So, you know, my connection was there. But I must say I lost that in the middle, but I can come over and talk about it. But you also follow the
They're waiting outside in case he can do that. I loved it being told.
Morning. Good to see you. How are you? Hello.
That was fun.
I know.
Next is my side.
Hmm. Gunjan, can you please ask people to come in? Sir? Okay. We now move into one of the most insightful sessions of the day, titled Heat Waves in India, a Threat Across Different Climatic Zones. India has a vast geographical diversity, which means that the way we experience, we respond, and we prepare for heat waves varies significantly from region to region. Whether it's rapidly warming Indo-Gangetic plains, fragile Himalayan cryosphere, or densely populated urban corridors. This session will explore these distinct ecological realities. To lead this important session, I'm pleased to invite our moderator, Ms. Gunjan Jain, Assistant Director at Climate Trends. Joining her on this panel are renowned speakers, Dr. Krishna Achyuta Rao, Dean, Indian Institute of Technology, a climate scientist who has contributed extensively to global IPC assessments and specializes in detection and attribution of climate trends. Dr. Farooq Azam, senior cryosphere expert with ICIMOD and renowned glaciologist. His research on glacier melt across Himalayas and hydrology has helped in shaping up regional water security policies and climate adaptation strategies across India and neighboring countries. Dr. Chandni Singh, lead School of Environment and Sustainability, Indian Institute of Human Settlements, and lead IPC author. Dr. Singh works at interface of climate change and development in rural and urban geographies within the global south. Dr. Jagdish Krishnaswamy, Dean, School of Environment and Sustainability, Indian Institute of Human Settlements, and a noted ecologist whose research connects ecosystem changes, land use, and extreme climate events with on-ground policy implications. With such distinguished panel, we are in for an hour of deeply relevant insights for India's changing heat landscape. Over to you, Gunjan.
Thank you, Kartiki, and thank you everyone for joining us today. We have a very distinguished panel whose Many of them are joining us from other parts of India. And in fact, Dr. Farooq Azam has traveled all the way from Kathmandu to be here with us. So thank you to all of you for being here with us, and of course to our participants. Like Kartiki said, that this is a very critical session because while throughout the next 2 days, we will be talking about how heat is intersecting across various economic sectors and livelihoods. I think this is very critical to understand, first of all, what role is heat playing and how is it as a climatic and a weather phenomena shaping up in our present time and future projections. Dr. Achyuta Rao, you've done a lot of work on heat attribution. Maybe if I can just go to the basics and ask you about how how are heat trends shaping up? What are we seeing, which is an anomaly in terms of saying that there is extreme heat instances happening? What is happening about heat wave versus heat stress?
Thank you. Thank you for that question, and thank you for inviting me. So we've been looking at how we have, in the last few decades, seen changing patterns of heat waves and heat events. So part of this work is through what a group called the World Weather Attribution. So every time there's an extreme weather event, whether it's a heat wave or a heavy rainfall or flooding event, we try and address the question, has this event been somehow made worse or more impactful because of human-induced climate change? So it's a question of, if we are in a changing climate, as you will all appreciate it, climate is just, a sort of long-term statistics of weather. So for climate to change, your weather has to change. Now the question is, in what ways is that weather going to change? So those shifts seem to be happening in the extremes of the distributions of whether it is temperature or in rainfall. So it's these shifts in the extremes that are appearing to be happening at a more rapid pace than rest of the distribution. So what we have examined in the last few years, we've looked at the heat wave event of 2023 and 24. So these are all different kinds of events occurred in different parts of the summer pre-monsoon season. And so each one of them had different geographical signatures and also humidity and duration signatures. So all kinds of different heat events have been looked at. And it's really striking that we are seeing that compared to what these heat waves might have been before human-induced climate change happened, many of these are now 30 to 100 times more probable. Okay, so what we are seeing is that the risk of such events happening has increased. Their duration, their intensity, their spatial extent, all of these have increased many orders of magnitude. So in this, there is a real message in that what this is already doing to us when we are merely at about 1.5 or 1.6 degrees above pre-industrial climate. The question is, if we are unable to keep these global mean temperature rise in check, and whether, and if we end up at 2 or 3 or heaven forbid 4, what would these heat waves look like? So these are some of the questions we've looked at, and what we saw, for example, just to give you an example of the 2022 heat wave, is that we found that prior to industrial revolution, this kind of a heat wave, this was, just to remind people, this was a heat wave that pretty much started in March. Late February through May were really hot. So we looked at March and April, which is really not the season where large parts of North India get really hot. March, in fact, is usually the most pleasant and wonderful time. So those 2 months were so hot that before industrialization, it would have been, those 2 consecutive hot months would have been a 1 in 3,000 year event. And in today's climate, it's about a 1 in 100 year event, which is still rare. But the really striking thing was, if you go to a 2 degrees centigrade global mean change, this could become a 1 in 5 year event. So what we are seeing is that these kinds of really extreme events can have radical changes in their frequency of occurrence. So we've also looked at what's not just at these sort of individual events and how they are changing, but also in general, what are the things that are changing and likely to change over India. So the clear message from climate models, which we have looked at, is that the spatial extent of heat waves is going to increase, which means that you will soon have not just some small portion of a state, but multiple states across the entire southern peninsula or northern plains, etc., covered in heat wave conditions. So that's the spatial extent of a heat wave is going to be much larger. The second thing that we are sure of is that the duration of these heat waves is going to last. So in essence, what would have been a week-long event in one part of a state somewhere is likely to become a month and a half or 2 month long heat wave event across the entire northern part of India or parts of southwest India. So Southeast India rather. So there's this is a stark change that we are looking at the models telling us. I think this is not going to be as simple as every town having their own heat action plan, because once you have the entire country under a heat wave, or at least large parts of the country, you have to do things differently. There are things that are going to happen in a different scale than if you had one part of a country that's undergoing some extreme event. So I'll stop here with this overall message that we have a future that looks very stark. Some of the last point I forgot to add was that we see that some of the more humid months, the monsoon months, when typically there's no heat waves going on, are also likely to become areas, there are going to be areas where there are going to be heat waves. And that is particularly worrisome because by then, if the monsoon has set in, it's going to be humid. And now we're talking temperatures in excess of 40 degrees centigrade. So those are dangerous heat conditions that we hope do not unfold. But right now, we have good reason to believe our models because they've been able to capture what's happening now. So I would really caution that these high humidity, season getting heat waves is something that we have in our future. Thank you.
Thank you so much, sir. I want to just come back to a small question because you referenced it, and also in the morning, everybody talked about it. That's humidity. We are now seeing, while humidity earlier was always associated more with coastal regions, and I know when I was growing up in regions like Uttar Pradesh, we used to say humus ho rahi hai, humus ka mausam aa raha hai. That's how our parents would say that. So humidity is now becoming something which is very prevalent, and that's also being experts, we've always heard them say that it's becoming something which will be one of the biggest risks for India and makes India and Indians extremely vulnerable. Can you talk a little bit more about humidity and kind of what is leading to it?
Yeah, sure. So humidity, whenever you have a warmer air temperature, the air can just hold a little more water. Okay. So every 1 degree centigrade increase in the air temperature is going to result in about 7% more capacity for that air to hold water. So if you have a higher capacity to hold water, then more is going to evaporate from wherever there is. And which is why you have plants that can get stressed. When you increase the temperature, there's more evapotranspiration. You also have more possibility of drought. So there's just that much more humidity in the air. And you know, for those of us who live in Delhi, this kind of rainy May has been a weird thing. My fear is, while it seems nice now, I'm afraid that next month we're in for a very humid heat because there's all that water in the soil, and that soil moisture is going to evaporate, and it's going to make it sticky all through June when the temperatures are going to be really high. And typically that's, you know, July, August type weather, we're going to start getting that early. So that humidity is essentially making it difficult for us to for the body to get rid of heat, because drier air means your sweat can evaporate. And it's the evaporation that actually cools your skin down. And if you can't evaporate and the sweat is pouring down your face, of course, it's not going to cool you. So this is basic human physiology. And I think we are going to be faced with having to be very innovative in finding ways to cool ourselves, because the dry heat, you have other ways of cooling, but when it's moist heat, then it gets really tricky. I'll stop here.
Thank you so much, sir. Farooq, if I might come to you, you are, of course, a glaciologist and an expert in the Himalayan regions. How is heat playing out in the Hindu Kush Himalayas? We always kind of look at heat, and a large perception is perceived that heat is a phenomenon which is affecting the plains or the low-lying regions. But we've recently been seeing a lot more avalanches happening, a lot of changing kind of trends in snow, shifting agricultural lines, etc. So what are the kind of implications we are seeing due to rising temperatures in the northern belt of the country?
Good afternoon. So first of all, thank you very much, Gunjan, for inviting me here. Thanks to Climate Trends. Normally when we talk about glaciers, we talk about climate change impact on glaciers. And I'm really happy that for such event where we are talking about heat wave, I am being invited, and I have the opportunity to say something about impact of heat wave on glaciers. Even when we talk about climate change impact on glaciers, it is not really debated to the extent it should be debated in the general audience, people. And so for instance, just to highlight this, last week I was on a glacier called Yala in Nepal, and this glacier is actually disappearing at very fast rate. And our idea was to give it a tribute so that we can bring the international, media attention and the people's attention to this issue that climate change is impacting glaciers, and of course, that is resulting in downstream changes in terms of water availability. So coming to the heat wave, so basically, if we see since 2015, almost every year we are breaking the global temperature record. And in 2024, we understand that we overshoot it slightly, like 1.5 degree compared to the pre-industrial time. So if we see the mass balance patterns globally on the glaciers in different parts, we observe that the most negative mass balance was in 2022, though the annual temperature was higher in 2023 and 2024 at globally scale. So now why it happened, as Dr. Krishna mentioned, that there was a heat wave in March or April and May in 2022. So that actually significantly impacted the glaciers at large scale, from Andes to Alps to Himalayas. For example, I'm a field glaciologist, so we go on the glacier and we observe the glacier in field with eyes. And when we reached to Chota Shigri Glacier, where we are having our monitoring system since 2002, we observed that in the month of June, there was almost no snow on the surrounding valley walls. The glacier was almost barren. The ice was exposed. Even the blue ice, which is very difficult to see in normal years, even when the mass balances of glaciers are negative, the blue ice was exposed. So it was very hard to walk on that glacier that year. So what happened in early spring, whatever snow was there during the winter time, everything was melted out and the glacier was exposed. And because the exposed ice is having low albedo compared to the snow cover, so glacier absorbed a lot of heat and melted out very strongly. Since 2002, we have the annual records on this glacier, and 2022 was 4 times higher mass loss on this Chota Shigri glacier compared to its normal mass loss. So in that year, the glacier lost almost 2 meters of ice from the whole glacier surface in just one single year. If we see similarly, we had some results from Gries Glacier in Switzerland, where the mass loss on this glacier was almost 5 times higher than the normal mass wastage. And we have observations since over 1950s, I guess, on this Gries Glacier in Switzerland. So this 2022 heat wave produced a lot of melt from the glacier, and glacier mass balance was like super negative, much beyond the annual variability of the mass loss, which we observe over last 70 years on these Gries glaciers. Another example we can take from Austria, so Hinterreisferner Glacier, where we have very long observations over last 70, 80 years. 2022, sorry, was the most negative. The glacier lost almost 4 meters of ice from its surface. And in normal year, it is losing around 1 meter of ice from its surface. So heat waves, when we are talking about the heat wave impact on agriculture, health, and different sectors, at lowland, heat waves are actually impacting a lot up on the mountains, the glaciers and snow cover. And that is actually changing the river patterns downstream. We have changes in seasonality of water. So we are having more water. For instance, this 2022 again, it produced along with early, if I'm not wrong, please correct me, Dr. Krishna. So there was an early monsoon in 2022, and at the same time, snow and glaciers were producing a lot of melt. So that combined effect was turned into a flood in Pakistan. So we have a lot of impact of heat waves on the glaciers and snow. And 2022 year actually brought the attention of global community to heat waves impact on glaciers. But yes, we need a lot more research in the Himalayan region, especially to understand the impact of these heat waves in detail, how they are affecting beside this normal climate change trends. So I will stop here. Thank you.
Thank you, Dr. Azam. You talked a bit about about rivers, and that's one of the big kind of water security for a country like India is one of the big risks. And of course, with changing kind of snow and ice patterns in the Himalayas, a lot of the water is downstream from that region. What are the sort of changing hydrological patterns that are being observed, which can kind of produce, which need to be prepared for in the next decade or couple of decades?
So if we see behind me, we have this thermometer. So how does it work? So if we have more temperature, mercury rises because of its expansion to heat. It is otherwise in case of glacier and snow. If there is more temperature, they shrink. So they are reducing their volumes. So currently, if we see, we are having more and more melt because of increased temperatures. And we are having more water available in the river systems. And if we talk about these river systems, so there are some important things like glaciers melting in Greenland or Iceland, in Antarctic. They have different implications compared to the glaciers melting here in the Himalaya, because these glaciers, they are very close to the densely populated regions. Like we have more than 1 billion people living in Indus, Ganga and Brahmaputra river systems. And directly or indirectly, glaciers and snow cover, they are providing water that is actually partly catering to their energy requirements, food requirement, etc. Like we have around 25,000 megawatt installed energy on these rivers, and more than this is planned. Almost 3 times of it is planned. So we are like agricultural based economy. The country needs a lot of water for agriculture, irrigation. So now with the climate change or global warming, currently we are having more water, but there is a threshold volume of ice locked in these glaciers. When this volume will reach, like with the passage of more and more melt, after a certain threshold volume, we will have less melt water from these glaciers. So that is called peak water. So some models, they project this peak water will come around 2050 in these river basins altogether. And a couple of studies, they also suggest that the peak water has already passed in Brahmaputra river system, especially. So now, what is the issue? If we believe these models, up to 2050, we have to deal with more water. And after that, we have to deal with less water. So up to 2050, we will have probably more floods if they are combined with erratic precipitation from monsoon, like into 2022 was a great example of that, I think. And after 2050, we will have less water. So first hand, we have to deal with the volume of water, whether it is more or less. So we have to adapt these changes. Second, because of global warming, the warming in the Himalaya is actually is not the same as globe. Because of its topography, we are having more and more warming in the mountainous region. So that is called elevation dependent warming. So let's say if we assume that 1.5 degree rise is the target. So if we are able to achieve that, that will result up to 2.2 degree rise in Himalayan region. At globally scale, if we are able to control within 1.5 degree, that will result in 2.2 degree rise in the Himalayan region. So what is happening then? In the springtime, we have warmer temperatures, and these temperatures, they are melting snow and ice in early season. And probably in very early season, we don't need that much of water. So seasonality is also changing. So that is going to impact our hydropower generation as well as the irrigation systems. So we have to deal with volume that is going to change in longer term. Up to 2050, we have more water probably, and after that we have less water. And we have to deal with the seasonality shift in pre-monsoon, or we can say the springtime. So these are two major challenges in front of us.
Thank you so much. Talking about overflowing rivers, Chani, if I might come to you. We have recently in this month itself, we've seen two of our major metropolises being flooded. Mumbai, I think in the last 24 hours received more than 107 mm of rain, and Bangalore, I think, has had the wettest May, if I got that correct. How do you see urban flooding? Of course, I think there are every hashtag for every metro possible, that hashtag Delhi floods and hashtag Bengaluru floods. I think each of these cities has experienced that. So how do you think preparedness is kind of taking place towards this? We are seeing this as an annual kind of recurrence. And just like Dr. Azam said, that we will see more and more such instances with erratic rainfalls and more kind of volume increasing. How do we kind of prepare for this?
Thank you, Gunjan. I know the panel is on heat, but I think it's also salient to talk about other hazards. So I was quite surprised to come from Bangalore and come to this relatively pleasant Delhi, because end of May, one expects to be baking. I remember 2022 and the March heat waves that completely, I mean, I think I suffered near heat stroke kind of symptoms. So, I mean, that from there to today, I guess I'm not surprised by this kind of what Frederick Otto, she's a well-known climate scientist, calls angry weather. So there is just weather patterns that we don't imagine possible are happening all across the world and across our cities, across rural areas. I'm not surprised, because this is exactly what we have been saying in the IPCC, that a climate changed world looks like this, where you've got floods coming in seasons that you expect heat waves in, you have a lot of erratic monsoon, you have unpredictability both in precipitation and in temperature, both in terms of extremes, but also the frequency and intensity of that is changing. Now coming to, of course, preparedness, and what I want to put a focus on is we often tend to talk about risk in terms of, in very homogeneous ways. Who are the people at risk? Where are these risk hotspots located in our cities or in rural areas? And how are the capacities to deal with risk, this escalating and uncertain risk, how are they differentiated in both in populations? And I don't want to only focus on, and I'm sure Jagdish will pick that up, it's not only human societies, but also our natural systems, right? So if we look in the IPCC, at least the way we disaggregate risk is we talk about the hazard, here in this case heat, but Gunjan has also mentioned floods. We talk about exposure to the hazard, and then we talk about vulnerability to these hazards. So these three things come together to determine risk. What we do very well, and from the morning panel, we spoke about it, Dr. Mrityunjay was talking about how well the country is now developing systems to map and monitor the hazard. How much heat, how many extreme heat wave days, what are the deviations from the normal, what are the anomalies, and so on. So we've got a good handle on the hazard. There's also a lot of attribution work that is now sort of, I mean, has been for some time actually showing us that this hazard of extreme heat is anthropogenic in nature. There's absolutely no doubt in that. The level of heat that we're seeing is human induced. So we have a good handle on that part. I think we have begun having a good handle on exposure, which is that how many people are exposed, especially around flooding. Actually, we have sophisticated models, at least across some cities in the country. There's a lot of work on, like IISc is doing work on developing a twin, a digital twin of Bangalore, so that you can do these simulations of what would flood look like in Bangalore in that digital twin. And then you sort of play out scenarios and see how that will play out under different levels of, say, urbanization, built form, rainfall, and so on. So there's a lot of interesting science, I think, going on in this space. Exposure, of course, is also understood in terms of numbers of people exposed to a certain hazard. And here again, I think there's been, especially from the health sciences now, a lot more work on things like who are the people exposed, in what ways are they exposed, what are the numbers. What I feel we don't understand well enough still, or don't focus as much attention on, is that third angle of what we call the risk propeller, so hazard, exposure, and vulnerability. The third element is vulnerability. Who is vulnerable? It's more difficult to pick up because vulnerability, a lot of it looks like poverty. A lot of it looks like structural issues in our society. So all that people were saying in the morning around certain workers or certain genders being more vulnerable to heat, that is the story of vulnerability. And that unequal vulnerability, I think we are very poor in mapping. We tend to fall back on extremely outdated census data to capture vulnerability. There are some interesting exercises. I know Bhubaneswar's heat action plan, Irade had done a good, at least a first level mapping of what uneven vulnerability in the city of Bhubaneswar would look like through a primary survey. But we are again falling back on static ideas of vulnerability, going in, measuring certain indicators like gender, access to early warning systems, and so on, a type of livelihood you're engaged in, and developing a composite of this is what vulnerability looks like. But we know from all our work, and anyone who is doing work on the field understands that vulnerability is dynamic. People move in and out of risk. People change jobs. People move across rural and urban areas. I do a lot of work on migration, and you see that people are crossing rural urban areas constantly. I mean, we are a very mobile country actually, and across income groups, people are moving. All of that shapes our vulnerability, and all of that comes together to shape unequal risk in cities and rural areas. So I feel that is the fundamental thing we should be measuring. And just coming to, because you asked about preparedness, I would say that, again, because I work a lot on adaptation, which is preparedness is part of that, but you've also got really future-looking response strategies. I mean, what could you do proactively? And while we've got these wonderful aspirational heat action plans, there's also, at least from when we were writing some of these IPCC reports in 2019, 2020, where heat had somehow still not caught the imagination of the country the way it has caught it now, for good and bad reasons, obviously. Now, every week we have a heat convening. I think now what we have to think about, I mean, the heat action plans have, they operate, or they sort of have this sense of being standard operating procedures, a laundry list of activities that different departments have to do. I think they're very good as SOPs. They are much needed. They also put a lot of emphasis on interagency coordination, so different departments coming together to do something pre-heat, during heat, and after heat season. So in that sense, I think aspiration is good. Now, of course, for example, the Delhi Heat Action Plan is also doing a lot with 10, 11 knowledge partners, trying to bring in experts and even NGOs that have been working on specific issues to sort of help broaden the base of the heat action plan. But what I want to end with and argue for is we really need to think about heat adaptation pathways. So adaptation pathways is this idea that you can't do one thing at one point. You have to think about sequences of bundles of solutions. So when I say bundles, it's you have an early warning system. You also have heat-proof, low-cost housing in certain kinds of settlements. You have behavioral kinds of solutions that the heat action plans talk of, awareness building and all of that. You have heat risk insurance, parametric insurance, which is being tested out in various parts of the country. So that's a bundle of solutions. But when do I do it? Should I focus on air conditioning? Should I focus on passive cooling? Should I do nature-based solutions? That is what adaptation pathways walk you through. That's a decision support system where we need multi-stakeholder consultations, conversations to say that This is the amount of money we have. This is the kind of capacity we have. And this is the heat risk we have. Now, given this, in different parts of our city, what are the kinds of pathways we have to take? What are the sequences of solutions? That's a very different conversation from pre-heat, during heat, post-heat. These are the 10 things we have to do. It's not easy, but I think that is what the need of the hour is. And of course, apart from heat adaptation pathways, we also need risk pathways. So it's not only to heat or to flood. At the end of the day, risk is complex. It's compounding. Things are happening simultaneously. So an ideal world would be where we've got these pathways for multiple risks, multiple hazards, but I don't think we've reached there. If we can even get to heat adaptation pathways, that will be a big win. Yeah, I'll stop there.
Thanks, Janni. You talked about poverty, and that just leads me to one small question. I mean, you've mentioned, of course, the inequity that comes in due to heat, which cannot even be measured beyond a point. We look at there's a lot of talk about how India is successful in reducing poverty to a huge extent. How is heat going to challenge our momentum on achieving SDGs? What is the sort of multi-dimensional risk that we see, be it towards disease stress like malaria, poverty, inequality, all of this?
Absolutely. I think this is what we say about climate change, right? It's going to depress development in significant ways. And the SDGs are one of the sort of metrics that we use to assess how we're moving towards some of those sustainable development goals. I think there are some SDGs that are, of course, very directly affected. SDG 3 on health and well-being, SDG 8 on decent work, SDG 11 on sustainable cities. These just come to mind. But apart from that, which I think we don't talk enough about, is SDG 5 on gender equality. And I think Dr. Soumya, of course, mentioned that in the morning. We've gotten an extremely underreported and poorly evidenced sector or whatever space of looking at the gendered and intersectional impacts of heat and escalating impacts of heat. So if you look at gender equality, and we've done some assessment a few years ago, looking at how we are thinking about mainstreaming gender in our climate action plans, woefully inadequate. Most of the states were gender blind in their state action plans on climate change, and then very few are sort of focusing on gender targeting. Similarly, we're doing an assessment of the heat action plans, and we find a similar kind of thing, where there's a lot of course, you'll have the common sentence of women are vulnerable to heat. Which women? Women like you and I aren't as exposed or vulnerable to heat as, say, an outdoor worker or indoor workers also. People who don't have access to heat alerts, differently vulnerable. So there's a range of things one has to unpack, I guess, when it comes to SDG 5 in particular. I'd just like to highlight that. But last point to say also that many people sort of confuse poverty and vulnerability. Poverty, of course, many poor people are vulnerable, but not all vulnerable people are poor. So, you have to think about, when you take a particular hazard like heat, where are the pockets of vulnerability? There may be certain groups of people who have access to certain social security measures or something, but the nature of their work is making them particularly vulnerable. So we have to think about those kinds of things as well when talking about poverty and heat risk.
Thanks a lot, Chandni. Dr. Krishnaswamy, if I might come to you, you bring a huge wealth of knowledge on looking at how heat is intersecting with different ecosystems, be it forests, be it biodiversity, water systems, agriculture. Could you explain a little about this to us?
Yeah, so as a community of ecologists and environmental scientists, over the past few decades, we have started learning a bit more about what is likely to be, what is happening and what is likely to happen to our great natural assets, the forests, wetlands, grasslands, and other ecosystems, agroecosystems as well, that sustain us in many ways. So I would like to go back to 1998-99. That was a El Nino year. And in the Western Himalayas, where a region where you would not expect heat stress and so on to be an issue, one thing that struck many of us is that, there's a lot of emphasis on the southwest monsoon for the right reasons. But a lot of our ecosystems depend on the moisture that they get from the winter rainfall and the post-monsoonal rainfall, whether it's convective thunder showers or western disturbances. So basically, after the southwest monsoon, there is quite a bit of moisture that comes to many of our ecosystems. So in that 1998-99 El Nino year, when you would normally get anywhere from 100 to 150 mm or more of rainfall in the post-monsoonal period, the Western Himalayas got rainfall of just double digits. And the forest dried up, especially the broadleaf forests, the oak forests. There was a devastating impact on forests. That's when we started to learn about the impact of a combination of lack of moisture and heat stress. Because as you know, when there is more heat, there is also greater demand for transpiration. And if you look at, India is blessed with a wealth of trees, many species of deciduous and evergreen species, conifers, many other, we have everything. We are just beginning to learn about how these trees are responding to heat stress and moisture stress. So, as we know, we have many deciduous trees which shed their leaves in the beginning of the dry season. That's their adaptation to moisture stress, because we know we have a monsoonal climate with a long dry season. So our forests have evolved with that type of climatic regime. But that is where this moisture, that dose of moisture that you get in the post-southwest monsoon period is very important for the sustenance of many of our forests. Some of these tree species, they, depending on their life history traits, they can shut down photosynthesis, which means that transpiration will also be reduced as a response to moisture stress. Because what happens in a drought and when there is also heat stress combined is that your soil moisture and shallow groundwater on which many of our trees depend can go down very quickly in a matter of few weeks, and you can actually have a flash drought. So, but the trees are faced with a dilemma. If you shut down photosynthesis too often so that your stomata are closed and therefore you won't transpire and lose moisture, you suffer the risk of carbon starvation, because if you don't photosynthesize, you won't be able to sequester carbon. And this carbon is required for investing in new leaves, in secondary compounds to ward off pests that all trees invest in to different amounts, and overall growth and productivity. On the other hand, if the trees decide to take the risk of maintaining transpiration and photosynthesizing, they suffer from a hazard called hydraulic failure, which is basically when the leaves are demanding water and the roots are not able to supply that water, and then there can be hydraulic failure in the tree, which can lead to a lot of damage and in many cases mortality as well. So between hydraulic failure and carbon starvation, many tree species are going to be across this gradient in terms of their response to both heat stress and moisture stress. And we are just beginning to learn about which of our trees are likely to be more vulnerable to this type of emerging hazard. So this is just one aspect of it, that we must pay a lot of attention to what is likely to be happening to our forests. Remember that depending on how you count, between 300 to 500 million people depend on our forests in one way or the other for a variety of resources. And therefore they are, and apart from the role that they play for biodiversity conservation, for climatic regulation, hydrologic regulation. So we have to be concerned about this aspect. So that's about how we learned about the Western Himalayas and how they are actually vulnerable to this combination of moisture stress and heat stress. Coming to agroecosystems, we have I think last year we had an alarming study which showed that we have lost about almost 6 million large trees from our farmlands. These are large trees can be detected from using satellite imagery. Now, these large trees are irreplaceable. Apart the amount of shade they provide, the local cooling, microclimatic regulation that they provide, and of course their role in biodiversity support, carbon sequestration, carbon stock, all of that. These large trees are irreplaceable because you might plant 1,000 saplings. There's no way that you're going to match what that large tree has achieved in terms of ecosystem services for many decades to come. So this whole thing about compensating that, large trees can be cut down in many places and we can just replace them with saplings and so on is not going to be doing us a great deal of good in terms of whether it's heat stress mitigation or biodiversity services as well as other ecosystem services. So just to point out that the trees outside forests are going to be a very important part of our of being able to cope with the heat stress and other hazards, environmental hazards in the future. Then from agro-ecosystems, I just want to quickly come to urban ecosystems, where of course there is an increasing emphasis on nature-based solutions. Of course, the government of India actually prefers the term ecosystem-based adaptation, which is a subset of nature-based solutions, which is focused on climate action, like heat stress mitigation and so on. We just have to mention that these green and blue spaces in our cities, which do provide us with cooling services, because through evaporation and transpiration, just like we cool ourselves through perspiration and so on. Now, the water that is required to sustain our green and blue infrastructure in cities is currently coming from fairly good quality water that cities are often importing from other places, other ecosystems, distant places, including Bengaluru, which gets its water from the Kaveri more than 100 kilometers away and pumped 300 meters up. And then the seepages and leakages from that system actually are subsidizing the green and blue infrastructure of Bengaluru. Now, moving forward, if we have to have all the three issues related, water security, biodiversity loss crisis, as well as climate change and heat island effects, the water to sustain our blue and green infrastructure will have to increasingly come from treated wastewater, for example. We need to plan for that. So Bengaluru has started some interesting experiment on using treated wastewater for rejuvenating water bodies and also supplying water for irrigation. There are some concerns and issues around that, but nevertheless, it's something that I think cities, as you know, produce a lot of sewage, and if some of this or a lot of it can be converted into a resource, then I think that our green and blue infrastructure and nature-based solutions will be able to also be sustained in the future. I just want to point out some limitations of nature-based solutions. For example, in areas with high humidity, just like we are not able to cool ourselves through perspiration, and that, like what Dr. Achudra also mentioned, even vegetation or water bodies will not be able to either transpire or evaporate, right? Because there is high humidity, so it constrains the process. Therefore, we have to be careful about relying on nature-based solutions in certain situations where high humidity is becoming an issue, whether it's in coastal areas or in some parts of the country where humidity is going to get changed in the future because of the way in which we are redistributing moisture through large-scale interbasin transfer, changes in irrigation patterns, new cropping patterns, and so on. So, so that is something that we have to watch out for. However, even if you can't have vegetation cooling the city using transpiration in times of high humidity, the shade that they provide is still going to be a very big, I think, benefit. And large trees can provide that benefit a lot. So if you will notice that in many cities, whether it's a hospital or a large campus or a school or institution, there are large trees and even temples and all of these places where many people use. Large trees can provide a lot of shade effects, even in high humidity areas. So that's one thing so that we don't get confused between where to invest in nature-based solutions and how much of it is going to be useful. And one last point I want to make is that that in cities, we have transformed the hydrology, we have transformed the topography, we have transformed many things. Therefore, nature-based solutions, especially green and blue infrastructure, cannot be designed and implemented in isolation from integration with gray infrastructure. Because gray infrastructure is the one that will eventually supply the moisture and maintain the hydrologic connectivity between the catchments in the urbanized catchments and these green and blue infrastructure. So whether it's canals or stormwater drains, bioswales, or any other type of, or nalas, like we used to have a lot of nalas in Delhi, many of them are now gone. These are all going to become very important in the future in terms of hydrologic connectivity. And also it has a bearing on the flood situation. Many of our urbanized areas need this hydrologic connectivity so that you can take, because built up areas, when you have, even if you have 10 or 15 mm of rainfall, they generate a lot of runoff. And you need to take that runoff out of harm's way into areas where they can either infiltrate or can get stored, or they can move into wetlands and so on. So that, I think, is going to be one of the things that we will have to watch out for in terms of urban planning to respond to some of these new challenges because of climate change. So I am going to just end here. One last point I wanted to point out in terms of forests and climate change is that with rising temperature, we are also seeing that forest fires are likely to become more frequent. And forest fires, while in many ecosystems, forest ecosystems in India have always been a part of their overall adaptation and in terms of the response, and people and forests have interacted with each other. Fire has been used as a tool for managing many ecosystems. But now, under climate change, we are actually seeing that you can have a very large amount of forest biomass being easily ignited or flammable. And that is definitely a concern in some parts of the country. It's already happening in places like Uttarakhand and central India. And this will also impact many people who depend on forests for a variety of resources. So this is...
Thank you so much, sir. Actually, I have one small question, and I wanted to take 5 minutes to even see if there is any audience question. But just wanted to ask, are land use patterns adding to the heat stress and desertification in urban areas?
Yeah, I mean, yeah. So yes, I mean, any place where vegetation is removed and is replaced with either bare ground or built up areas, yes, we are going to exacerbate the heat island effect, but we are also reducing the cooling impact of vegetation. So those are things, but also, vegetation helps protect the soil. As you know, parts of northwestern India, even Delhi, has always been the recipient of sand and from the Thar Desert, right? I mean, during the Lu and all that, we used to. Now the thing is that the Aravalis, as well as which extends into Delhi and the green areas, they in some sense used to have some sort of a role in trapping the dust or reducing the impact of. I think that moving forward, as per deserts are a ecosystem in its own right. So there are natural deserts which have a lot of important biodiversity and important cultural and other resources. So that's one thing. But desertification, as per the IPCC and UNDP, is a process of land degradation because of climatic and other stresses. So I think that we have to distinguish between the two and not look at desertification as a land degradation process because of incompatible land use, and not confuse it with the deserts, natural deserts per se. But I just wanted to point out that vegetation can play a key role in helping with dealing with the desertification.
Thank you so much, sir. And thank you to all our very distinguished speakers here. Maybe we can take 5 minutes to just see if there are any audience questions. I know we are a little over time. I see one hand is up there.
Uh, Sir, my name is Akhilesh and I'm a journalist. I write for Caravan. So my question is to Sir Krishna sir and Dr. Chandni. Sir, while doing a story in 2023 in Balia, the heat wave, I visited almost all the victims who died that time. So what I found that most of the victims died, they got affected with heat stroke while they are at home. So I talked to some experts. One of the experts, the source was given by Gunjan. So he said me that only 10% heat stroke is caused directly. I mean exertional heat stroke. And the 90%, I mean the rest of the heat stroke, one can get affected at home or anywhere else, not directly in the sun. So can you impart some light on that, on this? And the second question to Dr. Chandni is that what she is saying ki, poverty is a factor in heat stroke. So I want more elaborated concept on that from you, how it is associated with poverty.
Okay. So I'm really not an expert in health effects of heat, etc. But I'll just take a stab at the question you posed, which is how is it that people who are indoors would have experienced so much heat that they could lose their lives. So I think we in the morning we heard about how there are traditional sort of construction, home building techniques for different regions that people have lived in, and then there are these more modern ways of using concrete and metal sheets, etc., that don't deal with the don't provide protection from heat the same way. So the whether the dwellings that these people were in were somehow are cookie cutter modern buildings with poor ventilation and just poor heat properties, if you will, whether it is that or whether these are the old style houses that people have built to adapt to the local climate. So that I don't know. But my guess is that this is probably one of the reasons. The other possibility is that somehow these people were otherwise vulnerable health-wise because if you have other underlying medical conditions, you're probably a little more vulnerable to heat effects, compounding them and leading to death. But then, like I said, I think Dr. Soumya would be the right person to elaborate on that. And this is my understanding that I have said so far. But I agree with you that the cases of people losing lives in unexpected conditions, we need to look at, we need to understand, because that has a message in how we plan to adapt to these kinds of events in the future.
One more question with this. I think
Akhilesh, you'd posed a question to Chandni as well.
No, to Chandni.
Okay.
Actually, in previous session, some data was given by Dr. Mahapatra and also one doctor sitting there beside him. So they were talking about the data since 1961 till now of heat stroke, and as they mentioned in 1998, 2000 heat stroke death recorded, and also in 2005, what they said. So is there any study of heat stroke in India? I mean, what is the criteria to, I mean, get the data, the accurate data of heat stroke? Because in the 2023 that incident in Balia, most of the people were comorbid, and the doctor denied to accept that the deaths happened due to heat stroke. And the doctor, the CMO, was sacked in couple of days after he accepted that the heat stroke was there. He was sacked by the government. So how can accurate data be prepared for to know the actual condition?
Thank you. I think this is it is a very valid question, but there are challenges in how we record deaths. And I think that is what Dr. Soumya in the morning said, that we need some kind of surveillance and data management system to start. And then, of course, much more regulation around how we record and monitor causes of death. So when you talk to a medical doctor and ask them about, and I've had lots of conversations about this, what would a good system to attribute deaths or stress to heat look like? Currently, the PHCs and the system, the healthcare system that we have, or even in the private sector, people come with issues of heart attacks, urinary tract infections, kidney disease, and all of that. These are very, very clearly in the literature linked with heat, but they could also be because of many other reasons. So that attribution question of how many people are dying because of heat is a difficult one in any case. So coming to your question of, is there any good data set that you can then look at? No, there isn't. And I think NDMA has been for some years talking about developing a whole data management system where, of course, we have our registers of deaths and births in the country, but then how much of it is attributed to heat? Because it's also, I mean, these are sensitive questions, because if you automatically, and now I'm talking more from a climate policy point of view, if you start saying that so many people, without having proper systems of attributing those deaths, if you start saying कि इतने लोग heat की वजह से मर गए, then you are sort of also accepting that we are not doing enough. But it is not clear how many people, the science on attributing that is complex. So that is one thing I want to say. And I think just on the other thing about this indoor heat and why would people indoors die of heat stroke? Again, it comes back to, at least I know Balia is also a hot place. I've been doing some work in North Karnataka, Gulbarga, Kalaburgi now. Regularly temperatures go to 45, even 48 degrees. It's a very, very hot place. It's historically been a hot place. I go and do field work there and ask about heat. No one is ready to, everyone is like, this is our life. This is what summer looks like in Kalburgi. So this underreporting of the heat hazard is another thing that we should keep in mind. So often people will not talk about heat, but not realizing that what they say. But the ways they talk about it is every week, lots of women I've spoken to, all of them now speak about urinary tract infections. How is this normal that every third woman is facing UTI? So that is a symptom for me. That is almost betraying that heat is becoming severe. Lots of people every week, outdoor workers, construction workers, talking about taking, saline drips. So that is a kind of diagnosis. And why I'm saying this also here, because I think there are lots of reporters, that's the kind of diagnosis. People are not going to say climate change is causing it. And, because I'm an outdoor worker, this is happening, or indoor worker. So I think we have to make those connections for ourselves. But no, currently there's no nationally representative data key. These are the number of heat strokes deaths. I mean, heat stroke related deaths. There can be various inferences you can make from existing data sets, which I think many people have, and MSSRF has also put out some studies on gender and climate change and those kind of things.
Thank you, Chandni. And we are quite over. So if I might just thank all our speakers and our panelists and our participants here. Thank you so much for this wonderful discussion and for just taking us through just how completely, I mean, it's just overwhelming on how heat is impacting across every ecosystem, everything that we can kind of imagine. Thank you for joining us. We have one more chat which Kartiki is organizing, and we'll break for lunch after that.
Yes, thank you. In the meantime, Gunjan, may I request you to please present some mementos to the speakers, and please also gather together for a photograph, group photograph. Group photo. It's okay. Group photo. We have some detailed talks around heat action plans since morning. So I think it's perfect for us to bring in some speakers who are now working on heat action plans. They are very much involved in heat action plans, and they are working towards improving those. I would like to introduce two of our panelists. One, so to begin with, Mr. Vishwas Chitle, Senior Program Lead, Climate Resilience Council on Energy, Environment and Water. Vishwas leads some of India's most robust data-driven initiative to support governments in building climate risk preparedness, especially around heat, flood, and urban vulnerability. Then we have Aditya Valyathan Pillai, Visiting Fellow, Sustainable Futures Collaborative. Aditya is a climate policy researcher working on resilience, urban climate planning, and state capacity for adaptation, contributing to heat governance studies. This will be a 30-minute interactive exchange on governance, capacity gaps, and smart planning tools available for states and cities. So we'll begin with Vishwas. What do you feel? How are cities and states experiencing heat differently, and how does that influence their preparedness and response strategies?
Yeah, thank you for having me on the panel, Kartiki. And it's great that we have this India Heat Summit right when the North Indian belt is facing the heat. How different cities in India are facing the challenge of heat stress. Actually, we have also published a study on heat risk index that was published last week itself. Some facts and figures from there. What we have seen is maybe all of us are aware that the number of very hot days have increased in the past. That we can also acknowledge because we experience that when we go outdoors. But also what is staggering is the trend of warming of increase in number of very warm nights is even exceeding that to the number of very hot days. So this is especially concerning because first of all we are not able to acknowledge that okay, number of warm nights are increasing and that they are having adverse impacts on our body. And in terms of say heat stress, I mean, the overall statistics from the study suggest that nearly 57% of districts in India and nearly 75% of population of India that resides in these districts is exposed to high and very high heat risk. There are cities like say Delhi, Mumbai, Chennai, Bangalore, like all these metros are of course there in the high and very high category of risk. There are many other cities also of say tier 2, tier 3 nature, which are rapidly urbanizing and also are falling in this high and very high category of risk. So this is the current status of how cities are facing the risk in terms of heat stress. When it comes to what was the follow-up question?
How does that influence preparedness and
Yes.
response?
See, just look at the case of, say, Mumbai, or even say some of the Maharashtrian, Maharashtra cities, and also for that matter, let's look at the example of Delhi last year. In the end of June, when there was severe heat crisis and there was massive long duration heat waves occurring, suddenly on the next day there was excessive rainfall. So this preparedness, if we look at it as a seasonal perspective, that okay, during the summer we need to prepare for heat, it's not going to be anymore like that. And I think also in the earlier panel, Professor Achyuta Rao highlighted that we are going to see heat waves from all the way starting in February and going all the way up to monsoon, say in July and August. So we are, especially we are talking about 6 months long duration of heat wave, or not heat wave, but heat stress, and we have to prepare for it accordingly. And then in some parts of India, like say in case of Maharashtra, the October heat is something that is also causing a lot of problems during the post monsoon season. So October, November, December are also becoming kind of warmer periods of heat. So I feel that we need a year-round resilience, year-round planning for addressing these kind of challenges.
Thank you, Vishwas. Coming to Aditya, from your work, how would you describe the current state of heat governance in India at sub-national level?
Can you hear me? Is this okay? Okay, thank you for having me. And I'm sorry I couldn't be there today in person for this installation of the Heat Summit. The current state of heat planning and governance, I think, is characterized by a focus on short-term actions, which is essentially actions that have the effect of preparing for an impending heat wave, right? So this includes things like getting, water stations and cooling stations ready, converting temporary cooling stations, making sure there's enough health capacity, that sort of thing, making sure, you're able to deal with a possible rise in heat stroke, etc. We did a study over the course of the last year where we went to effectively 11% of India's urban population, 9 cities. And we tried to look at what exactly they were doing. And we found that the vast majority of actions that were reported by these cities were in the short-term bracket, which is the effect lasts for just that summer. Where they really were lacking was in terms of long-term planning, right? And this means bringing structural change. And I think previous panelists have spoken to varying degrees about the potential for and possibility of long-term actions. And this includes things like changing the structure of the city, right? The way your city is built, how many green spaces you have, how dense your informal settlements and slum areas are, etc. And this is one area where it's impossibly hard to do. And we spoke, I think, to about 88 respondents from government. We spoke only to government officials to ask them what they were doing and why they were doing it. The long-term actions are much harder to do because it's quite politically difficult to actually place heat actions in areas that need heat resilience, right? So if you think about very dense parts of the city, there's very little land, which means you can plant less. It's much harder to plant trees, or it's much harder to change the offsets on the side of the streets so that you have more sort of space and less density. So these sorts of things sort of tend to compound each other. And over time, you have not only climate change, but also extremely hot urban environments that sort of interact with each other to create these hot boxes. This is the actual solution side of it, right? There's a whole separate scene happening in the background, which is the way the institutions and the financing are structured. And this is quite critical, right? Because at the moment, you have a policy structure that is not formalized at all. heat action plans don't have legal grounding. They don't have, most of them don't have financial backing. And I know there are efforts underway to try and build more financial structure around heat action plans. But at the moment, it is purely based on the voluntary initiative of local governments. And I think it's important to remember that. So it's much easier to do short-term actions that are cheaper and much harder to think about more expensive, more time intensive, more focused, concentrated long-term actions. So at some point, the point we tried to make is we might be doing an okay job at structuring short-term actions and getting to a basic level of implementation. There's a lot of variation between cities. It's not like every city has reached that basic level of implementing short-term life-saving actions. But the moment you start thinking about guarding against future heat, you're going to hit a bit of a brick wall. There is going to be a threshold because we haven't started preparing for future heat. We're just about trying to deal with the heat of the present and the past. And unless you have a more robust policy system, local governments aren't going to be able to deal with these problems.
Okay, my next question is to for both of you. Could you share some examples of Indian cities or states that have implemented effective heat action plans or other heat resilience strategies? What made these examples successful?
Aditya, do you want to take this first?
Go ahead, Vishwas. I just spoke for 5 minutes.
So I think in terms of implementation of heat action plans, and as Aditya highlighted, I mean, the topic actually is fairly new to the cities in terms of like, the syllabus that they have had so far. So they have been dealing with floods, maybe urban flooding as a challenge because it is much more visible. It causes damage to infrastructure, it causes damage to people. But in case of heat, it is somewhat like an invisible disaster. And that's where the role of identifying where the heat risk is high within your city becomes very important. But in terms of heat action plans, yeah, I mean, last year we supported Thane city to develop their heat action plan, and that was also very well taken up for implementation by them. But again, like, since maybe many of us were not yet aware of what exactly do we mean by these long-term mitigation strategies that need to be implemented. So again, it was more focused on, say, short-term actions like, say, water dispensing facilities, maybe regular health checkups in wards which are highly vulnerable or at risk. Then we also conducted a training for health sector preparedness, like all the ASHA workers and those basically who are in the health sector, those who are working on the ground. How can you identify heat-related illness? How can you treat a heat-related illness, etc.? So some sort of preparedness mechanism went in there. But I think if we talk about some of the success stories of, say, long-term mitigation, I think, I mean, this year we have supported 10 cities of Odisha, 10 cities of Gujarat, 11 cities of Tamil Nadu to develop heat action plans. So we should look at these success stories next year because this year the baseline kind of assessment has been ready. But one example that comes to my mind is from Chennai city. I think many cities in India are currently in the process of developing their master plans or development plans, which will be relevant for next 20 years. So what Chennai Metropolitan Authority has been able to do that is to map urban heat islands within Chennai city and then get those included as part of a risk assessment mechanism in the master plan. And then there are certain long-term actions that are linked with it. So at least, like, this is an example which shows us a way how to incorporate existing heat risk and how do you address that in the longest term.
Any word from you, Aditya?
Yeah, I just want to agree with Vishwas. I think it's very, very early in the game to be able to say this is the benchmark for what a good implementation story looks like in a city. It's way too early. I think the way to think about it is a lot of cities and states are now activating themselves, which is the story Vishwas just said, right? So Chennai is doing the urban heat islands, Thane is doing something. Delhi this year started implementing. Kerala is doing a bunch of stuff. Gujarat, we know, has done things for a very long time. There are bits and pieces of each of these implementation stories that are kind of stand out and are worth thinking about replicating in other places. But I don't think there's any single place that has done the full gamut of things that we should define as a benchmark for success, right? Which is thinking about the long term, building the data pipelines, making sure there's adequate met information, urban heat islands, temperature thresholds, debt surveillance, like we were talking about in the previous one, full gamut of solutions that are linked to the hazard, counting all the vulnerabilities, making sure you have a vulnerability assessment, risk assessment. I don't think there's a single place that has joined it all up together, stitched up a perfect sort of implementation, right? So we're quite away from it. And I think right now we're at the point of just picking up bits and pieces of different places. And maybe at some point in the next couple of years, we'll see somebody stitch the whole set of actions together.
So we believe that this process is at a nascent stage, but where do you see the biggest bottlenecks? Is it the finance, or do you think that there's technical gaps, or what is that? Something else?
Yeah. Sure. I think maybe if I can quickly show the slides on heat risk, just quickly to give you a sense of where the challenge lies. See, in terms of challenges, there are various sets of challenges. Of course, as I said, the syllabus is very new. So to understand what a heat risk I mean, what kind of damage a heat risk can cause to the population, to the infrastructure, and many other bits is very difficult to acknowledge. Can we go to the next slide? Yeah. Yeah, actually, you can go to the next one, the maps. So this is just quickly to show you how the heat risk has been evolving in the Indian landscape, and I just have 5 maps to show you. So this map shows increase in frequency of very hot days in last 10 years compared to 30 years before that. And you can very clearly see that the parts of, say, Jammu Kashmir, Uttarakhand, Himachal Pradesh, also in the northeastern state, northeastern states, we are seeing that there are hotspots of increase of up to 10 to 12 days of very hot nature in the past. But also look at the coastline on the western coast. We are seeing the increase of up to 6 to 7 days. Next one, please. Now, but the story is here, like, increase in number of frequency of very warm nights is something that I also mentioned is very concerning. Many of you might say that in desert parts of India, the days are very hot, but at night it it cools down by quite a bit. But that's no more a reality now. When we developed the heat action plans for 10 cities of Gujarat, and especially Bhuj was one of the city, it was clearly highlighted by the government officials also that at night it is not getting cooler at all. It still stays above 30 degrees Celsius, 32 degrees Celsius, and this can be very clearly seen from the maps. The next one, please. Also, when it comes to relative humidity, I think someone talked about it in the past panel as well. Look at the Indo-Gangetic plains and look at the trend of increase in relative humidity, which is almost up to 10% of increase in the relative humidity context in last 10 years. And then I think the last map of heat risk. Yeah. So this is the overall heat risk in the context of Indian districts. See, I mean, this study was launched last week. So till that time, there was no data on how different districts in India are facing heat risk or what has happened in the quantification of heat risk in the past. So now with this data, we hope that at least the challenge of availability of data, availability of information on how and where the heat risk lies could be solved. Now the next, next one, please. Now the next step is that in case of heat action plans, and especially the pace at which it needs to be developed. So this is just to put it in context that, I mean, this was of course Aditya's study that highlighted that nearly 95% of heat action plans till 2023 lacked heat risk assessment. So basically they did not have a lot of inputs on where in your city the heat risk lies. So that we are trying to address when we are supporting these 300 cities in India to develop the heat action plans. But also if we want to achieve that pace, like, individually, if we go one by one in the cities to develop heat action plans, it will take us nearly 10 to 12 years to achieve that full scale of all the cities having that. So I think one challenge is also there. How do we accelerate the pace of development of heat action plans? And then comes the next challenge of how do we bring in finance? And Aditya touched upon some points. currently at national level, there is some discussion going on what kind of funds can be allocated to heat mitigation strategies, heat mitigation plans, and some sort of funds that can be made available to the cities. But I think, I mean, yeah, just to summarize, the challenge lies in terms of data, access to data. The challenge lies in terms of accelerated, pace of work that we need to follow, and finance. But also one challenge lies on the current capacity to address all of this. So once even identifying, okay, where the heat risk lies, we again will have to put efforts on enhancing and strengthening the capacity of the cities in order to build, focus more on these long-term mitigation strategies rather than focusing short-term mitigation, short-term response strategies. Yeah.
Over to you, Aditya.
Yeah, thanks. I just want to dwell on the map Vishwas just showed from his from CW's latest study. The thing that struck me in terms of the heat risk is how widespread it is, right? That entire western southern corridor, and then is the highest category of heat risk, and then the second highest category basically stretches through most of the country, 75–80% of the landmass of the country of mainland India. The thing that worries me about that is each of those districts and cities has to solve that governance problem itself locally, right? And I just want to build on Vishwas's presentation by just showing you 2 or 3 slides of what exactly the problems are at each of these districts and cities, what we presume to be the problem in each of these cities, right? So I just want to touch upon the thing that we've talked about, which is funding, but also the overall governance structure and how we put all of this together in each of those places in red and orange. The first thing I want to show, and I hope you can see this, is on the funding side, and these are results from the paper we published a few months ago. We were kind of surprised at how much cities were reporting that they had adequate funding for heat, right? And this includes places in the dark red that Vishwas showed. And to me, it was mind-boggling. I thought, well, no, there's not enough funding in the system, et cetera, et cetera. There is a supply problem with finance, true, but there's also a demand problem with finance, which is you need to expand the imagination of local governments to get them to think about solutions that actually require money to implement, right? And this goes back to that story of long-term versus short-term. The short-term stuff is easy to do and it's less expensive, it's temporary, it's ephemeral. And so you have a large green 69%. You actually want that to be much, much smaller as the sophistication of implementation improves in the coming years. Here's a positive story about it, and this is a general trend across the places we visited, across effectively 11% of India's urban population. Local government officials are already pooling money from different sources, right? So these are the different sources, and you see most of it is local departmental budgets or state departmental budgets, but then, which is the green on the right. But then you see 19%, 16%, 13% state government, central funding, private finance. There's already pooling happening in the system, which is a good thing, which means where they're implementing, they're actually pulling from different places. So this is partly the finance story. One big problem is where the demand for action is coming from. And I'd love to know what Vishwas thinks about this. But what we found is the demand is not necessarily coming directly from the people, right? So it's not like people are petitioning government for action. A lot of this is happening through institutional channels. So NGOs, civil society organizations talk to governments. Governments say, okay, there is something going on, we need to fix it. And then they go try fixing it. All media and reports of deaths, right? That seems to be a very big driver of action. Where heat demand comes from the public is not for heat per se, not for heat resilience per se, but it's for drinking water, it's for Bijli, it is for ORS, etc. It's not categorized as heat resilience. So what you get in the democratic framework is people asking for a set of very discrete solutions. And somewhere in the background, somebody has to stitch it all together and say, okay, this is actually a heat resilience plan. I'll very quickly end with this. All you need to look at is this is self-reported bottlenecks, right? Karthi, to your question of what are the problems. Self-reported bottlenecks from heat plan implementers in these cities. Look at all responses. The number one problem that they report, and this is across various sectors, so the sectors are below, the top is all responses. Number one problem is coordination, right? Heat is a multi-departmental effort. Usually you'll have a disaster management authority or a health department managing the heat file. They have to get the electricity department, water department, waste department, transport department to play ball with them in implementing the heat plans. That's where the implementation starts failing. The second thing is these are short-staffed departments most of the time, and they have a ton of competing priorities, right? I remember one official said, look, it's heat today, and then it's flooding tomorrow, and then it's dengue season, and I'm lurching from one disaster to the other, and we don't have enough people to deal with all of this, right? And that's a common story across the board. So this is nuts and bolts stuff of getting departments to cooperate with each other, getting them to solve the capacity problem. And then you'll see there's a whole bunch of other things, which is weak technical capacity. They report inadequate finance. And they also say that the HAPs need some sort of legal mandate. So yeah, this is sort of the overview. I think this story is going to have to play out in each of those dark red districts and orange districts that Vishwas just showed out. You're going to have to solve this problem in each of those places, which is why this is such a big governance challenge.
Thanks, Aditya. So, okay, so it seems that it's quite a big challenge for big cities only. Leave the smaller rural towns alone. But how can a state government better support smaller town or rural areas in developing heat action plan, which may not have that capacity on their own to develop one?
Yeah, I think, I mean, if we talk about, as I said, development of heat action plans, we definitely need to accelerate the pace and we need to bring some innovation into the process. So when we talk about technology being developed for anything else that we talk about, why can't we have technological innovation that can solve the problem of development of heat action plans that can partially be, say, some sort of automation, and then some sort of bottom up approach with authorities reporting on certain perception kind of survey, etc. So we should look into how do we blend these two approaches. But also, I think when we talk about smaller towns needing a heat action plan, I think even before that, the states need to focus much more on the urbanized cities and large scale cities for whom the problem is right here, right now. Maybe in the smaller towns, because of not so much urbanized or because of not having that much of population density or total population, the problem or the exposure might be still less compared to the large scale urbanized cities. So I would still suggest that much more focus needs to be on how do we address that in the large big sized cities versus rural population, of course. But the challenges that rural population is going to face are of different nature, so we might have to think differently in that case.
Okay, Aditya, any word on this?
Yeah, yeah, I think it is a very tricky question about how to support local government, right? I think one thing to be very mindful of is that India's federal structure is such that local governments have relatively less capacity and finance and bureaucratic resources than higher levels of government, right? So when you get to the central government, it's a very sort of top-heavy federal system. It is very, very important to think about that linkage between the center and the city and the district and the way that looks, right? And so the financial pipeline is going to be partially dedicated heat financing from the center to the districts and states through the finance commission mechanism, through centrally sponsored schemes, et cetera, et cetera. We are yet to build those linkages, right? And that really needs to happen. So that's the supply side. I really do think right now the need of the hour on the demand side from the local implementers is really getting them to understand that this is a problem and why it is a problem, right? We are now at a stage where people are beginning to recognize it as an issue, but that's it. There's a whole second layer of what do we know that works, right? How do you plug into conversations like the one you're organizing here, that NDMA organizes, the CEW organizes? How do you get them to plug into this heat community that has now been built in the last couple of years? You have to plug them in. You have to give them the contacts. There's a lot of very basic nuts and bolts stuff. You need to give them international exposure. One of the things we found in our study is having organizations embedded with and working with local governments is hugely important. The cities that we saw that were doing well had a local civil society partner that was carrying the weight for them. So ultimately, you can outsource a lot of the thinking and some of the implementation impetus to a civil society organization. And there are tons of organizations that are starting to do that. They're also established players, right? So we saw the presence of NRDC, CEW, C40, WRI. So these are all organizations that are playing a role in the climate adaptation space and embedding with organizations. So I'd say that's the third sort of very big thing. Encourage civil society to embed with local governments and give them the funding to do it, give them the space to do it. I think is super important.
Okay, thank you so much, Aditya and Vishwas, for sharing these practical perspective with us. This brings us to the end of our chat session. So time is very limited, and I'm really sorry for eating into your lunchtime, but there's one question from the guest.
Yeah.
So I'm taking some input from the previous session in terms of the need for restoring what presented Dr. Natural Resources. And from what I'm taking from your session in terms of needing for a long-term planning, and the metric right now is catering to the short-term strategies. Can we look at, say, the environmental impact assessment for large infrastructure projects, which impact, say, like ecosystem components, or say, like in the cities itself, as a way of integrating heat, building scenarios for heat stress and addressing something like this, using they can talk to each other. We're not just talking about short term, but also looking at the long-term plan.
Yeah, no, thanks. That's a very important question. So yes, of course, I mean, EI is one way to address this challenge, to look at what kind of adverse impact that ecosystem is going to face, or that, say, city is going to face if we are to set up a new township in that particular locality. And then I'm sure that there is a lot of research. I think 2 years back, there was a research that highlighted that the problem of heat stress is not only to be accounted to climate change, but majority of it is also to be accounted to rapid urbanization. So that kind of assessment can very well be done in case of a EI. But also, I think we should look into how do we embed this heat risk assessment in development plans of various cities which are currently in process of development for next 20 years, master plans of various cities, so that if it gets embedded in that process once, then there is a high likely chance that there will be continuation of these kind of things.
I think that brings us to the end of session. We now break for lunch. We will try and convene at 2:45. I know it's a shorter lunch, but yes.
Sure. Thank you.
Thank you.
Thank you, Aditya.
Yeah.
You would like to say? The dual threats of India's energy system in a warming climate. It explores the growing risk that rising temperatures pose to both energy infrastructure as well as energy demand, from increasing electricity loads to the challenges of keeping thermal power plants cool and operational under heat stress. Moderating this session is Ms. Archana Chaudhary, Associate Director at Climate Trends. Joining her on this Power Pack panel are Mr. Alok Kumar, former Secretary, Ministry of Power, a veteran policy leader with deep insight into India's energy transition. Mr. Prafulla Pathak, President, Solar Energy Society of India, an advocate for decentralized solar innovation and rural energy access. Mr. Mohit Bhargava, Senior Advisor at UC Barclays India Energy and Climate Center, and former CEO of NTPC Green Energy. He has over 35 years of leadership across India's power ecosystem. Next would be Mr. PC Garg, Principal Advisor, National Solar Energy Federation of India, who brings critical insights for India's solar manufacturing and deployment landscape. Ms. Shwetal Kulkarni, Fellow at Prayas Energy Group, a specialist in energy efficiency, demand-side management, and equity in energy access. Together, they will examine the vulnerabilities in India's energy system and the solution to safeguard both supply and sustainability. With that, over to you, Archana.
Thank you so much, Kartiki. And welcome back. I'm not going to say trite things like this is a difficult session because it's post-lunch, but welcome back and thank you so much for your interest in this very important issue. And I think we all have a fairly good overview since morning, so I will not spend a lot of time talking or introducing any concept to you all because all of you all are really invested stakeholders. All of you all understand what is at risk and that is why you all are in the room. Let's talk about today. In this session, we hope to understand how the most critical of our systems that needs to respond to the rising heat risks is prepared or how it should prepare. And we're hoping to seek some insights on these issues from these very senior panelists here. I would like to start with Alok Kumar, sir. Let's start with your, given your deep experience and your wide understanding of everything energy. Let's come to you. Let's start right away with the kind of policy and regulatory systems that need to be put in place to address and prepare India's energy architecture. Given the kind of heat risks that India faces, we've seen the map, we've seen how dire the circumstances are. If you can.
Thank you so much. My pleasure. I'm very happy to be here this afternoon. See, there are certain physical risks to our systems and also impact of heat on their performance. Those can be factored into the planning. The main objective of the policymakers and regulators has to be to do a much better, much accurate, much granular forecasting of demand and generation. Because power systems can cope up only on the basis of capacity to generate and capacity to transmit and capacity to distribute. And these capacities can't be created in months, they take years to create. So the first important thing is that you forecast both demand and generation in a way that you are well prepared for all possible risks, having a reasonable probability. Now, we are living in the world of the demand is so uncertain. The large loads, even US is now thinking all the data centers projects announced, many of them are not going to come. The impact of the regulatory measures like time of day tariffs, these are difficult to assess that how much load will be shifting to daytime from the evening peak. And weather-related uncertainties are very well known. We are already seeing them. Similarly, on generation side, we are all aware the type of variations we see in solar and wind generation, and their share of supply is increasing. So there are two important things which we have to address. First is very robust planning. we have enough capacities and enough reserves. And second is the other operations. So when you operate the given capacity, and sorry, you want something? Just a minute. So once you operate a system with the given capacity, then you have to do more of operational planning, outage planning, and also see what are the economic incentives required for the right type of capacities to come to face them. So I've also written it extensively. The present regime of the long-term PPAs with Discom Center, they will not be adequate. They will, of course, will continue to have bedrock like around 70–80%, but you need to have different market structures. If you see in the last week, the prices in the power exchanges, they have almost turned near zero in the day. So can you believe which capacity, which investor will put in the capacity to face those prices? No. So you have to have good capacity remuneration mechanisms so that they make themselves available when you need them. And if they fail, then there are very stiff penalties. In the PPAs we have currently, the availability is judged on an annual basis. So he is happily getting 85%, but he is not available at the moment the system is facing stress due to heat. So we need very, very different focus in our long-term planning, in operational planning, and also in the market structures. I'll stop at that for the time being. Thank you.
Thank you. Thank you so much. I'd like to move next on to Mr. Mohit Bhargava. And if you can come in, Mr. Bhargava, and talk a little bit about how you're seeing, because what Sir says in terms of the balance that is required and the capacity planning that is required, how does green energy fit into this? Because we're talking about transition, but how does that, these dual goals of ensuring that there is stable power available and we know when it is available and we know how to plan it, and at the same time, how do you then scale up power? Because we recently saw what happened in Spain, where folks immediately turned around and said it was renewable energy, and which is the reason why they had a power outage. We still don't know what the reason was. How do we then balance our plans for transition with ensuring that we have stable power systems?
Good afternoon, and thank you for having me. Probably a very important point, which I also think does not have a very good answer at any given point of time. So Alok sir did raise a lot of issue about planning and all, which is definitely very important, and we all saw, and I must compliment that during his tenure, a lot of this got very seriously institutionalized in terms of, for example, the states getting onto the preparing the resource adequacy plans and so on and so forth. Renewables are here to stay. So I think probably I'll start with that. Whatever we might add, that is what is required, because we cannot be adding a lot of other capacities like coal capacity or fossil fuel based capacity, because there are additional costs at some point which have to be borne. So renewables are here to stay, but the challenge is a bit different. For whatever reason, there has been a lot of thrust in, if you look at conducting auctions. And at some point, the government did decide that we need to do a lot of auctions because we have a target of doing 500 gigawatts by 2030. So it was actually backward calculated and 50 gigawatt auction started. But someone forgot to tell the state guys, I mean, look, you have to buy this power. But then state guy was smart. He said, why should I buy? I already have enough power. And what do I do with so much solar? Exactly pointed out by Alok sir. So much capacity is there during the daytime that if the demand falls even by 10 or 20 gigawatts, exchange goes to like 10 paisa. So there are possibly solutions to this, and we'll have to be alive to this situation. So let me take just one example. We have today in operation about 100 odd gigawatts of solar and about 50 odd gigawatts of wind. Please correct me if I'm wrong here. And a lot of this solar comes during the daytime. And obviously during the daytime, there's also thermal. Demand during the day, even though it has increased significantly, it's probably not at that level at which we expected. So why not we allow a lot of this solar, which is now becoming in a way surplus and not getting into the grid because no one wants it, to be fed into a storage system? So government has allowed storage, but probably there's a need to allow some changes in the existing PPAs as a system that all the PPAs which have been signed earlier for solar alone, for example, they may be allowed to be tweaked to allow battery to be added to them. Let it give it to states. I'm not saying let again ask SECI or NTPC to do these auctions. States should be given this template that here's a template wherein you can allow significant or minor changes in the PPA, which will allow this surplus solar to get into the storage. Because everything said and done, if we look at all the computations, whether CA or whether India Energy and Climate Center, where also we have done these projections of demand, we have seen that at least over the next 4 to 5 years, the peak demand is where all the shortages will remain. Whether we look at 4 hours in the peak time, 5 hours, but there will be significant shortages. And at least till 2030, it appears almost improbable that we'll be able to plug the demand unless until the demand doesn't grow at all. So one quick solution is this. So similarly, RE integration, and I think probably Mr. Garg will talk about this more when you bring him in, but RE integration is a challenge. And this is something which the government, when I was in NTPC, we were very aware of the situation that the moment we hit a certain number, there is going to be a challenge as to how to manage the grid. But having said that, we probably need to avoid, if I may say so, knee-jerk reactions. Because today what is also happening on the other hand, in the name of so much power coming to the grid, the RLDCs are actually giving schedule for 2% capacity. So in NTPC, I was told for a 2000 megawatt plant, the schedule given during some time blocks was 19 megawatt. Now, someone has to apply their mind and find out how can that plant run at 19? Because after 4 time blocks, you're saying come back to 800 megawatt. So these are things which need to be handled. So right now, I'm probably trying to raise more questions, but there are answers, like one answer I gave that. Let's allow more storage because battery storage at least can come into the system very, very quickly. Maybe 8 to 10 months if we really move quickly, or at least definitely between 12 to 14 months. This will at least prepare us to manage the peak shortages better. This will also enable us to take care of the renewable integration and not allow unnecessary, power going waste. Electrons are there and no one is buying them.
Thank you. Thank you. That's a very valid point that you've raised, which takes me, because you're talking about solar and what solar capacities and storage. Actually, if we can take one step back and ask a question, Mr. Garg, we're talking about extreme heat today, and solar panels. One of the things that is said about solar panels is that the efficiency of solar panels and other renewable infrastructure comes under strain when there is extreme heat. Can you talk us through whether how that can be mitigated and whether that is actually happening on the ground?
As we all know from the basic electrical system says, when temperature goes up, everything loses the efficiency. Okay. So same thing happens with the solar panels, not only solar panels, with the wind turbines also. When I was in CTU, we were struggling in granting connectivity to the wind developers because we wanted that the turbines should generate full power at 45 degree. And most of the turbines which are at present supplied in India, they start derating at 40 degree. At 45 degree, they become almost zero. The reason is that these all designs are pertaining to Western countries where the temperature never goes to that level. And as it is, the things are coming to our country. So no improvement has been done on cooling system and all that. So as far as the temperature is concerned, it is derating both solar as well as wind. Now in solar, there is a dual risk. When temperature rises, the solar generation goes down, but at the same time, your consumption goes up. Load requirement goes up, ACs are switched on and all those things. So it has got a dual problem. Now in solar panels, there is a solution. Like in wind turbine also, when connectivity was denied, then most of the developers, most of the manufacturers, they came and they said, okay, sir, we have modified it. And now my turbine will not be derated at up to 45 degrees. So that means there are solutions. Some cooling system has to be improved so that the efficiency doesn't go down. Similarly, in case of solar panels, now good technology is available. Some heat resistant coatings are there, which can be provided on the panels and their efficiency doesn't go down. Bifacial panels are there. So whatever efficiency goes down, that is because if we go for a bifacial panel, it increases the efficiency by 5 to 10%. So that much of reduction in efficiency with high temperature can be mitigated by bifacial panels also. Of course, there is an incremental cost. Another solution, as Mohitji told, sir also indicated, we have to go for the storage. Now, this storage, I am not talking about the storage to supply in the night, to provide electricity during the non-solar hours. I am talking about this problem itself. If every developer, they put some storage, some battery storage along with their solar generation, then in the event of any such exigency where the temperature goes very high, but there are situations during the day when there is excess of generation. There is excess of generation. That generation can be stored in the batteries. And when situation arises that the solar panel loses its efficiency, that time the battery can discharge and they can maintain the load. And if suppose that contingency doesn't arise during the day, then there is a demand in the evening hours. That small quantum of energy stored in the battery can very well be discharged in the non-solar hours. So there will not be any issue for the developer. So these are few things we'll discuss further, that how to go ahead with all this. But these are the solutions for mitigating this problem. Thank you.
Certainly. And thank you for talking about solutions, because I was coming to Mr. Pathak, because that was something that we would like to hear a little bit more from you on the kind of innovations and standards that are emerging that can help solar installations become more climate resilient. And if you can talk us through a bit of how the efficiency can be increased, and how do you keep optimal energy output, especially during heat waves?
Yeah, I'm very much thankful to be here today, and particularly the theme of today's event, rising temperature and shared solutions. So just give a brief about myself. I will take your question, but before that, I belong to a city of Nagpur, Maharashtra. And this rising temperature was there for us. That's an important factor for us since our childhood. Means even our relatives who are staying away or on other part of the country, they were saying we are not going to come to your place between February to May and June. And at that juncture of time, I always had a thought that why not to use this sun or heat energy, so that whatever the problems we are facing, we can get rid of those problems because of what we are facing the problem. So same thing applies here. We are in the process of evolving. When we were discussing with the panelists, I'll just give you some information. When we had an independence, at that time the installed capacity was 1000 megawatt. And in 2010 or 12, we had an installed capacity of 1,25,000 megawatt in India. And now we have crossed 5 lakh megawatt. So this is what has happened in our country. Why I am sharing all this data or all these figures, that we are in the process of evolving. So when we were short of the electricity, we were facing the problems of the electricity, the things have moved to solar. And when we moved to solar, there were initial days, particularly before 2010, nobody was that much confident, or nobody was ready to move to solar. But whatever the policies that has come up and the motivation that has come up, the private players come in, and the solar situation has moved from somewhere it was 15 rupees per unit to now we are 3 rupees plus minus we are getting, or even less than that. So my point is, we are in the process of evolving. So when these type of installations of photovoltaic and all that happened, definitely everyone was trying to put whatever the data or whatever the information they have. And as rightly pointed out by Mr. Garg, whatever the systems those were there, those come to India, those were designed for the European or those countries, and where the temperature was not at that level. Secondly, when we do something, whatever we do, the first word which comes is affordability. So whatever we are doing, is it affordable? So initially, everything is such that it is in research stage or in initial stage, so nothing is affordable. But as we move ahead and get a scaling, then we will find out that that thing will get affordable to us. Mobile is a good example of that. Similar happened in solar. So whatever the installations that has been carried out, in an area where the land cost was less. So the option is to go there. But that type of study, that whether this 45 degrees temperature, if it crosses and then will the panel burns and all that, those were not there. So now when we come across all these things, definitely we are working on that. The things trying to improve those things, those are going on. But yes, whatever the efficiency we learn, that is there, and it has that problem of that is goes above particular temperature, it has a problem. But secondly, another thing which as a Solar Energy Society of India or as a person, when I look at, we welcome this heat, because the another part of solar sector means solar PV is, many of you knows about solar PV, but there is a solar concentrator technology, there is solar thermal technology, and in fact, the one thing which I would like to share with you, I think some 10 years back, when first time 500 megawatt targets were set before this government come, there was a chunk of allocation to the solar thermal. Ms. Sunita Narayan stressed for that, and because of that 100 megawatt, I think that figure was finalized that it will go for solar thermal. But unfortunately, or maybe because of technology, or maybe because of those have taken the interest of a plug and play type of photovoltaic, the solar photovoltaic grows like anything. Because everyone was sure that if I go with solar photovoltaic, that is the easiest thing. And solar thermal or solar concentrated technology remains at a really a back foot. So that one clip I have, which I will show in my deliberation, that gives that now whatever this problem of heat, that can be solved, or that can have an option with the help of solar concentrated technology. What is happening is, we have, you might have heard that at Brahmakumari, they had some arrangement where they were having a solar dishes installed for a steam, and then they used to prepare food with that somewhere 15 years ago. So similar operations were there. Even UNIDO had some project wherein this solar thermal was used. And even I know one location in Maharashtra where the person who had an iron setup, ironing, he used to have this steam for the purpose of ironing. So that is also good help to climate change and all that. So what I want to share with you is, now if you look at as a PV photovoltaic, yes, we have achieved. At the same time, we have some issues. But if we move to solar thermal or something like that, then we are in a position to get a steam out of the solar and water. And once you have a steam, there are enormous applications which you can. Even in our thermal power plants, we use this steam. The only thing is, again, the affordability. Whatever the technology I am going to show you, a small part, it is not scaled, so it is a costly affair at this moment. But if we work on that, if some research should go on that technology and all these things and its applications, definitely all these heat problems will not be there, and maybe there will be a day when we welcome the heat. So I want to show that.
That's an interesting
small
thought.
clip.
Yeah, let's play the clip.
I will explain it later. Can you get a sound? It says that there is a 1000 degree temperature at that point. So this is a 5-storied building height dish installed near Baroda. They say it as a big dish. And because of this dish, whatever the heat that comes in, they can convert it into a steam. And once it's a clean technology. Because otherwise, if I have to make a steam in my thermal power plant, so I have to have a mining of coal, then I have to transport it to from mine to my power plant. Sometimes it may be 700 kilometers from that place. So then after taking it to coal to the power plant, then I have to make it to such a granule level so that I can process it into my boiler. And after putting it into the boiler, then I am in a position to get a steam, and then that steam I am using it for my future process. Of course, there are some limitations. It is not that same steam can be used. But yes, once you have a steam, you can drive a steam engine. Once you have a steam, you can get rid of boilers which are consuming the fossil fuels. So these type of options are in a process. These are the available. The only thing is that scaling and some research activities are yet to be done. But if we could do this, we will welcome this rising temperature.
That's an interesting thought, but and a very interesting clip on the technologies that are available. We'll come back to this. But while we're talking about where things are at the moment, let's go to Shweta. Shweta, who I believe you have a presentation that you wanted to
No, I think
make
we can
quickly.
just
We
talk
can just
in
talk
the-
about
yeah.
this. So can we, would you like to talk a little bit about your work on the systemic vulnerabilities that you're seeing currently in the Indian power sector?
Thanks for having us here. And it's actually a great pleasure for me to be here with a lot of stalwarts from the sector. And also some of them, I mean, I've been reading a lot and learning since I have been working in this space. So it's a pleasure for me to be with Alok Kumar sir, also Mohit sir, etc. So largely, I think on the aspects that Alok Kumar sir, Mohit sir, Garg sir have been talking, we see that yes, heat has significant impact on electricity demand. But what is challenging in demand is especially the sharp peaks and or sharp demand rises that we see owing to changes in weather, whether it is, sudden downpours happening or sudden temperatures increasing. On the other hand, the steady growth in terms of where demand is coming from and what is leading to that demand growth is something that is yet to be, entirely understood. In the previous session, we looked at some charts which showed about, how temperatures are changing across districts. Electricity planning does not happen at the district level, right? So electricity has its own systems in which the planning is done. So you have divisions, you have circles, which do not very well overlay with the geographies of the country. And there, I think, is another significant challenge where to be able to predict this demand, we need to have data which will tell us where that demand is going to come from and why that demand is going to be looking in a particular fashion. Here, I think, I mean, this is also from some dialogues that we've been having with electricity distribution companies, is that for them to be able to predict what the demand is going to look like, they need to have enough information and data. Right now, the data that Indian Meteorological Department puts out is mostly at the district level, which is not very helpful for the utilities to make their planning in a fashion that they will be able to meet that demand. Having said that, at many times, given the nature of the systems that we have in prediction of weather, these weather predictions do not always come true, right? And or there are these sudden changes that are happening in the weather conditions, which is leading to utilities facing that brunt of having to suddenly reduce demand energy being procured or suddenly increase the demand. And this is also reflective of certain things that the panelists earlier mentioned about how prices on the markets are also dropping. That's also because you've not been able to see how this demand is going to come and when and what is going to influence it. But at the same time, I think along with, so we looked at generation in terms of RE. We are also talking about issues or efficiency drop in thermal power generation. We are also talking about issues because owing to heat in lower hydro generation. So at the generation end, yes, there are issues, but there are another two elements in the power sector which are also being significantly impacted by extreme heat, which is the distribution network and the transmission grids, right? So the transmission grids, having said that, in our country, we have a very extensive grid that is existing, but extreme heat also has a lot of problems, which leads to increase in losses on the transmission networks. At the same time, in the distribution grids, this overdrawal or increase in demand leads to a lot of failures at different points within the grid, which is also very challenging to maintain or manage. So overall, in terms of extreme heat specifically, I think looking at, I mean, it's really a complex and a challenging problem, because you have to look at these different aspects within the entire network. And I think, like Alok Kumar ji started off the discussion saying that, operation is where we need to focus on, because that is where lies the key at, managing the entire grid given all these uncertainties that are coming.
That's a fair point. Managing it at the company levels, at the system levels. I'll come back to you, Alok Kumar sir, for this.
Please.
If you could then talk a little bit about how the discoms and how our distribution companies are actually adapting to this kind of sudden spikes that are happening, and what are the changes that they can make and are making?
See, first, starting from what Sweta was telling, the demand forecasting has to be at substation level, not at distribution company level, because you have to serve the demand right at that feeder or that distribution transformer. If you do it only at one node, it will not serve the purpose. I'll again say, repeat it, say rising temperature, long-term trend will lead to increase in demand. That you can forecast. Problem lies in the uncertainty. Say, when you have not planning for it, your units are under outage or planned outage, suddenly heat rises. That's a problem. So my view is that there are 3-4 mitigation measures which distribution companies are taking into account and they should take into account. First is these uncertainties. If you see in large geographies, they always plus minus, there is a diversity. So a good transmission system across a large state or across India is one very important instrument which can take care of the uncertainties in heat. So long-term heat, its impact on demand can be forecast, but uncertainties, you need a robust grid within the state and outside, interstate also. Second thing is you can't plan every capacity for extreme heat every time. So there are certain now, say, instruments available, discoms, which they are started adopting, is the demand response. Demand response is one which can take care of certain unforeseen situations. But for an effective demand response, you need good load research and smart meters so that you can communicate with the consumer in the real time, so that, because demand response will not work unless until consumer is almost in real time, he's looking at the grid situation, the prices in the market, and what is going to be paid for it. So what I'm saying, there are two elements which discoms are adopting, and they should adopt it further, are a robust grid planning and also a good demand response system based on real-time data conveyed to the consumer. And the smart meter data can also help them to do some load research. You can't devise a good time of grid tariff without proper load research. So these are the few things which I would like to emphasize upon. Thank you.
Thank you. That was very succinct. But then if I can go to Mr. Bhargava with this, because that thread goes then, if this is what needs to be done, what is stopping? What are the bottlenecks that are holding back the system? And I think financially and technically.
So that's actually a very wide subject, and probably I don't know whether
No, we are
have the
speaking
time.
mostly from the heat perspective. So
Yeah.
especially when there is a heat stress.
You see, I mean, what Sir said is absolutely right, and it needs to be done. It's probably a story of how government's decision making from the federal level to the state level, and then implementing it, rolling it out in the best possible time frame. I mean, that's the whole challenge. So we can always debate about it. I don't think anyone sitting here can very easily. Sir probably is the best suited to give that answer. He's been in that hot seat. But I mean, we can keep on debating and say, "Jaldi hona chahiye, bhai, ye to aapko kar lena chahiye." But it doesn't happen because everywhere there are checks and balances. Having said that, and probably I'm slightly diverting a bit. So in the work we did at ICC, our team is, I'm not the guy doing the work in any case. So they actually have two very typical solutions, if I may say so. And that's why I said I'm slightly diverting. I think one of the things was mentioned by Shweta also, and also by Saab, that rising heat leads to higher temperatures in the transmission as well as the distribution system, obviously leading to more losses and so on and so forth. So what our team has done, and this is an ongoing research, a lot of you, if you go to the ICC website, you can probably see the initial draft of that report also. That's work on advanced conductors for transmission. These are basically aluminum core composite, aluminum conductor composite core, or HTLS. Now this is, and Greg Saab can definitely comment on this later on. This is basically a conductor which is now available easily in India also. There are people manufacturing in India. I understand in a couple of states like Gujarat and Maharashtra have already started implementation of this ACCC at 66 kV, 33 kV. What it has done is that it has increased the capacity of the same line. So this you can actually retrofit. You can use the same set of towers, whether at 33 kV or even 400 kV. One, it solves a very important problem of right of way, which is actually one of the biggest bugbear in expanding capacity. But it also helps increase the amount of current that line can carry. So effectively, it is taking care of the increased demand and the heat losses. What has been established, I believe scientifically, that these conductors can take more load at a lower loss. So effectively, you can actually service more load. So whether you do it at 11 kV, 33 kV, 66 kV, so this is something which can be implemented. This needs to be rolled out. And in fact, our team had also met CA chairperson, and probably we need to at some point start putting it in the specifications that this is something which needs to be mandated. Please use ACCC, because it is no longer a proprietary thing. It is being manufactured. So it is not like a one product thing only. So it can be done, which will help. And this is equally useful if we are doing like the Ladakh line to evacuate like 400 or 4,000 megawatt or 10,000 megawatts RF power. The second work which our team has also done is also on the demand side. When we talk about heat, and I think probably, I don't know whether it has been discussed. So when we talk about the increased demand, I was hearing some numbers when we were talking below that 2035, 1800 megawatt kind of demand, CS at 1800 megawatt. And so if we are looking at that kind of demand, one of the things we saw that by 2035, almost additional 200 gigawatt of demand will come from air conditioners. And the efficiency of air conditioners today in India, I mean, I'm just giving it as a reference point. Our 5-star ACs are actually equivalent to 1.5 star in China today. And so this is a research our team did, and we have suggested to the government, and we are also part of the discussions the government technical committee on AC had, that if we actually ramp up the efficiency level of our ACs, we could actually save almost 1/3 of that incremental demand by 2035. So, and this is just one large item which can be done. Already higher efficiency and better efficiency ACs are available in the market. And every manufacturer, I was also there in the meeting, every manufacturer is in a position to supply that. All they're asking for is a time. I mean, government obviously can take a call, and our session to the government would be that please try to take as little time to roll it out, because in this government has a very good role. They can actually mandate that these efficiency levels have to come in effect within the next 24 months and so on and so forth. So take the manufacturers into, take the points into view and then put it out. This will help reduce the incremental demand. The challenge of meeting demand today, I mentioned earlier also, and Sir also said storage is the only way we can meet the peak demand now. But if we are looking slightly longer term, so just doing 1,000 gigawatts additional capacity in the next 10 years will not serve the purpose. That has to be done smartly. That has also to be supported by demand side, efficiency improvements and whatever appliances we are using. And I'll just try to leave on one small note, because we are all very, it's more food for thought. It's not any suggestion from my side. So we are all very gung-ho about AI and ChatGPT. I think everyone in this room has been using ChatGPT for doing most of the inane tasks. So, I mean, just as a reference again, if you post a query, simple query on Google, and I don't know why Google actually started using AI to even answer your simple queries. So whatever energy is used by Google for a single query, AI uses 5x. So while we are very happy using ChatGPT to help us draft a letter, a chutti application for the office or whatever, probably doesn't make sense. Google can do the same job, but then that's where we are.
That's good food for thought. But while we are working on our efficiencies and while we are looking at new technologies, this is obviously going to come at a cost. And if I can come to actually all of you all to a certain extent, and Alukumar sir, I'll come back to you later, but Mr. Garg, you could talk a little bit about the investments that will be required in your technologies. Mr. Pathak, if you could also, after Mr. Garg, talk a little bit about the kind of investments that will be required and the role that the private sector can play in this, in ensuring that there is, things move faster so that we are able to be better prepared for our managing heat risks.
Yeah, thank you. First of all, I'll add little to Mo's treatment on use of those conductors. Why CA is not doing that? Why it should have been done long back?
I did not question.
No. I wanted to tell you it's a soft debate. No. So I'll let you know. STLS conductor is really a very good conductor. What the normal two conductors can carry, whatever current, the same current can be carried by a single STLS conductor. So when we erect, say, a single conductor on the tower weight goes down, the tower width becomes less, ROW requirement comes down. Okay, everything is fantastic. It looks very nice. Okay, but the problem is that whoever is electrical engineer, they know that in a given resistance, if you increase the current, the losses increases 4 times because it is I square R. Right. So what happens in STLS conductor? The resistance of that conductor is very high, but its thermal capacity is also very high. So you can push more current. It doesn't sag much because our problem is basically sag. If you load, my normal conductor is also capable of taking double current, but it will touch the ground because heating will sag the conductor. STLS doesn't sag much, so you can push more current. But the loss part, it causes more losses than the normal conductor. But what Mohit said and what context we started, in the existing distribution network, existing state network, definitely this is the solution because you cannot replace the towers. It's impossible to replace all the towers. On the same tower, you can use these better efficient, better conductors, STLS conductors. They'll carry more current. And now the requirement is that load is increasing, but we are not able to make the lines. So just go and do the retrofitting with STLS conductor and increase the capacity. And what he said is very, very true. But for new lines, bringing it into the specifications should be very, very, it should be done cautiously. Wherever we have the corridor problem, we should go for this conductor because even if the losses increase, at least we are able to make the line. But wherever flexibility is there, you can go for a wider corridor. You can use, more conductor, quantum and all that. We should go for the conventional conductor only. So that's why CA is taking very cautious. They're going with cautious approach that wherever the demand is there, we incorporate these conductors in specific projects. And another thing that's a little more technical, when we work on height like Leh, we need more number of conductors to mitigate the corona effect. So if we use the STLS conductor, then we will be forced to use less number of conductors. And in that case, the line will not work because the stability issues will come. So in hilly area, forcibly we are using the quad conductor in the lines. We are not going for the twin STLS. So those things are there, but still we need to work on that, and selectively we should go for HTLS conductor. Now, the basic question which you asked regarding the investment, definitely, as sir also told, that robust transmission system is the backbone of your power sector. In India, we had great problems 10-15 years back because we were not able to transmit power from the power surplus areas to the power deficit areas. But today, the power generated in any corner of the country can be taken to any other corner of the country. And that's why this problem of less rate and exchange rate and all those we are seeing. But that is a positive sign. What problem has come 2 days back, sir was telling ki the rate came down to 0 paisa, almost zero, is because, I mean, a lot of RE is coming. Thermal, Mohit can tell ki you cannot back down like that. 2000 megawatt should be to 20 megawatt. You cannot come below 45-50%. Otherwise, it will not run. And in the evening hours, you have to ramp it up again because in the night, RE is not there. So you are dependent on the thermal, coal-based power only. So storage, we all are talking about storage is the real solution. Storage requires investment. It requires research and develop R&D also, because very efficient and cost-effective battery system is required. So the major investment is required in the storage system that will solve a lot of problems. And at the same time, the state network, when sir was secretary, we were called in the power ministry and we were, I mean, really, I don't want to use the words, but states were not able to draw the power from the ISTS network. Sir knows that that ATS, TTS problem, they call is available transmission system, available transmission capacity. All those things were available at the border of the state, but they were not able to draw it to their system because state network is very fragile. Use investment. ISTS is doing well. Power Ministry has pushed a lot, and definitely a lot of work has been done on ISTS. And now people are trying to stop it, but it is not stopping. I mean, the inertia is so high. But at the state level, definitely a lot of investment is needed. Both center and state should work together, and a state network has to be improved. These heat issues, they are basically initiating from the distribution network only. That network has to be improved. More transformers are needed. Everywhere the load is, say, 1 megawatt, the transformer capacity is 1 megawatt. It's not N-1 compliant. Like in ISTS, we are always going for N-1 compliant. If one line is needed, we are making 2 lines. So that if one trips, the load should shift to the other one. Because in power, we can't afford dark. Always power should be there. Always there is an extra expenditure on power. I mean, power infrastructure. It cannot be made just one-to-one. Same thing has to be done at distribution level and state network level. The use investment is needed, and willpower is also needed at the state level. And once we improve that system, definitely our many problems will be resolved. Thank you.
So we go back. Thank you so much for this very important point, because then we go back to what we heard in the earlier session, where the answers are perhaps more local than we realize, and that what needs to be strengthened is the local government systems and the local solutions. Thank you very much. That was very interesting analysis. If I can come to you, Mr. Pathak, then, and to the other part of my question, where what role then does a private sector play in this to be able to ensure technology is available, or, you know?
Well, to continue what
yes,
the things were going, I will take a half minute for that and then another half minute for what you have asked.
Sure.
See, we have a federal system and central, state, and all these issues are there. If you look at from Delhi to state, it's different. If you look at from any village to center, it's definitely the angles are different. Everything is different. So if we are facing a problem of the overloads or the problem because of heat and all that, a general solution is you have to reduce the load, whatever you have. And for that, I think just last week I was going through some social media posts and all that. So somebody was discussing about, as we discussed about air conditioners. So he said, "Ki now we have come up with, even India has come up with air conditioning system which has a solar photovoltaic as its input. When you have a solar photovoltaic based AC, so definitely it will take its power from there and there only. As in the introduction, he says, my interest is distributed generation. So at a state level or at a longer end, the importance should be given to the distributed generation. You generate there and there only because you have a solar panel, you have a availability of the solar radiations and all that. So you have to look in for the solutions for the last time. So that if you have the things where you will be generating there and you are using there, the another advantage is you don't have the transmission and distribution losses. And as Mr. Ashish Khanna was mentioning in the morning, that whatever, and even I shared that whatever the cost at earlier days, and now we are below 3. So if we are in a position to have a electricity cost by way of solar or any distributed generation below 4 or below 5, and otherwise if I'm getting it at the cost of 7 rupees 50 paisa or something like that, so that type of things are needed. And for that, what you said, whether it is a private player investment or government investment or government handholding, we need to work on this, that how we can develop these things so that the load on the my central grid should get less. Of course, it is not so easy. Whatever I am sharing, it's an concept, but concepts can be developed and that can help. That is what we have seen, or we have the experience. So that is what I believe the answer to both of your questions, that whatever your requirements, you have to reduce that. Second, maybe for the time being. And second, you have to look for the options available at your last end and how will you get benefit of that. And for that, good amount of investment by private players as well as some good funding arrangements for research and development are needed.
So that's where the private funding can also go in.
Yes.
Okay, that's a good answer. But if I can then go to Shweta, you have worked, Prayas has worked with CDRI on a certain framework, because decentralized, we can come to that is perhaps a solution for some in the future. But currently there is already a lot of pressure on our utilities and on our systems. How can the framework that you worked on with CDRI, how can that help utilities? Can you talk a little bit about your work?
Yeah. So heat, yes, is a challenge for the power sector, and Prayas, along with CDRI, we try to understand, rather pinpoint areas where there are issues, and then look at some ideas or solutions that can work. So some of the solutions that most of the panelists also talked about in terms of technology, in terms of certain implementation ideas, are yes also in the bucket. But largely, I think we looked at it from two perspectives. One is in the immediate or in the short term, what is it that can be done? So some of the things that, as a framework, we come out with is that utilities at the state level, or even at the federal level, even CEA and the other national organizations, can sort of reflect on what they did in the last two extreme heat months, which was not just in 2025, but also in 2024. So what were the measures that were taken? What was effective? Why did certain measures be deployed? And what was the result that we saw? I think this sort of assessment, because on ground, I think at the utility level, even down to the lineman, we have very capable staff, and they are able to manage these systems very well. Probably it's not very well documented, or there's no methodology or approach in the form of a note that we have, but these systems are working, and that is why all of us are able to actually get our electricity supplies, right? So what is it that was done differently to manage that demand, or to manage the issues that happen on ground, is something is what we feel is the first step that can be done, which when collated will also have some scope for sharing and learning across different divisions or even different states. Secondly, I think something that even Mohit sir pointed out was to come up with these standards and revise them at the national level to say, how our grid should be designed, planned, what kind of um, uh, resiliency we want to build into the grid, which means how our network should be developed. So that is another thing that we should be working on. And the third thing is also, two other things which are important is to have heat related emergency protocols. So what do we do when we know that the summers are going to be long, we know that there are going to be extreme events? So what are the protocols that can be followed? So some documentation, some guideline on that is certainly helpful for the utilities to come up with. Prayas and CDRI together have been ideating on this, and some of which is there in our publications. Another critical aspect of this entire management of the system is also something that Alok sir mentioned, is demand response or demand side management. But what does that mean? It doesn't mean only for the utilities to take that responsibility, but it also means that the consumer needs to understand what it means. And when I have to contribute, what does it mean for me? Like, do I need to turn off my air conditioning, or do I need to reduce the temperature of my air conditioning? For how long do I need to do it? And all of this responsiveness also, from what Alok sir was saying, is that smart metering certainly allows the utility to understand, but building that connect with the consumer, for the consumer to understand when I have to participate and what I need to do, is also very critical in making our systems more resilient to heat. Finally, I think in the long term, or I would say in the medium term, we talked about efficiency of air conditioners. Yes, we need to certainly improve appliance efficiency. But some of the other guidelines and protocols that we already have in terms of introducing energy conservation and building codes, right? Buildings are one of the largest energy consumers. And we need to focus on, mandating these codes that have been developed. Also looking at implementation of, better implementation of TOD tariffs, like Alok sir was also mentioning. So some of these things fit into the framework in a way where it ensures that you have to look at consumers, you need to look at grid resilience, you need to look at how information can be gathered, which means you need not always have new transformers that you need to put on the system. Having better monitoring of the existing transformers can also help you make the system more resilient, right? So this kind of systems together can bring in the resilience that we need in the system and the grid.
Thank you so much. That was very helpful and very well put. We have a few more minutes left, and before I really like to throw the floor open for questions. We can take a couple of questions, but I'm just going to put Alok Kumar sir on the mat just one last time. I'd like you to have the last word on a quick word on, so what are the low-hanging fruits that we can move on really quickly? If you can quickly give us like the top 3 or 2 ideas.
I will again reiterate. One is the smart metering of the system is one key which will make us future ready. Let us roll it out faster. Second quick thing which can be done in less than a year is the building capacity in DISCOMs for resource adequacy modeling. It can bring a lot of cost efficiency if you do it smartly. One study for Madhya Pradesh showed that if you plan appropriate battery storage at substations, you can save close to 6 to 7% cost, capex and opex put together. And third thing, I'll say that reliability will have a cost. Let us make our mind clear whether we want reliability, whether heat or cold. Europe is struggling with the cold, so it is always extreme weathers. If we want to have reliability, it will have a cost. So the cost will have to be passed through the consumers. Let us help the needy ones, not everyone. So the subsidy needs to be better targeted. Thank you.
Excellent points. Thank you very much, sir. Throwing the floor open for questions. Yes, Deven, please.
So my name is Deven Pobaru. I represent Indospace. For information, Indospace is India's largest grade A real estate developer. We have about 50 million square foot of space, which we lease out to customers across supply chain companies, manufacturing companies, etc. And we are building another 50 million. We are funded adequately by all the real estate private equity players. We generate 18 megawatts. My team told me today that we can go to 350 megawatts solar energy. We don't know how to negotiate, for each state has its own logic, so I'm not going to talk about that. But storage is something that we have been thinking about, and I don't think this is a question which can be answered right now, but we are ready to and happy to invest in storage also at the park level. If we are treated as a customer, we can obviously give it to all our tenants. We have more than 150 companies which are our customers. So for us, this is a very important element where we are EDGE certified, founding member of IGBC, all the various other things that are possible in a building we have done. But this is one area we believe that there is huge potential. We obviously are going to charge a lot of trucks, the electric trucks which come to deliver material or pick up material from our parks. So we believe that people like us can really play a very big role in making sure that solar energy production as well as consumption as well as storage can be better managed. And obviously we deal very closely with the state governments because we bring a lot of investment which is coming with the foreign companies which want to start here. So not a question, but then these are the kind of things that private sector is ready for. A lot of my customers keep asking, what are you going to do? Because we are the only agency which can coordinate and put all of this together. And we obviously interact with all the state governments very closely. So I don't know what can be done, but if anybody has any suggestion that what can be done tomorrow or what will have to wait for a few more months, happy to hear.
Who would like to take that?
And my competitors will also follow me closely. So it's not only me. I mean, I'm saying we are talking of all the developers who are going to do this. This is the place where maximum investment is happening in the country right now.
Very briefly, 2 hours of battery storage is definitely going to be very viable for next 10 years. Go for it.
You can avoid the DG set in your.
We already have out of that, but I'm saying the state should buy that power also from me if I'm not able to use it.
There is a provision of net metering. I think
all states have. I will talk separately, but all states have their own logics, and I can give you execution logics of.
You may not get benefit of net metering, but I think even without that, it should be good.
Yeah.
So net
If
metering,
you use
because
that 2 hour battery
capacity
store in the
is-
evening and you don't draw from grid, you will save money.
Anyone else?
and a lot of discussion is happening on TOD. So TOD will come.
Yeah.
So that time, what sir is telling, evening 2 hours will be very great.
For 10 years, you will mint money. Go for 2 hours storage.
Yeah.
We have seen the demand because the demand is right now not there for
Sorry to interrupt you, but Alok Kumar sir, can you take the last question?
I will leave after this.
We're anyway closing. This is the last question.
Yeah. So as per demand, I think the demand is already now going to come up very soon because right now the data center has not been coming here. The biggest problem that government is right now working on, which is to launch its own data centers in India, because now we don't want our data to be stored by US and any other country. So as soon that comes 1 gigawatt to data center, only one data center will take 1.2 gigawatt, like monthly they are consuming, and the water they're consuming, that's next level. Plus drone-based delivery service is going to launch in India, which will take a lot of electricity. Again, the third area which you are told that, okay, night, we don't have right now. We have to use thermal power and all that. I think that can be solved if you use the footstep-based electricity which Japan is using, which is then in the mall. Why don't we have a foot-based electricity generation? So that in night also we can generate the renewable energy. We don't need that power consumption, because in India we have so much, which everyone wants to go to the mall. They just want to walk it. Why not use that foot electricity, which already Japan and other countries experiment? So as a startup, I think we should, I think that with the private players, like startups, let come in this energy sectors. Lot of problems can be solved which you guys are facing. I think if you want, we can have a discussion separately.
So maybe we should have that discussion on over coffee, but would any of you all like to say something? Yes.
In the one line.
Sorry. Yeah. David.
Mr. Devan, my answer to your query was you have to look in for what I shared. Whatever the rate you are getting right now, you have to look in for how better rates you will have and through what sources.
Just saying thank you.
Please.
Okay, thank you. Thank you. We're really just about making it. Thanks a lot, everyone, for being such good listeners. And I'll just ask my colleague Kartiki to
Yes,
please close the session.
so we would like to give Archana, if we could request you to give some.
Okay.
Thanks so much. Climate change.
Thank you.
Thank you so much for your time.
So may I also request all speakers to gather together for a group photograph, please?
You're only on the front.
We now break for a short tea break. We'll be back by 4 in the room for the next session. I'll tell him. I'll ask him.
EV companies से क्या
Should I, Archana? I think Sauraj just moved out. Welcome back, everyone. We now move to the final session of day one at the India Heat Summit 2025. The session is titled Industry Preparedness Amid Rising Temperatures in India, and it focuses how the private sector is facing risks posed by heat stress, not only to their infrastructure and supply chains, but also to their workforce, especially in outdoor and high exposure sectors. Moderating this session once again would be Ms. Archana Chaudhary, Associate Director at Climate Trends. Joining her on this high impact panel are 4 distinguished industry leaders and sustainability champions. Archana? Our first panelist would be Mr. Praveen Gupta, Member Advisory Board Sanctuary Asia, a sustainability advisor and advocate for nature positive corporate strategies. Mr. Vaibhav Dangi, Head, Build India and Board Member, IIM Nagpur, known for his work on infrastructure modernization and transport sustainability. Mr. Devin Pabaru, Managing Director, Indospace, a logistics and supply chain leader with over 30 years of business strategy and transformation experience. And finally, Mr. Vishwajit Singh, Founding Director, Zip Electric, innovating in electric mobility and last mile logistics space with a climate conscious lens. We look forward to hearing how these industry voices are planning for a hotter future. With that, I'll hand it over to Archana.
Yeah, hello. We are missing a few listeners and 1 speaker, but
last session you can expect.
The speaker cannot have ended.
No, he must be.
Yeah, sure. Oh, he hasn't arrived as yet?
no, I think he should have been here.
Are you daily based? Mr.
Yes, sir.
Okay. Thank you. I don't have a card, but I'll drop you a. Thank you.
In the interest of time, shall we start?
It's his guy.
Thank you. I'll mail you.
Okay. I think this is, this may be the last, but I think this is one of the most crucial discussions that needs to be had more often when it comes to climate crisis, when it comes to building resilience, and especially in the context of heat.
Correct.
We've seen reports that said that between 2001 and 2020, India lost about 59 billion hours of labor annually because of heat-related issues. And the 2022 heat waves, those we've seen led to an almost 20% reduction in wheat yields and 15% drop in milk production. So we've seen a lot of losses across industries, and only about 25% Indian companies have concrete plans to adapt to physical impacts of climate change. Today, we have with us a panel which can help us understand some of the thinking that Indian industry is doing and some of the solutions that they are considering. I will not take more time. Let's go to Mr. Gupta first. Let's start with you, sir.
Thank you.
You have a very crucial sector you handle, and we've seen case studies where insurance companies have been called out for insolvency because of costs of extreme weather. Like we saw that in the California wildfires. Reinsurance firms like Munich Re, Swiss Re, they warned about the vulnerability of the insurance sector. Is India's insurance sector even recognizing these vulnerabilities, and how prepared are they?
Thank you very much, Archana. I appreciate. It's a pity that we have a very thin attendance, but the message is very loud and clear. I'll just sidetrack a bit and talk about a bit of a narrative change that is required. So there was a lot of discussion on energy and power and all that. What I'm going to mention is, much of heat that we see today is a function of energy imbalance. So daily, according to Bill McKibben, who's a very renowned climate, I won't call him activist, he's an environmentalist. Bill is one of the most prolific and respected columnists. He writes for the New Yorker. And according to his working, and which is very objective, on a daily basis, there is an extra heat trapped equivalent to 400,000 Hiroshima bombs, which is 150 megatons, which is a very small bomb in those in the current context. But that's the amount of heat that goes into the planet as what is generated and what gets into the systems, and 90% of that goes into the oceans. So my request to you is that next time, I mean, everyone's so obsessed with the terra firma that we forget the role oceans play. Oceans are the biggest climate regulators, and we are messing with them big time. And if we hit sixth extinction while we are alive, unfortunately for the Gen Next, many of you are that, or thereafter, the reason would be not because of overheating on land, but overheating in the oceans. So please remember that, and that's very important. So energy imbalance is a major thing. The other thing is Earth systems. So and again, I will connect it to where insurers come in, in a moment. And the third thing is the planetary boundaries. So there are 9 planetary boundaries, and one of the most eminent scientists in the world who works for the Potsdam Institute of Climate Change, Johan Rockström. I would seriously urge you to please see, and I will share one of his critical presentations as to how out of the 9 planetary boundaries, 6 have been breached, 7th one is about to be breached, and we are on very precarious ground. So when I hear all those discussions, that wonderful and knowledgeable and reflective stuff being talked about earlier today, it's fine, but that is a slow track. What's happening on the larger planetary space, and which will determine where we are headed, because this heat that it is the fever that our planet is seriously going through. And what we are doing is putting a band-aid when it requires a major intervention. So that's these are the 3 things that I want to mention. Now, sorry for this long-winded thing, but this message is very important. So basically, again, heat is one of the outcomes of multiple things. And heat doesn't, I mean, it can be a cause, it can be an effect, but it can also interplay with many things. In one of the sessions, it almost came to a concept which again you must refer to. It's called polycrisis. And polycrisis is an outcome of multiple triggers interplaying. And heat is one of them. So imagine you have a heat wave and a COVID crisis, or you have a heat wave and followed by all kinds of other things like earthquake or a tsunami and stuff like that. California, that you alluded to, almost had a sea level surge while there were big fires burning. Now, you asked me whether we face some of those threats that the US saw in California and continues to see in Florida and parts of Texas, which are always hit by hurricanes. The point is, our balance sheets are very small. The insurers do three things. One is they are risk managers, two, they are risk carriers, and three, they are investors. So if you look at the total investable fund of the Indian insurance industry, it is like 68 lakh crore rupees, which is not a very big sum when it comes to US dollars, but it is still a significant amount if it can be channelized into much of what has been talked today in terms of mitigation, adaptation, and resilience, which is still not on our radar. It's important. Indian insurance industry doesn't talk about ESG. Unfortunately, that should be a discussion at board levels. That should be a discussion at the regulatory levels. And if you look at all the money pipelines, we've seen how far SEBI has come, which is just doing lip service, or how close RBI has come, again, which is lip service. So all the money pipelines are seriously and inadequately working on this front, and it's not a good news.
Thank you. That was a very honest and a very thought-provoking answer. And we will come back to some of the points you've made. If I can go to Vaibhav, but before I go to you, Vaibhav, I just wanted to say that our fourth speaker couldn't come. He has sent a message saying he's had a bereavement in his family just now. Someone met with an accident, so he's had to rush there. So we'll come back to Vaibhav. Vaibhav, you are from the infrastructure sector, and one of the things that we'd really like to know is how our current infrastructure projects, we've heard a lot about heat stress, but generally for ensuring climate resilience, how are we incorporating that in our infrastructure projects?
Thank you. Thank you, Archana. When you invited me, I was a bit surprised because I'm not a climate expert, but yes, we have been working into infrastructure and trying to make infrastructure more of a sustainable, I would call it. Calling it climate resilient will be a bit too far to say that, but and as Mr. Gupta said, we are still behind even in the thought process. I think, let's admit, we have still not recognized that challenge as it. And I'll not blame our industry or our thought leaders or our policymakers alone, for the simple reason that for long, probably 100 years, we have been told that if you want to be a developed nation, your energy consumption has to be equal to what US is doing or Europe is doing, your fuel consumption, and so on and so forth, so many. And today, suddenly everybody is saying, no, you have to be more climate resilient, you have to be more, less adopter. So I think it's a bit of a, pendulum has gone to that end, and we are trying to bring it to, this end. So, but pendulum will always flow like that if you want to settle down somewhere. So I think heat as a problem, I don't think industry has to large extent still recognized in a large sense, both in terms of whether it is calculating and kind of managing the risk through insurance or those kind of means, or even to look at particularly loss of time, working hours and things. But I think what has started understanding and happening is we need to look at these areas and try to address those issues is the very beginning step that industry has started looking at. And uh, I was listening to the earlier session, which was primarily focusing on energy, and I think obviously energy plays an important role on heat and other things, but I think we are still much behind on the design part, I think, and that's where the amount of energy used in buildings, we were discussing about air conditioning adding into certain percentage of heat into our urban centers and so on and so forth. I think we are still much behind on the design. Regulatory framework was designed, I think, 3 years back or 2 years back in the budget. Honorable Finance Minister has announced that India will relook at entire building codes and other things. I don't think much has happened on that line, but I think seriously we need to look at that, and then we need to look at that from the climate perspective as well. It's not only about, because we have been just copying. You look at major infrastructure, whether it is airport, whether it is, for example, we all have seen that there were carpets in T3, and then most of the carpets are being removed now. Because we were just copying designs from wherever we found it attractive, where we found it good looking, probably. So I think all those perspectives still yet to come into building codes, into our infrastructure design codes, and then the sustainability in terms of material we use. It's not only about using. So ultimately, if we want to be more climate resilient and more sustainable, we probably, again, I think we probably need to look at the basic principle of what is climate resilient. It is ultimately more because nature, if you look at, has a very perfect cycle of everything, and therefore that the larger recycle, reduce, reuse cycle is still not happening anywhere, and therefore I think that's a bigger challenge. So whether it is in infrastructure, we look at building the large infrastructure, whether it is roads, ports, airports, railway stations, all those aspects, metro stations, all those aspects we need to look at. Yesterday what happened in Mumbai metro, or all those aspects we need to look at. But parallelly, a lot of work has started happening on reducing our impact of the infrastructure material on the energy. How do we reduce the, so for example, a lot of experiment is happening on cold mix for bitumen instead of hot mix, and that saves us around 1500 degree of heating for the bitumen and aggregate mixing. That's a direct solution to reducing our contribution to the heat. I'm not saying that alone will solve a lot of the problems, but these are small efforts which can probably look at changing our way we, because ultimately we'll have to go on reducing, not only reducing our heat energy consumption and the heat we generate, but parallelly we'll also have to look at those kind of solutions to look at. So point I'm trying to make is, we first need to look at all the design and those kind of code aspects in infrastructure, and second, look at materials, processes that can probably bring down. So for example, now we talk about transport infrastructure. Everybody talks about converted to electric or those kind of vehicles. I'm sure that's a solution. But if you look at say Delhi, and tomorrow whole of Delhi using their personal cars, and we still expect that electric cars will reduce the problem of traffic and climate, I don't think that's very realistic to expect. So how we can be more sustainable in terms of transport? So we can't leave a solution of public transport that will ultimately address to the reducing the impact of transport sector generating heat. So whether it is you use electric vehicles or flexi fuel vehicles or a hybrid vehicle, but number of vehicles, if you have probably 1 crore vehicles on Delhi roads, no solution can be looked at from that perspective. So I think on those aspects we need to look at.
So basically, time to go back to the drawing board and think a little bit harder.
Yeah, more than going back to the drawing board, we need to bring in that aspect in everything we think of, right from policy to designs to solutions to technologies to processes to materials.
Fair point. But now that we understand that a lot more thinking needs to still be done, if I can go to Mr. Babaru, because you seem to have done some thinking with your businesses. Can you talk us through a little bit about what kind of measures that your industry has been looking at, your own companies have been looking at, in terms of ensuring that there is a certain efficiency built in when it comes to managing heat resilience?
I'll take, I think the context has been set quite well, and obviously since morning we have been listening to. I'll take you maybe about 2006. I may sound old, but I'm not so old. About 20 years back, we used to have godowns, and there were no large modern infrastructure around warehousing and manufacturing locations. And I'm talking of late 90s, and we realized that in Nagpur is the place where 45 degrees centigrade was seen even in those days, and people would just start falling in a warehouse when they are working in a shift, and we would start tracking that, in the afternoon shift, whatever that afternoon shift is, the productivity was very low. Some 2-3 people will just fall. And we realized that this is not going to work if we have to increase the size of the warehouse, etc. Nagpur being the center and the 0 mile, I was in future supply chain that time. We created the first 5 lakh square foot Maharashtra government in Mihan. And we created a building which was 12-meter high, which was big thing. Again, worldwide, this has been done donkeys years back. In 2008-9, we got that to Nagpur. And with the kind of modern ventilation systems that we brought in there, in terms of Louvre, in terms of our ability to do 6 air changes, and bringing, again, very basic passive ventilation, nothing modern or fancy, the temperature difference would be about 7 degrees. So if the ambient temperature is 45, we would be operating at 37, 38. And then with fans, etc., inside, we could mitigate some of this. And obviously, these are very simple systems, but in India at that point of time, this was the first thing. Today, I am now a member of part of the team of Indospace. We are a $3 billion real estate private equity funded player. We have about 50 million square foot of space, which is operational across the country, and close to 125 customers here, domestic as well as MNC customers, and everybody is focused on ESG. We obviously generate 18 megawatts of solar energy in our plants. We have huge development plans, another 50 million. And one of the key things that we are making sure is that the infrastructure which is required for any large operation. I've also seen trucks, so we used to go to 750 districts, temperature controlled as well as ambient. And ships, again, another thing, ocean weather also is something that we are exposed to in supply chain. And in supply chain, we are only the victims of all the gaps. Nature, while it was so good to us, we obviously have taken it for granted. So nature is getting back. I think somebody spoke about angry weather in the morning. Supply chain has to bear all the brunt of it. And obviously the people working in it have this extra responsibility. The second direct impact is that I have customers who directly debit me for all the losses in the inventory, which my insurance company is not going to bear. So I am the only victim in this entire thing. While everybody can say that, policy ban jayega, design ho jayega, but finally I have to sign those debit notes, because I will not name a company, and I'll just give you an example so that it becomes specific. In Rajpura in Chandigarh, which is close to Himalayas, you don't see temperatures of 45. My systems, I only signed on the solution design. My systems were designed till 40 degrees. And maybe one day they can handle 45 degrees. And there is a 20 crore inventory lying inside, which is temperature controlled. Now, data logger, unfortunately, also tells you that, outside temperature is 45. So I can't even fudge that, data is not right? And data is getting all over online nowadays. So, your customer is also watching the data. Your operations team is also looking at it. In my control room, and I'm hoping every day in the newspaper that heat wave, that red color thing comes, and I say, oh God, guy. So I rushed and doubled the cooling capacity, flew in 5 people from all over the country with all the capacity, and I said, just put that damn thing there. I don't even want to know whether it is required. He's saying, boss, 10 tons ka 20 ton. I said, put 25 tons, because I am worried. I'm not worried about 15 lakh rupees. I'm worried about 20 crore inventory which is inside, which can be measured. Again, something gets damaged in the truck, no responsibility will come to me. I will say that it is damaged in the truck. But somewhere somebody is losing that money. That finally lasted, that heat wave lasted for 7 days, which has never happened. Now everybody is saying this system was not designed because in the history we have never seen this. So we do not have a forecasting system that if I am designing a building for the next 15 years, what should I design for? I have no knowledge. And the insurance company will tell me that, okay, you have not designed the system for 40. How can I pay you whatever XYZ on 45 degrees centigrade? So it becomes a force. My customer is saying, I don't know. You figure out, I told you to design, you design 45 for 45. So nobody is in a position to look at granular data and plan for future, and not to 1 year, 2 year, I'm talking of 15 years. And imagine this multiplied by 100 customers across the kind of entire country, 750 districts. If I have to plan infrastructure keeping next 15 years in line when we are just discussing the heat map today, the kind of complexity that we deal with is mind-boggling. And somewhere that is the price that all of us are paying, because that is a net loss to all of us. Apart from the human health and safety and so on and so forth, which anyway is an issue, we are actually suffering for all the work that should have been done, which obviously I'm not blaming anybody, but therefore now we have to catch up. Like he said, starting from design to thinking to conception to policy to everything, and it is already late.
Wow. So that is a
And it's
very
not option now.
Correct.
That's a very interesting point that you brought it to, because it's a good segue to what I'm going to ask Mr. Gupta. But it does underline the point again that we can't any longer work in silos, and that this has to be an effort that goes across levels of governments and levels of industry, and everybody has to talk to each other. But having said that, Mr. Gupta, because the point that Deven made was very interesting, that the insurance company is not going to sign on it. But then the insurance company is also looking at climate resilience, right? At some level, it's their job to understand risks. How do they, if they do, how do they look at risk in countries like India? Where do we stand at with the insurance?
Thanks. I mean, that's a very thought-provoking question. Thanks for asking. The point is, climate is still not an issue in India in the minds of the money pipeline, as I said, whether it's the banks or, it's very lip service kind of a situation. Insurers, fund managers, only the enlightened ones raise these issues and wish these to be addressed. The point is, how do we, say for instance, there was a mention of nature-based solutions. Now that's a big thing. And I would say that if anywhere in the world something is happening in my erstwhile industry, which is in the right direction, it's Europe and not the US or North America, and maybe to some extent in other small countries. But Europe is significant. Again, it's driven at the EU level, it is driven at the regulatory level. There are kind of watering down of standards. But what they're pushing for, and the issue that Mr. Pabru raised was about standards and about insurers not able to give a commitment. But the point is, they've started having codified standards, and I think those are good ways of doing things. Now, for instance, a company that I was associated with is based in Germany, Allianz. One of their board members recently stood up and said, if the temperatures rise beyond 3 degrees C, which is bound to happen, my guess is it could go up to 5. No insurance would be possible. Now, we have to do something. We can't wait for things to happen. And he's predicted forecasted death of capitalism if that happens. So if there's no insurance, there'll be no things coming up. And I mean, you have to carry the risk yourself, and more like it happens here, where the flexibility and the creativity is still limited. So there is a problem. But the problem there also is it gets more complicated, because on the risk carrying side, they're saying we can do this, we can do this. We will not do oil and gas industry. Europe has been pretty strong on that, but America is different. The companies that you named, Munich Re, Swiss Re, they've stopped doing a lot of oil energy kind of business, because obviously that is fueling the heat today. It is leading to carbon emissions. Carbon emissions are touching almost 430 ppm. They are expected to hit by 2035 500, and much of what is insurable today will not be insurable beyond that. So we have to accept that we have a serious crisis facing us, and this is now going beyond our generation. This is a generational crisis, and there are no boundaries. See, it's not about India or Europe or America. All of us are in the same boat. We are all going to go down together. So I think what needs to be done, particularly the young people here, I would appeal to them that they think about this seriously. It's not about dekha jayega or we'll deal with it as it comes, or someone will do it, someone will not do it. We have to own it and do something about it. So my answer is not very encouraging from the insurance industry side. There is a silver lining in Europe. America has gotten worse. We all know the reason, and we can't take for granted that this is just this 4 years and things will change. Because we would have, even if we hit net zero today, the carbon dioxide emissions in the atmosphere are going to bother us for thousands of years. So we are going to get storms, hurricanes, flooding, droughts, sea level rise, glacier meltdown, you name it, and everything's going to continue happening. So we need a bit of mitigation, more of adaptation, but a lot of resilience. And that requires a societal action plan.
Which hopefully is starting somewhere when we all gather together and talk about
that
this.
You've organized it and discussing it, I just thought, let me stretch the boundaries.
Thank you for that. Thank you very much. It is indeed disheartening to know the way insurance companies are thinking about this, but I really don't know what solutions they could have. But on that pessimistic note, since if we can move on to infrastructure again, because one of the things that I really wanted to ask you, Vaibhav, is also we talked about how money is not thinking, big money is not thinking about this as seriously as it should, at least in certain countries. But when it comes to us, Build India did a lot of work. There's a lot of labor involved, people who are directly affected by heat. Have we had to respond to that? Have you personally seen those kind of instances where we have responded to this? Can you talk a little bit about the labor issue in this whole infrastructure, just because we've heard a lot in the morning about how heat risk affects them?
Unfortunately, the entire infrastructure sector is still a eat reti rodi wala sector. Let's accept it as a fact. So all this resilience is still to reach there. वो सच में वो it's a last man in the queue kind of a situation. So to that extent, of course, there are incidences and there are some preparations done by the players, industry players, to address those issues. But as somebody said, probably it's still not part of the entire. So for example, when for an infrastructure project, a detailed project report is done, I don't think our DPR consultants are still addressing those issues. They are not looking at those issues, right? From, like, for example, for an infrastructure project, they'll plan for highway or for a port or for airport or for railways. They'll look at soil, material, design, capacity, all those aspects we look at. But I still doubt our consultants who design all those engineering and technical and financial aspects of the project are looking at those aspects. They are still in certain sense, ESG has started coming into, but not in a large sense. So let's accept it. First, accept that we are really not doing much in this area. We need to do a lot, right from, a very simple thing, that planning our work, workflow, looking at what are the impact our weather will have and those kind of. For example, our best period for work are period where we have extreme heat in infrastructure. For example, monsoon, you can't work in infrastructure. So your best period is to work during, winter, summer, those 6, 7 months, 8 months. So I think we need to look at those aspects right from the minute we start conceptualizing this. The second aspect, still there is no monetary incentive attached to it. When I say monetary incentive, for example, when carbon credits started coming in, a lot of green aspects that we started doing, it became a kind of a small incentive for even for industry to look at it, because at the end of the day, businesses will not look at it, things only from the responsibility perspective. It has to be economically viable for them at the end of the day. So for example, in infrastructure, if I need to use a sustainable material today, I was explaining about the cold, for example, mix. My cold mix cost today could be a bit higher than hot mix cost. And over a period, it will go down, obviously, if technology improves, volume increases and things like that. But today it could be a bit higher. But that's not an incentive for me and there are so many aspects to look at, because most of the infrastructure projects are government driven projects. So there is a set type of procurement process involved into it. So there is a little leeway for contractor to look at adopting new technologies. So, multiple those aspects also need to look at, because in thus, for example, for him, probably building a good logistics warehouse, he may not require every time approval from some agency or other thing. But for infrastructure project, there are so many regulatory and other aspects involved, where adoption of new technologies needs a lot of policy embedment of those technologies into the policy. So all those aspects need to look at in infrastructure. And therefore, as I said, we are still at a very early stage. But I think at least start looking at using the sustainable technologies, processes, reduce the consumption of energy into the whole processes, all those aspects. For example, if we are able to do 30-40% of our infrastructure construction requirement, substitute it with precast, which is factory made, for example, it can help us reduce a lot of heat, which we do at the site, and which automatically will help reduce creating right working conditions for our laborers. All those aspects will automatically start falling into those processes. So all those aspects we need to look at. So for example, we need a policy intervention where government will have to kind of create a roadmap that if infrastructure need to be more resilient and climate friendly, let's create a, for example, roadmap. How do we start increasing the contribution of precast from 10-15% to 30-40% or 50%, or similarly use of sustainable green materials from 10-15% to 40% in next, say, 5 years, 7 years, whatever that roadmap could be. I'm sure experts can sit down and look at what could be the right roadmap. Industry can give its feedback, but those kind of aspects need to be looked at. So for example, even for the energy use, Mr. Gupta was talking about Europe. So for example, with the Ukraine-Russia conflict starting in last 3 years, Europe has come up with almost 200 biogas-based gas plants. So, and for example, just by doing the CBG plants, lot of FOM that is generated through CBG plant became their organic manure. All those aspects. So technology is looking at, nothing should be left waste in none of our industry. That's also close to reducing the impact of heat and everything, climate being more climate friendly, climate resilient kind of thing. So all those aspects need to be looked at, I think.
May I just interject? He said something very interesting that we don't have incentives or disincentives. But the fact is that we are still a global world. A lot of trade that we do, if US acts funny, will have to be directed towards Europe. But Europe has all kinds of regulations, CBRD and all that coming in, which would penalize us for, say, usage of fossil fuel and stuff like that. The cost of capital goes up, rating goes down. So, in a globalized world, if you are an exporter or have a global fundraising originating from Europe, we have a challenge, and that kind of will push us to move in that direction. So there is some hope. But
no, absolutely. No, I spoke more from the infrastructure perspective.
I'm just adding to what.
Yeah, absolutely. But I'll tell you example. For example, I know incidents from Maharashtra where a container of grapes went there in Europe and they have to throw away in the ocean.
Wow.
Just because they were tested here, they were sent there, and then something happened. So, so that's a different market. So I'm not trying to
Yeah.
comment on that.
See,
But
mangoes
you are right.
recently,
Mangoes, yeah.
yeah.
So you are right. There are some incentives that have started coming. So that's precise point I'm trying to make. If there are some roadmaps where some incentivization is done or some disincentivization is done, either way, that will probably make industry start looking at solutions. I think first asking everybody to hit to a roadblock or to a wall will help us bring in more solutions. Solutions are available, but probably we have to hit the wall and then only solutions will start coming up.
And I think we hit the wall yesterday. but but yeah, you're right. Unless there's a carrot or a stick, there's going to be little incentive for folks to change. But then there are folks who are changing. And we know, I mean, although you're right, there's only 25% Indian firms that look at any kind of climate adaptation plans at the moment. But Devin, if I can bring you here, if you can help us understand, because some of the things that you said even earlier on how you have been planning ahead and ensuring that you are managing your risks through investing in certain things. Can you talk us through a little bit of how financial risk can be managed by Indian companies?
So I'll talk about two things. Before that, I want to also talk about what we have learned the hard way and some of the things that are working. So there is also a ray of hope, if I may say so. Some of our customers, we started forcing, and I'll give you one example without naming any customers. One of the companies had a shift starting at 9. And obviously, it was very convenient for all the employees, and it was very convenient for the managers more than the employees. But we realized that when we started tracking their KPI along with the temperature in the day, and we saw that there is a distinct dip, obviously, everybody is feeling tired. They don't stop working, but their productivity starts going down, and you can measure that very clearly. So we told the company that we will start a shift at 6. Now, if you have to start a shift at 6, that worker who gets up, he has to just get up, shower and come, because 6 o'clock is too early for him to prepare breakfast, etc. Which means that the cost of giving him food also is shifted to the customer. Which means now at 5:30 there is no public transport available. At 9 o'clock the frequency of the bus is there. So wherever we could speak to the local authorities and say, can we get the buses on time? Maybe we start 6 different services. They have to change their timetable. The driver is to come earlier. If they are running every half an hour at that time, because normally everybody designed from 9 to 6. So all those things, it took us a lot of effort, but then we said, otherwise we are not giving up this contract. You figure out. Because they have a penalty. If the productivity does not come, the penalty comes on me. I said, the easy thing for me is to give up this contract. So we hit the wall. The moment I said, sorry, they said, no, we'll discuss. So the moment they said, we will discuss. So in India, at least, I don't know, I'm not an expert on Europe. India, forced collaboration works. Disincentive works much more than an incentive. This is my view. FASTag also, everybody said, no, hoga. Today, FASTag is as smooth as it can be. But that time, every day, I said, wait for 3 months. You will see the FASTag, how it will get adopted. And he said, driver ye nahi karega, driver phone nahi karega, driver ye karega, sab kuch, nothing. Poor driver is blamed for most of the stuff in the country. Actually, is not at fault in anything. Anyway, so this customer then understood that while there is a cost, but the productivity benefits are far more. So we actually stopped in the middle of the day and saying, you go only one way and you go home. So human behavior change and systemic thinking, this is a small system, right? A local bus station has to be spoken to, or authorities locally have to be spoken to, local whoever has to be your people, etc. Some food catering arrangements will have to be made. This is an organized plant. So I deal with the best of the companies in the country. So I have a certain advantage. These are companies which understand the language as much as we all do here in this room. So it's easier. It's not easy at a national scale, I'm sure. So this behavior change we have started seeing because people have started seeing the difference in productivity. Finally, productivity has to pay for all this. And the same is in the infra that we started designing cold systems. We're saying that 45, if it has happened once, it will happen 50 hoega. Put 5 lakh rupees more today in the design without knowing what is the factor of safety. Can we start putting that infra at a number which is higher, because this is the direction. You can't get wrong in the direction now. Direction is never going to go reverse.
And so can you do that infra? Can you do that with the behavior to the extent that you can influence? We started saying that the food that is served is also not heaty. So start giving hydration, water, compulsory. There is an awareness program being run that, after every hour you have to drink some water. Otherwise, when you're working, you forget typically, and then you start just fall off. So a lot of work by the HR teams because they started seeing. So everything when you start linking to the productivity, that language is understood by everybody. Not only the government obviously understands it, but at a company level, you have to start getting into the micro stuff, and it is very granular. For example, I don't know how many of you know, trucks did not have AC cabins once upon a time because the driver would sleep off. Can you believe that? This was the logic. I don't want to again give names, but this was the logic. Finally, obviously, the entire industry worked and we kind of shifted. Ministers have also obviously played a role in it for those of us who are chasing that. So for us, I think we have come a long way. The productivity is one common theme around which everybody will pay their share. Why somebody has to benefit from that productivity. And same way should be, I am assuming the insurance will also link to that productivity that finally my premium will go up if I am not careful. But for any risk which is beyond us, we should be a part of it. The larger the system, the cheaper will it be for all of us. Coming to the finance part of it, most of the foreign funding, at least till maybe 3-4 years back, you had heard of green finance, etc. It has gone in a tailspin, but all our investors, which are all private equity investors, have very stringent ESG guidelines, and all our money comes with a certain set of reporting, and therefore some of it, call it incentive, call it disincentive. My park is measured 24/7 on what is the kind of work I'm doing in terms of greenness, or where am I, what are the new projects that I'm doing. Obviously lights, where we have skylights 4%, we have LED, 100% LED, we generate solar power. In fact, one of the reasons why a conference like this works is that a park like ours can become self-sufficient in even cooling. Not only will we generate electricity for others, we can also give it back to the community and around that place, because I have a capability of generating 350 megawatts across all my parks, only on the roof rights. Now, assuming I have a community system which I work, then I give back this so that even if there is heat, I also provide cooling solutions. So there are a lot of ways in which a self-sufficiency can be planned, and that is one of the decentralized generation, etc., which was being discussed in the morning, that these are the kind of policies which I'm assuming all of us are intelligent people will have to arrive at some such solutions, which have never been thought of because we have never faced this kind of a situation before.
True. And
can I make 2 points if
yes,
your
sure,
time
please,
permits?
please.
Not a point, basically, I was just sharing he spoke about logistics, trucks and other things. 2 points I'm trying to make. For example, we'll have to create solutions will automatically incentivize. I'm sorry, I'm insisting on that solution. So for example, I don't know how much of you know, we import almost 50% of the rubber requirement in India. We still import that, more than 40-50% of rubber requirement. So our tires, unless we start recycling it, that import will not go down. And most of the tire otherwise get burnt out, and oil is generated from that tire, which are the most polluting and heat generating methods that are available globally. And most of the tire gets that kind of treatment in India.
Yeah.
So what we tried to bring in was tried to focus on bringing in the extended producers responsibility in tire. So there is a roadmap now. Now every tire company has to minimum go on adding certain percentage of recycled rubber tire which is generated from the used tire. So that automatically became a incentivization. So the whole industry started coming up to very environment friendly reusing the tires and then crushing them and creating crumb rubbers. Then a solution was found to add that crumb rubber to the bitumen. So there was a further solution available. So so we created a value in the entire chain, because the entire chain has some value, right? From the steel that is steel that is taken out from the tire to the crumb rubber to everything. So there is a value to it. So then naturally it became a whole sort of industry, and government didn't gave any financial incentives. Government only created a regulatory framework. So I think that is something, the example I shared, because those kind of regulatory frameworks can help create the whole lot of solutions, right? For everything, from the industry to different adaptation of those solutions. So for example, nobody thought of crumb rubber 10 years back.
Yeah.
But today crumb rubber, CRMB, as they call it. So modified bitumen with crumb rubber is the best bitumen available for, infrastructure. So, those kind of solutions will start coming in if we try to focus on. Added to that, for a country like us, we still have a lot of infrastructure deficit. And when we have a better infrastructure, overall impact on the energy usage goes down. Why I'm saying this? Again, I'll go to the logistics sector, which he mentioned about. So I was in one of these truck owners conference, lorry owners conference, and they gave me a data that their per kilometer usage of tire, a tire is burned out because of the usage, was earlier around 26 paisa per kilometer. It has gone down to 16 paisa per kilometer. So their efficiency gone up. Just because the infrastructure is better, efficiency has gone up. And just because efficiency has gone up, use of tire has gone down. And therefore, the number of tire used per year by a lorry or an operator has gone down. And therefore, the overall, ultimately, climate resilience is also about using less everything, whether it is energy, resources, everything. So I think those kind of things need to be looked at.
Thank you. So now that we are in the more optimistic side of things and looking at solutions, maybe we should go more towards that. And it would be great to hear from each one of you all. And I'll come to you, Mr. Gupta, first. In terms of insurance, each one of you all are experts at your field. When it comes to especially heat resilience, since that is the one problem that we are looking at tackling or talking about, how can the insurance industry, for instance, what is it that is a low-hanging fruit or a solution that you can think of that they can do easily in India, and they should, to help mitigate some of this pain?
So, parametric insurance is now a buzzword, but it's still not as widely sold and serviced as it ought to be. But it makes servicing and assessing of any triggers resulting from climate challenges, including heat, much more easier. One of the early experiments was, of all the places in Ahmedabad, you have this Seva, which you would have heard of. Oh, is it? Okay, so nice. Good to see you. So you would know how that works. And a lot of women who are the kind of gig workers there were protected by severe heat. When the temperatures go beyond, say, 42 or 45 degrees, I'm not sure of the temperature level, they need not work. But because of that trigger, their revenue or whatever income and the allowance is protected. And that's just a small example, but that became like a rub-on for others. The other thing is, and which is an irony of India, and I'll leave that thought rather than just keep talking about parametric, but there is a challenge with parametric. A lot of, like someone was talking today about how the data and analytics would come from, say, a NASA or NOAA. They have virtually, they have an agreement with various agencies and labs who provide them that. They churn the data and then supply it. So if there is a trigger which should get you that claim or that indemnity, you have that reliable data, because if it is stamped by NASA or NOAA, it's not that it's an American data or American process thing, but it's a reliable reliability, which is the key, and objectivity. So that is great. But today we are seeing challenges with those two agencies, NASA less, but NOAA more, and that could have challenges here. So we need to do something about it here, having that started and needing to scale it. The other thing is, in fact, I need to talk to Aarti about it, because there's another COP coming, and I know last year she was there at the COP 29, and India's position has changed by its sheer trajectory of growth. And we could be number 4 in terms of GDP, which is not a great way to measure the well-being of an economy. But having said that, we are racing in that direction. So a lot of climate triggers that should have been taken care of by the UNFCCC's loss and damage, pushes India out of it. So China got kicked out of it for obvious reasons, but India has also now come into that region. So we need to do something about it. So that makes it even more compelling to address it. So we have a large population which is poor and which cannot afford insurance and will not get the benefit of even subsidized or socialized schemes. So we need to do something, and that's where some kind of a mix of that loss and damage and parametric could come into play. And maybe the SEVA model could be a perfect example. I mean, there are others who are doing it, like for rainfall and for hurricanes and earthquake and hailstorm, stuff like that. So all these triggers which impact the poor people or which impact the marginal part of the population can be looked after.
That was a great point. Maybe, Bhargav, you'd like to talk about your sector very briefly, and we'll take a couple of questions before we wrap up.
Just a small point, which probably part of repetition of what I've been saying, that one part, as Mr. Gupta said, that obviously the international pressure through whether it is regulatory framework or through an international cooperation framework will push us towards more climate resilient and looking at policies and framework. But a lot of sensitization within is also required, both from the industry side and both for the policy maker. So I'm sure, initiatives like what you have done, similar such initiatives, similar such constant kind of reminding us all that this is not an option now. It's a compulsion. So that kind of, I think, sensitization is much required. Both of my co-panelists have said, for example, infrastructure will also have to be planned for probably 45 degree.
Yeah.
Designed for 45 degree, 50 degree, hailstorm, water logging is something which we have been seeing everywhere in our infrastructure, right from our airports to ports to, everywhere. So all those aspects will start coming in if those, sensitization happen, that it's not only about one-off occasions, they are not one-off incidences, but we need to look at the impact which climate, radical incidences that are happening in weather conditions, extreme heat, extreme monsoon, and all those things, that need to be a very critical component of our thought process, right from planning to everything. And then if it becomes our part of our critical component of our thought process, then I think other things are easy to follow in it, whether it is in terms of budgeting for those requirements, getting inputs for designing those requirements is a little easier job, but making sure that we want to do it. So sensitizing, I think, is a very critical component that we need to do at every stage, at every level.
So the trajectory, sorry for a moment, the trajectory that our economy is supposed to take. I had the pleasure of talking to one of the chief economists of IMF, who understands India very well, and he said your country has to still build 80% of its infrastructure. Yes. For going up to 2100.
Yeah.
So look at it more positively, that you can really build a resilient infrastructure if you want to.
Yeah.
So
we have an advantage of doing late. So we must use that advantage to our.
That's a good way to look at it.
Yeah, so
Devin had a point.
Late mover advantage is always a good idea.
Yeah.
In our business. And one of the things that I'm very optimistic about is that whatever variables, and one of the reasons why I'm spending time here today is that all the variables which are known here already in this room, believe me, not many people outside this room have not, I'm talking of the decision makers in the top 125 companies also, understand that.
Correct.
Some of that responsibility, because of being at the victim side, is fallen on us. But I would say that if we scale this up, and let's say that all the decision makers who are so-called in the money side, they all understand money much faster than all of us.
Yeah.
So if moment you put a maths to it, which is what I was saying, productivity to it, it is very easy to convince a top management of any company that I deal with right now, and I tell them, you will lose this, and I'm giving up your contract. Nobody else will also take, and I'll also ensure that no insurance will cover. Believe me, in 30 seconds, he will decide and say, okay, well, whatever you are saying is right. But that somebody has to do it. If there is an institutional way to do it, which is what a regulation will be,
yeah,
we would start seeing much better and faster results. And India, that is one faster way to implement anything. कि कल से ये कर देना, kind of, then somebody will figure out कि कैसे करना है उसको. That ability supported by all the work that has been done. I saw that report today. I have not yet seen it. District-wise heat map, I had never seen before in my life. I wish it was known to me 5 years back. The same thing that we are discovering today, if we would have known 5 years back, we would have invested. And at least some of the investments would have been more logical. Anyway, we are forced to invest. When you start losing inventory, you will anyway be investing. So it's better that you know this and you start investing ahead.
Yes.
So I think investment is not a problem.
Absolutely.
The knowledge and the implementation cycle, which takes long in India, that's, I think, one of our DNAs. If we bring that up faster, I'm very optimistic that we'll be able to do most of the stuff that is known to the world. What is unknown, we can't plan for, right?
Absolutely. Absolutely.
For that, there is insurance.
In insurance, we trust.
I hope so.
But thank you so much, gentlemen. This was such a lovely discussion. I'll just throw the floor open for one question, maybe. Does anyone have anything to ask? Yes, sir, please. Can someone reach in the mic?
You see your India Heat Summit, shared solutions. How many are willing to share? See, India is a developing country. 80% of the world's energy is consumed by 20% of the world's developed countries. These climate problems, developing countries hardly contribute in single digit. So it's a sort of negligible.
Yes, sir.
And the very big elephant and big cats, they are withdrawing from the COP summit and all. They are not willing to participate. Who are responsible for the major contribution of this climate problem?
Yes, sir.
So unless they are taken into account,
yeah,
what is the use of discussing here?
Because we are an independent country that can take our own decisions.
So
With
we
our
are
own
hardly
systems.
we are hardly contributing to any.
But what is your question?
Yeah, exactly. What's your question?
Question is this only: we are not contributing much to the climate problem.
We are the world's 4th largest polluter in the world, with due respect. Now, so we are not a nobody in that space as well.
But who will these SDGs to 2030 is not going to be achieved.
So maybe
Your
that
point
is
is
not
very
the-
valid.
yeah.
Your point is very valid. And most of us agree that everybody will have to contribute more, including the bigger sharks. So I agree with you, and we all will agree. But that doesn't mean we should not do anything. They have to probably do more. We'll also have to do something.
They are the big culprits.
No, I agree. As I
Fair,
said,
fair.
thank you.
Thank you so much. Anyone else? Yeah. Okay, this is the last question then.
It's a great question, actually. So I'm happy and I'm disappointed there because they know what the problems are. They know what the problems are. They know what the solutions are. And I would, since you raised it, I don't know whether you have any association with the actual profession, but one particular body, and I've been writing about it and interacting with them, is it's called IOFA, the Institute and Association of Faculty of Actuaries of UK. And please see their website and what they've done. In fact, they're championing the cause of what I was saying about PIC, the Potsdam Institute of Climate Science, the planetary boundaries that Dr. Rockstrom has conceptualized. They have brought in a concept of planetary solvency or insolvency if we don't act. And that's a very well articulated thing. It's not rocket science. It's something that, since you have raised, I would suggest others as well to look it up. And if there's anything you want to discuss further, we can talk it offline, or you can reach out to me. It'll be a pleasure. So actuaries are doing things.
Thank you.
And they are not doing.
Thank you on that mixed note. If I can request Karthik to please wrap up today's session.
Thank you to all our speakers. Archana, I would now request you to present mementos to the speakers.
Okay. Thank you.
Thank you, Dr. Thanks so much. Yeah. Thank you.
So can we also have a group photo, please?
Yeah.
Thank you once again. This brings us to the end of the day one. Thank you for staying with us through these critical conversations. We now look forward to welcoming you tomorrow. That is May 28th on day 2. We are starting at 10 a.m. tomorrow in the same Kamala Devi complex, India International Center. Have a restful evening.
Yeah.